I'm gonna wait. I'll wait. You let me know when you're ready, then I'll start. 'Cause I have no visual of what's happening online if the stream is live or anything like that. I'm live. Hi everybody. We'll wait till actual 10 a.m. and when I get the go ahead, then we'll start. We have about a minute, then we'll get going. I'm just waiting for the go ahead. We good? All right, let's get this going. All right, morning everybody. Morning. My name is Dan Nagel. I'm a software engineer, and I have a presentation about software testing. Before I dive into this, I want to get a read of the room real quick. How many of you are currently or aspiring to be a software tester? Software testers? Okay, that's fine. That's the basic.
I think pretty good. I've been a software tester since 1995.
There we go.
A lot of other things.
Right.
It's always part and parcel of what I'm about.
Right. All right. Part two of the question. How many are currently employed or aspiring to be software developers? There we go. Okay. Now. Retire. Congratulations. Now, what if I told you that the most money I ever made was software testing, not developing? It's true. Now, with that in mind, how many people are now thinking, maybe I should give software testing another look? Get some more hands up? Okay. There we go. All right, so this presentation is near and dear to me. Software testing is a big part of software development, and this is focused entirely on software testing. It's oriented towards college students, but I know there's some seasoned professionals in here. So what I did was I tried to sprinkle a few things for an intermediate, handful of things that are advanced. So my goal is that everybody in this room and online will hopefully take away something, even if you've probably seen 80% of this content, because this is basically best practice on software testing. Inside here, I have little things sprinkled. I call them code breakers, where it's basically, if you're a software tester and you add this to your test set, you're basically going to guarantee to break the code. Then you can take that and complain to developers and say, hey, what's up? So that's code breakers. We'll start with what I call the classical approach to software testing and development. It's probably what most of y'all do in college till you learn, the ways of the pipeline and you get inspired. So then I'll go into the pipeline development, and then I'll show you a few little tricks that you can do. Who here has ever committed a syntax error? When I'm done with this presentation, you'll never do that again. I'll show you how. All right, let's get this going. It's about me. I'm just going to breeze through this. If you want to find out more about me, you can look online. Hope has a nice little blurb, but I've been doing this for 20 years. I've written 2 patents. I've presented at 30 conferences. I invented a semi-famous open source project that gets used everywhere. So I've done a lot of stuff. Look me up. I'm mostly on GitHub. I don't do much social networking, but I am on LinkedIn because in my industry you basically have to be. So just go there if you want to look up more about me. And we are at the first code breaker section. Near and dear to my heart. Now, question for you all. What time is this? So I admit I struggle with 24-hour time. Um, it's a thing like once you take calculus, you forget how to do arithmetic. So I have to kind of do a little minus 12 to get into my mind about what's going on here. But it's 24-hour time, military time. That is hours, minutes, seconds, 23, 59, 60. I want to know what time that is. Okay, so a couple choices. Um, this is midnight, right? So the 60, that set that to 0, carry the 1, that becomes 60, becomes a 24, so 2400 hours, which is actually 0 hours, which is midnight. Midnight. It says it's midnight. This is just midnight. It's midnight with extra steps. Basically, that's what it is. So what we got here? Midnight with extra steps. All right. Other choice. It's invalid. Like this timestamp does not exist. That 60 should have never happened. Like it should have gone 59 to 0, and it's an invalid timestamp. So whatever system this was fed to should have flagged it as an error and basically gone into whatever failure, recovery, retry mechanism that's appropriate, whatever system. I don't know. Maybe you toss it out completely. Maybe you go and request a refetch or something. Invalid. This is invalid. We go into some kind of failure mode. Votes for that? Votes for that? Both answers are wrong. What if I told you this is a 100% valid timestamp? Would you believe me? It's true. So, 10 years ago, the NTP servers, Network Time Protocol, that's what keeps our clocks in sync. The governing body for it, I forget the name of it, declared a leap second. That's what this is a leap second. Yes. It happened 10 years ago about this time. The NTP servers fed that down to the internet, this timestamp, and broke like 2,000 websites.
I remember that.
Because they didn't know what to do with that. So either they threw it out or they didn't know what to do. So this is an official timestamp because it came from the NTP server. That's the source of truth for all our time. Now, since then, Google has now stood up their own NTP service, and they promise, this is their promise, if there's ever a leap second, they won't do this. They'll instead take that extra second and smear it across 12 hours. So the bonus second will basically be 2 milliseconds off till it all catches up onto the next day. So if you're a test engineer or a developer, or you're building your test set, and you're working with time, which happens all the time, take that, put it into your test set and see what happens. And when the system breaks, which it will, you can go to the developers and say, hey, what's up? And they'll say, that timestamp's invalid. And you'll say, no, it isn't. Or you can say, it depends what NTP service are you using. So anyway, that's the first code breaker to put into your back pocket if you want to watch everything break. So keep that in mind. Let's get to the classical approach of software development. I used to call this the wrong way, but that's not right because, I mean, millions and tons of very successful software projects use this technique very successfully, and but there's problems with it, as we'll see in a minute. So the way it's typically done, without, if you're not inspired in the ideas of the pipeline, is that you write the code, you test the code, write the code, test code, and it's good. So like a bug comes in, you replicate it on your desk, write, test, the bug is now gone. You fixed it. You create a patch, right? Then you toss it over and the QA department catches it. And what they usually do is they have the previous version running. And the bug is this. They install your patch, the bug goes away, everything's good, finished, ship it. But there's a problem here. What's the problem? The bug comes back. How many, I know you're a seasoned professional, and there's a few of you in here, whoever has ever heard the phrase, I thought we fixed that. Right. So, my friends, there is a better way. We call it unit testing. The way unit testing works, the idea is behind this. You flip the script, basically. So what you do is a bug comes in. Instead of just replicating the bug, you write a test, a unit test that stimulates the features in your code to replicate the bug in code. And then once your unit test is failing because the bug's still there, you iterate on your code. So you code, test against unit test, code test, unit test, it's passing, the code is fixed. And then what you do is you check in both the code and the test, the two go together into the repo. And the idea is that once the bug is fixed, because the test exists alongside of it, it stays fixed. And then that now gets hooked in to all your regression testing, versus before you would have to do all that manually. So that's the idea behind it. Fix the bug once, and with the test, it stays fixed. Now I'm going to show you an example here real quick. This is a very simple example that works with Python. You can start using this right now. So, fans of Python? I love Python. Throughout this demonstration, I'll be using Python, and it's more because it's just a very nice, easy to use language. All right. So see here. No, you can't see this. You absolutely cannot see this. Well, this is going to be tricky. Okay. I did not anticipate looking over here. All right. So what we have over here is, this is the way I like to develop the code, particularly with Python, because the unique quality supports this kind of development. And what you basically do is up at the top, you write whatever your function that you're working on. Python, we call these modules. If you're familiar with Java, classes, C++ classes, Python, it's modules. It's all basically the same stuff. And up at the top, you have whatever module function you're working on. So here I'm summing up a list, right? A list goes in, add them all up, and then output the result. Very simple. Now, below that, I have your unit test. I have a test set, 1, 2, 3, 4. That's my answer, and I sum it all up, and I output the answer. So effectively, what you're doing for every single module or every single class, if it's Java, C++, or what have you, down up at the top, you define it, down at the bottom, you test it, and eventually you'll get a collection of these. So let's run this and see what it looks like. I'm just going to duplicate my displays because this will be a whole lot easier. All right, am I on both now? All right, very good. This will be a lot easier. All right, so Python, unit testing. Nope, wrong directory. So, as we expect, Now, every module, code at the top, test at the bottom. Now, I can see what you're getting at. I can feel it. You're like, but Dan, I've got like 200 classes and 200 modules. I can't simply just go through and run, the main routine on every single one of these. That's highly inefficient. And you're absolutely correct. That's why we have a test framework. And for Python, the one I like to use is called PyTest. I love PyTest. And that looks like this. So once you outgrow code at the top, main routine at the bottom that you run, you start hooking it all together with a framework. And for this, I use PyTest. And here's what it looks like. So you can see here, I imported unit testing. That's this file right here. And I've imported some list. And then if I had more stuff, like maybe I'm building a client and server, I would do from my class import client, import server, and then instantialize all of these and just start banging them together to find all the flaws and test it out. So here's my unit test. These are all the various test sets you might be interested if you're going to sum up a list. Test all the positive integers. Test all the negative integers. Test an empty set right here. Always test the empty set. test a single element, test max set, which I've commented out because time. But you would have that in there because this would be running and you wouldn't be too concerned about time. I'm going to throw garbage into it. Be sure you test garbage. See, the problem is like maybe I don't support inputting garbage, but there's a workflow to where the user might be able to submit garbage. And you at least want to know that you will handle that in the proper way. And it is possible, like with all these tests, that you'll say, hey, I broke the system. And the response would be, we don't support that. And maybe that's okay. Like it's possible that this is just something you're not going to support. And if it pops up, you'll handle it as is because it's just too much resources, too much rework, too much refactoring to support it. But you at least need to know that the problem exists. And that's what this would be doing. Also, make sure you test none or nil. That will always break you. And I have that test in here. For you Python fans, who have used PyTest before? Yeah, get very familiar with PyTest. It has other unique qualities, which I'll show you in a bit. So we'll see what this looks like. All right, it ran all my tests, had a very nice report, and it can just scoop it all up and let you know if something fails. It's beautiful. Now I got to do Command Shift F5. There we go. All right, next code breaker. Y'all struggled with the previous one. How often do we have a leap year?
Every 4 years divided, but not those divided by 200.
No. At least a handful of you are on the right track. So it's not every 4 years. So if you come across a developer who is writing their own calendar system, first just go ahead and smack them right there. And then and then feed this data set into them. I'm gonna show you something. It's not every 4 years. So hopefully you can see my calendar down here. You can sort of see it. I'll narrate. So let's scroll to the year 2100 and see what we got right here. All right, go to February. Up. My leap year's gone. That's weird. I like I already said I'm bad at arithmetic. Like so let's add 4 years. Like I mean I can't do arithmetic anymore. I just can't. So 2104. Pretty sure that's +4. Leap year came back. Oh my God, that's amazing. The actual math is thus so. It's every 4 years, unless it's divisible by 100, unless that is divisible by 400. So year 1900, no leap year. Year 2000, yes, leap year. That was a once every 400 year event, by the way. And year 2100, no leap year. Because the problem is that we don't revolve around the sun every 365 and a quarter days. It's more like 365.224. I think that's pretty close. So every 100 years, we're off by a day. I mean, that's the Julian calendar. Thanks to Julius Caesar. Yes, that Julius Caesar. And then about 1,500 years later, we're now off by like 2 weeks. And then Pope, I think it was the Gregorian calendar, made the leap year tweak. So every 100 years, we drop a day, but every 400 years, to get that 0.4, 024, we add a leap year. So our calendar should be good. We'll be off by a day after 3,000 years with that one tweak. But that's all nice. But feed the year 2100 February into your data set if you notice an engineer has attempted their own calendar. Now, with that said, it is 100% accurate response that they will reply, Dan, that's great, but I don't care about 75 years from now. And that may be a valid response. Like this system, you don't expect, to support to care 75 years from now. You're like, okay, modulo 4 it is. And you're good to go. So that could be a response. Typically what this will break is like finance systems, like think 529 college funds or things that extend out, pretty far. Already the Y2K 38 year 2038 problem, y'all can look that up. That's already breaking some mortgage calculators because that's now less than 30 years from now. But this is a fun one to shove in there because like you don't really think about that kind of stuff. And since the year 2000 was the surprise bonus leap year, then it's not, people assume that it's always going to be every 4 years. So that's the code breaker number 2. Now, if you're upset that I had 2 time-based code breakers in here, I'm not going to apologize. We could have an entire conference dedicated just to problems with time. Another example. How many months are in a year? I like how everybody's quiet. It's not always 12. It's not. Any of you ever worked in finance or accounting? A little bit? Okay. So it's rare, but it exists. But over there, sometimes it's a 13-month calendar. So what it is, like accounting and finance people, they like everything to be nice and clean and even and make sense and no oddities and bounce between 28, 30, and 31. They hate that. So they'll take a 13-month calendar with 28 days a week. So that's 4 weeks, all the months and days of this weeks are the same because, 13 times, I forgot to do math, 13 times 28, that's 364, very clean and even. Then they have one bonus day, for reconciliation or what have you, or maybe they actually toss in caffeine with their half cap. I don't know what they do on that day. Probably pretty wild. Now, you all as a developer, what are you going to do with that bonus day? Where are you going to put it? That's it's all fun stuff. So yeah, 13-month calendar in finance, it's pretty wild. All right. Other frameworks. Oh, I did it wrong. Here we go. We saw PyTest. There are others. What I recommend is that if you, whatever language you're working in, that is the framework I recommend that you use to at least get started. Every major language, every big environment typically has a framework associated with it to help your unit testing. JUnit, that's for Java, and I think Kotlin. It's been a minute since I've worked on Android, but I believe Kotlin and Android Studio are still using a variant of JUnit. Mocha is for all you Node.js people, and they recently added support to TypeScript. If you're still using JavaScript instead of TypeScript, I recommend jumping to TypeScript as soon as possible. It'll make development a whole lot happier. PHP unit. I know PHP gets blowback, but they've dramatically improved in just the past 5 years. If you're working on a WordPress site or Drupal or Laravel or something of that type, PHP unit's really nice. Google Test is what I use for plain C or C++ for anything that typically doesn't have a C or C++ framework library to go with it. That's my go-to. XC Test for iOS development. I think as of recently, Swift Test has now completely supplanted XC Test. I'm not entirely sure, but that one's been around forever, and we saw PyTest. So just keep those in mind. What I really like about PyTest is that it hooks into all the other stuff, because I referenced this earlier, but what's better than a full end-to-end system test? A full end-to-end system test that is automated. Now, it is painful to go through and just manually run your test. Instead, what you want to do is you have another computer running it. So you write your code, you commit it, you push it, and then all those series of tests just run automatically. These are the big ones that I want you to keep in mind. Azure DevOps, if you're in a Microsoft shop, it hooks in really well with that. Jenkins, I see Jenkins all over the place. It is really nice. I love Jenkins, good general purpose one. CI/CD for GitLab, that's the one that I'm most familiar with. I work in a lot of secure environments, so we can't host our stuff in the cloud. So we love standing up our own private GitLab and Jenkins. That's how we do. Atlassian has Bamboo. Weirdly, I don't know why this is, but I see Jira and Bitbucket all over the place, but they don't use Bamboo.
Bamboo's been going for like a decade. It's they're deprecated. Yeah, I mean, but it's really snuff. I mean,
Really? Well, that would explain it. I just wonder why, we got Jira but not Bamboo. Well, there you go.
That's what they call it.
Okay. GitHub Actions. Now, oddly, I know it's odd, like Azure DevOps owned by Microsoft, GitHub Actions owned by Microsoft. And you can now connect the two. You can have your GitHub call Azure DevOps. It's all wild. But anyway, it all works fine.
You're missing JetBrains Team City, which beats the
There's only so much room on the slide. Now, for all you aspiring developers and test engineers, since you all like testing now, because I told you actually can earn money with testing. If you're all aspiring, in your next interview, find a way to casually name drop one of these, and you'll get a job offer. It's true. They love hearing you talk about this kind of stuff. Let's see an example. I'll be using GitLab on top of Ubuntu, using PyTest, all free stuff that you can use right now. If you want to start adding pipelines to your own stuff and you don't want to sign up for an account, you can do exactly what I'm doing right here. Let's see it. So, come on now. All right, so I have my runner running. I have a GitLab running in the background. This is a VMware Workstation Pro. I have a paid version because I actually use commercial development. But if you're a student or a hobbyist, they've now made this free, so you can just download and start using it. I've been using it for like 15 years. It works perfectly fine. There's also VirtualBox and all kinds of other tools. And of course, Ubuntu is free. You just download, install. GitLab, they have a little helpful guide to get you going with the official version. You can download, apt-get and all that good stuff and be up and running in no time. Start to finish, maybe an hour, and then you can get your pipeline going. So I'm not going to submit the code. I'm just going to instead show you what it looks like, because there's really not much to see. It's like it just appears and then done, and it takes like 5 seconds. If I had a more involved test to be more useful. So here are code commits that I pushed when I was working on this. This one passed. And there it is. Does that look familiar? That's what I ran on the command line. So I pushed the code and it just did it all for me. Let's see what this looks like. And let's go back a couple. And it's called a GitLab. There it is. So with pipelines, what you do is you create stages. And so this is you saw it earlier over here. This was my test stage. I called it PyTest, and that's where that name came from. And you can just keep making more and more stages to get you going. So you'll probably have like a compile stage to build everything. Then you'll have a test stage to test everything. They all flow into each other. And then if the test works, then you'll have like an integration or make an installer stage, all the tests pass, make an installer. Then you'll have a deployment stage where you take it and you shove it to whatever service that you may deploy. Like me, I use Artifactory a lot to hold all my artifacts, but you may shove it up to some other cloud service to where the developers can go get it. So, and it's all done automatically. You just write the code, hit submit, and then computer in the background just turns through it, and then ding, it's ready, and you go and grab it. And the really nice part about this is that I don't recommend it because they get mad. You could basically just deploy thin clients to your developers because the back end is doing all the heavy lifting. They don't have to personally know how to compile the code. All they need is an editor, and they can just work. And the back end handles everything for you. So I really like it. Next code breaker. It's not about time. I promise. I promise. There's only 2 of those. It still went back to the beginning. My shift key's not going. Did you know you can have emoji file names? Because I didn't. What a horrible idea. Like a thing I didn't know I needed and I still don't need. But I'm going to show you how to make one. I think so. I'm not entirely sure. I mean, there's all kinds of problems. Like, first of all, like it renders differently on every operating system, you know, because they all have their own implementation. But the way you make one is you create your new file, then you hold the Win key, the Windows key, and you hit dot. And there you go. And now we'll get a bunch of emojis going on over here. You can already see that it renders kind of odd right here. Let's open Piracy. Yeah, that'll work. So, yeah, there we go. Emoji file name. Now, this already breaks some systems, as you can imagine. So, I'm going to show you. Let's open up my Get Bash shell here. Oh, look at that palette nastiness. Get Bash is already struggling with it. Now, to be fair to Get Bash, I think they did fix this. I mean, I'm talking fixed it as recently as maybe last year. But that's basically how it's encoded, you know, that pile of stuff. So if you're at a system that accepts file uploads, which is everywhere, and you're a tester, create you an emoji file name and upload it and watch the system choke. Then you can go to the developer and say, hey, upload an emoji file name. They're like, why did you do that? You're like, I don't know, Gen Z. They'll probably do. You're like, upload your test, like peace. Like,
the variation on that is go into the product file and add some Hebrew or some other things, and then just save that to your material and find out which one of your warehouses are using older software.
yeah, there you go. Yeah. So the way I typically handle this is I sanitize the inputs. Like if it's like a character set that I don't want to support, I'll just change it to an underscore or a dash. Like I've seen a lot of those happening. If you uploaded this to a system I've written a while back, probably the entire thing would be underscore. But you need to be able to handle this, and it's quite possible that whatever system you're working on is not going to be able to handle it. So you have, yes.
If you just normalize everything to underscores, doesn't that introduce the possibility of like collisions?
Absolutely. Absolutely collisions. That's why you usually have a unique identifier associated with the file name that you map it to. So, good question. Now, emoji file names. Horrible idea. I'm not going to bother maximizing anymore because I messed that up 3 times. So, you can do more than just test. You can build, deploy, I already went through all this, but the other point I want to make sense is like you can have like one main pipeline and it spits off, jobs to other pipelines. So you can have your Windows, Mac, Linux, iOS all building in parallel on different runners. So you can have like this full up system of compiling and testing all going on once with just a single push. So keep that in mind. You just keep expanding your pipeline to all kinds of systems and save a lot of time. What's better than a pipeline? Or not better than a pipeline? What's a good way to help a pipeline? Not having to run the pipeline. I hinted at this earlier. Who's committed a syntax error before? Not anymore. Let me show you how. You'll never have to commit a syntax error again. It's called a git hook. It's in your git directory under hooks, and I'm running low on time, so I don't have too much time to explain it, but I want you to look up pre-commit hook whenever you get a chance. And what this does is every time I commit Python code, it checks to see which files have been modified, then it runs the pylint syntax checker against it. And if that passes, I'll let my commit in. If it doesn't, I'll reject it. So I never personally have to commit a Python syntax error. So let's see how it works.
Dan, when you said that larger companies would buy someone's stuff to make sure that we're not installing anything bad also. So we don't just use lint, we use a security scanner.
Right. There's all kinds of stuff you can shove into your hooks. This particular example isn't. All right, that looks like a syntax error to me. And let me try to commit it. So git status, git commit. We'll call this oops. Running pylint. Rejected. I just saved a pipeline run because it would not pass syntax errors. Now you can add more stuff in there, but I like to just stick with syntax errors because like you don't want to do git commit and basically waiting for a whole Python run. That kind of defeats the purpose. But a simple thing like, is this at least syntactically correct? You can do that ahead of time and not, consume a runner to make sure you're all good to go there. So that's pylint syntax errors. I'm going to skip the network code breaker issues and instead shamelessly plug my workshop that's coming up where I'll be talking a lot about, I'll hint at it. So I have a workshop coming up in I guess an hour and a half or so at 12:30, right around the corner. Well, I'll be doing some network troubleshooting steps. It's called Hacking Network APIs. It's free. What I'll be doing is I've got a Raspberry Pi network audio player, okay? And it talks to it, and I'll be reverse engineering the protocols to build up a separate system that controls it using my open source project called Packet Sender. So Packet Sender will be over here, got Wireshark over here, reverse engineering, recreating the protocols. Then that's part one. Part two is there is malware on the Raspberry Pi, which I'll be unearthing in part two. And then we can discuss that kind of problem. And the next phase will be part three, where I'll show latency versus throughput test by trashing my network. So, and that should be a lot of fun. So it's a 2-hour time block because like I know what you're all thinking. You're like, Dan, I've been listening to you blab for 40, 50 minutes. You know what would make Hope really special? 2 more hours of listening to you blab. Like, I know that's what you're all thinking, and I'm here to give. So find me over there, and we'll do all that. And looks like we might get out a little early, which I don't think is anybody complaining about. But my name is Dan Nagel. I I do conference presentations. I do open source development. If you have a conference and you think my presentation will be helpful to you, you come see me. I'm here all day today and at least half a day tomorrow. I hope all this was useful to you and that all your testing and software development goes well. Are there any questions? We do have a few minutes. Yes.
Do you have any opinion? So you talked about PyTest.
Yes.
Do you have any opinion on just using the built-in unit test?
That was slide number 4 or 5, but yes, that is absolutely valid. I love the built-in unit test. What I use PyTest for is when I want to string them all together into like one full-up system integrated test. And for me personally, PyTest just works really well for that because it hooks into all the other tests to build up a full, complete test system. You,
Do you have any opinions on methods for automatic test case synthesis, like fuzzing or property-based testing? The idea being to, I guess, instead of assert quality of it, or assert a quality given specific inputs and outputs, assert relations on outputs and inputs.
Okay.
I found that they can be a little like, I write them because they're practical, but like it's sometimes they utter interesting input cases, but sometimes you just run into like input space too big to generate reasonably.
all right, so the question is building out the test sets, essentially good ways to do that. And there are, what I typically do, there are a lot of resources online where you can basically say, I have this scenario, what's a good test set for it? And there's just like actual just GitHub repos full of this kind of stuff. So that's usually my starter set. Like you saw my like positive, negative, empty test sets right there. I actually just picked that up, like actually did a search for like what's a good test strategy for integers. And I'm like, and I actually mentally forgot, like, oh yeah, like the empty set. I mean, even I forget the stuff like that. So I basically just grab a set and start with that, and then as problems arise, to start adding to it.
You have a couple questions?
Yes.
In the chat room, so I'll read them. One, how do you see the role of AI-driven testing evolving in mission-critical systems where false positives or missed defects can have major financial or legal implications?
Oh
do
my
you
God.
think we're ready to trust AI for compliance-heavy environments?
All right. Well, I'll answer that by saying that I personally work in this very secure environment, so AI is just simply not allowed. So that's the stance I have for that. But as far as like AI-driven development for other things, I use it to help brainstorm. Like, for example, your where'd it go? Your pre-commit, this thing right here, like AI actually helped me write some of this. So like, and this is not going to my codes. Like I'm not worried about it. There's like no danger in my pre-commit, thing causing issues. And I can personally proofread this and it's like, yes, this does what I think it's going to do. So for like little snippets of help, like the pre-commit, like Mr. AI chatbot, I need a pre-commit hash to syntax check my Python. Boom, it'll help you with this. Or syntax check my C++. Boom, it'll get to this. Or Mr. AI, like I'm trying to build a data set to sum up integers. And like, so basically brainstorming and ideas. But I would never like just copy this big, huge chunk of code and just plop it over there without giving it a thorough read through.
Oh, and please repeat the questions for everyone and when they ask them in here.
Okay.
Thank you.
Yes.
On that same point, are you looking at integrating tools like SendGraph in any part of the pipeline?
I'm not familiar with that. It was the question.
Static software testing tools.
Static analysis tools?
Yeah.
The question was integrating static analysis tools. And yes, that happens absolutely all the time. Like tools like Fortify is a big one. I've seen these things hook into like Nessus network scanners. So yes, you basically just keep dumping tools and tools and tools into this, and eventually what's going to happen is your pipeline could end up taking like 6 or 7 or 8 hours or longer. And what you do is you basically set up a timer. Okay, run the full up Python overnight, and the developer push pipeline would be like an abbreviated pipeline that might take an hour. So you have like 3 or 4 different sets of pipeline, where the big full up one with the static analysis, the fortify, and all that good stuff, that'll be an overnight pipeline job. That's how you set that up.
And
But
you
yes.
parallelize, where you can. Because those things can all, these days you can stand up multiple instances of your system under test. And so just go ahead and run all those different tests in parallel.
So the other person was
Magic of
speaking
the
about
cloud.
standing up multiple instances to handle this stuff, to spread out all the jobs in parallel to save time. So you can have like one like VM over here running your fortify scan, another VM over here running your static analysis, another one over here, like just spread it all out to run in parallel. Versus me, when I said the overnight test, that was mostly if you're going to do it all in series.
I have one more question online.
Yes.
It's does writing unit tests before the code, as TDD purists advocate, make any difference than writing after?
Test before the code, and I would say the answer is yes, but I'm not a purist at all. So what I do is I basically write both at the same time, and as I'm writing the code, I try to keep in mind like the idea of how am I going to unit tests, where I don't code myself to a hole where I have to like back out and refactor a bunch of stuff to be able to get the unit test first. So no, I don't write test and then code, because like I'm not a purist. I don't really care. It's more like make sure I write the code in a way that can be tested, and basically the two just get developed together in my mind. So now the example I put in earlier where I mentioned about a bug coming in, that will probably be code first. Code the bug replication first, and then go code the test for the bug first, and then fix the bug code. So that's be where that idea would come from.
It can also help if you've written a detailed list of the requirements first.
Right.
To, if you have that, then you have the means to take that and turn it into tests,
So-
and then write the code.
So his idea was detail list requirements also helps. Yes.
So it can be challenging if you're trying to connect to a database or something like that when you're doing unit tests. So the typical way is using like a mock, right? So you're mocking out the database.
Yes.
I'm curious if that's how you do it, or if you have an
I
alternative.
100% use mock.
Okay.
I use mock all the time. Python has a actual mock library, and it is called mock. And then there's even variants of it called like I think magic mock is another one. So anyway, yes, that is exactly how you do it. You would mock the database to where, and you can get really fancy. Like you can mock the database, and like if you get this query, then just respond with this canned data set that you then parse. But so yes, that is absolutely how you do it. Is you mock out all the different network connection points. So you can basically what you want to do is you don't want to have to stand up a server when you're doing unit tests. Now there's two kinds of tests. There's one where there's a pure unit test where it's basically entirely command line. Then there is like the integration, what I call integration test, where you actually would stand up a real server, a real this, and your mocks go away, and now you're simulating real connections talking to each other. So there's two approaches. One is the one, your idea, where you mock everything. The second test, where you don't mock everything, and you run a real integration test. And I think we are out of time now. Are we? Yes.
Yeah, we're out of time.
We're
Well,
out of
actually,
time.
can I ask one question?
You want to ask a question?
I
Yes.
just want to ask one question.
You're allowed.
My question is about screenshot tests and how you feel about them. Have you run into them, and any challenges with
I
them?
am 90% back end, so I've not had to deal with screenshots. So I can't give you a good answer to that. I'm sorry.
Okay, no worries.
When I used to do it for, when I worked for a small shoe company called Nike. And what we had to do on screenshots, and we would forget it all the time, is there must be a date and time and system ID somewhere on the screen. Because people would take this, not the correct answer, and they're like, anyone can make that
So his suggestion is that if you do a screenshot, make sure you capture the version, the time, and the date along with your screenshot inside of it.
System ID.
And system ID. Make sure you get all the. Yes, that's a good idea.
Otherwise, your security people will tell you it's no good.
Okay. All right, we're done. Thank you. Find me in an hour and a half over there. Come to my workshop.
Say for the year 4000.
Hey everybody, get ready for William Hudson, who is giving a talk called Build a Tech Community in Your Neighborhood, One Hackathon at a Time. So give him a big round of applause. Yes. Great.
Thanks, Noon. Let me see if I can pull this up here. So I just want to start by saying thanks everyone for coming. And before I get started, I would like to invite everyone to just look across the room, maybe look across your shoulder and look at the next person next to you. And just remember that that they're present, that you're present, that you showed up today at Hope. And that's important. I think that's something we should be grateful for. So give yourselves a clap and give Hope a clap for another year. All right, the nervousness is settling in now, so I'm gonna take a minute, and I invite you to as well to join me and just like recenter. So a little bit of silence for a brief moment, and then we can get started. Maybe you can take this time to be just grateful for being here, or maybe you prepared the slides last night at the last minute and you just need some shut-eye. Okay, so my name is William, and I'll be giving a talk about building a tech community in your neighborhood, and how to start and how to get one hackathon at a time. But before we start, I just want to see how many builders we have. So just raise your hand. Does anyone like building stuff? Okay, so that's most people here. Well, so do I, and a lot of people at Flushing Tech. So today I would like to share with you my experience of how we built a thriving tech community in our neighborhood, Flushing, with short, fun, 2-hour mini hackathons. All with zero community organizing skills and with minimal resources. And then I'm also going to be excited to share some practical guidelines about how you can start one in your own neighborhood today. So my name is, so let me just introduce myself real brief. My name is William Hudson, and I'm an immigrant from Guyana, and I've been living in Flushing for about 5 years. I'm a software DevOps engineer. Any DevOps engineers? Yeah. It's always like 1 or 2 people. I don't know why. DevOps is fun. For about 20 years, I enjoy building a lot of stuff in my workshop, in my apartment. I like to stay active. I like to think a lot. And I like to volunteer mostly in civic spaces. You can contact me I have a website, whudson.gy. GY is Guyana's TLD, just FYI. As you can see,
You're
none
a
of
bit
this.
quiet in the room, so speak closer into the mic.
Thanks.
I can...
Okay, yeah, this is a little better.
Yeah.
And as you can see, none of this requires any organizing skills. Like none of my background has a lot of community management skills. And here I have the flag of Guyana. Here is me at the top of my head in the immigration court, where I'm volunteering at this organization called New Sanctuary. And pretty much what we do there is we help immigrants through their court systems. And there's a bunch of guys there with a lot of masks. They're being very socially distant. And then here, does anyone know what this is? Close. This is an F-47. Okay, I just thought it was fun. So that's enough about me. So what is Flushing Tech? Technology is at the core of our society, making tech communities important spaces where everyone must be able to participate. Flushing Tech was born out of the idea that local community impact can be powerful, scalable, and sustainable when it's easy, fun, and accessible. It's an experiment demonstrating how global impact can be unleashed by maximizing local participation. So that's sort of like the high level idea about what flashing tech is, and we'll get into more details in a bit. What is our vision? So this is hard to explain, so I decided to go with an analogy. Signal is a privacy-focused app that a few people enjoy, and if everyone starts to use Signal, the world becomes a much more private place. Nextcloud is used by some organizations and governments to exercise control of their own data. If every organization starts to use Nextcloud, the world regains ownership of its data. Does anyone use Signal? Okay, that's most people here. How about Nextcloud? Okay, that's about half. That's nice. So our vision, in the same way, is when every neighborhood is empowered with a thriving tech community, the entire world becomes a powerful, scalable, sustainable network of participants. So that's where we're trying to head. So why build a thriving tech community in your neighborhood? Flashing tech knows flashing. Locals understand community needs firsthand because we live there. Visiting participants experience the neighborhood and its challenges, so people come to our events and they experience flashing. Flashing tech directly experiences the impact it has on flashing. Flashing tech volunteers build for flashing and can directly see their handiwork being used in flashing just by stepping outside. So what you build isn't sent off into the internet and never seen again. You can actually see and you can talk about it with your neighbors. For example, a flashing tech volunteer who builds a web AR app to help other volunteers navigate to the hackathon might meet their users at a local boba shop in the next day. Boba because in Flushing there's a lot of boba shops. It's delicious. Anyone tried boba? Okay, a few people. The rest of you should really try boba. Flashing tech is as agile as flashing, which again is because flashing tech knows flashing. Flashing tech can react to changes faster than anyone else in flashing. Flashing tech is focused on flashing. Focusing on the neighborhood we know makes it much more easier to organize and manage with minimal resources. And this idea is sort of integral with how you can get started today. Because if you focus on one neighborhood instead of like an entire city, you get to focus on bigger impact in a smaller area without having to think about logistics in a wider area. So if you focus, if you narrow your focus, you'll be able to organize and be very nimble. So those are some reasons why building locally might be a good thing. By the way, disclaimer, I totally forgot. There's a guy taking photos. He's only taking of me. Okay. So how did we build a thriving tech community in our neighborhood? We started small. Way down in the corner there on the right-hand side is one of our first events. As you can see, it's very casual. People just came together and decided to build stuff. To get that started, we just invited folks with an online ad for a casual in-person tech meetup in Flushing, and people showed up. We tried many things at first. We tried networking events. We tried happy hours. I'm a big drinker. Any big drinkers? Good, very healthy. Talks and presentations, and we tried hackathons. Networking events didn't work. People networked and then they left, like most conferences. Happy hours were fun, but they weren't lasting engagements. Talks and presentations were passive, and they were only one way, sort of like me speaking for an hour here, keeping you from your lunch. But hackathons was the missing part that everyone liked. Hackathons struck a chord because they were extremely engaging, because they were hands-on, very hands-on, They encourage natural socialization because a big part of the hackathon is to form groups and constantly engage with other people. They were deeply rewarding because you get to take home what you built, and you get to help someone else build something as well. They were very informative. A lot of people come to the hackathons and they learn new stuff all the time. And very durable. People would build stuff and it wouldn't be isolated to that one hackathon. A lot of people continue building it with other people very long after the hackathons. So the experience of the hackathon, the events, last for probably a lifetime for a lot of people. So that's how Fleshing Tech started. And just to give you an idea of what the hackathon is like, the hackathons are bi-weekly, which means that it's an expectation that there is going to always be another hackathon to experience. It's very consistent, and people like consistency. And the way that it usually starts is there would be some. It's a very simple format, very bare bones, which is a big part of why it should be very easy for anyone to start. There's some welcome, and then there's some introductions. The introduction is super important because that sets up the stage for everyone to start engaging with each other. So everyone who shows up gets a chance to introduce themselves real quick. Then we go straight into the hackathon. We start ideating different ideas about what people want to build, and they would usually start with something that they heard about during the week, or some trending technology that they want to explore, or maybe they already have an existing project that they want to build. So people would just dump all the ideas possible, and then we'll start sort of like forming groups around the biggest ideas. I should have brought some water here. So once we have the teams, then we start building stuff. We spend like an hour and a half building whatever fun stuff everyone wants to build. And then after that, after an hour and a half, we present. And then we do some friendly competition. These are a little different than bigger hackathons where there's money, there's big prizes. These hackathons, they're small, but they're consistent. And the reward is the joy of building something, engaging with someone else, meeting new people, getting a new friend. So that's the competition. And then at the end, we get to close with some networking and enjoy our company. So it's very bare bones. Anyone should be able to do this. And we do this every 2 weeks in Flushing. So what happened 18 months later? Where are we? Right now we started on Meetup. We're mostly on Meetup. Anyone uses Meetup here? Okay, so a good chunk. We have about 700 people on Meetup. We also have Discord. Any Discord users? Okay, very good. Yeah, I was wondering if to use Discord or Slack. Seems like you can go either way. So we use Discord, and we have 100 people there. We have a lot of people active on Discord. And then we have about 10 people on average attending each event. And remember, each event happens every 2 weeks. So this is one of our events, and that's someone presenting. I remember that. That is actually someone who made a wearable with an Arduino. That was very fun. And they're presenting what they built and what they learned building it. So it's a very casual setting, but still very hands-on. We did 38 bi-weekly hackathons, and we're still going. A lot of people have a lot of fun. We have a 4.7 rating. I don't know if that's high or low. That sounds pretty high to me. And then we have about 140 projects built, again, because these hackathons are every 2 weeks. So there's always constant opportunity to build projects. Okay, I'm going really fast. I'm going to try to slow down. So that's what happened after just 18 months. And this is our experience now starting this idea. I imagine that as other people build similar hackathons in their own neighborhoods, it's not going to take 18 months. You can probably hammer a lot of this stuff out in 6 months, maybe. And maybe you'll get way more members in your neighborhood, depending where you are. So how do you go about building a thriving tech community in your neighborhood? And this is where I'd like to introduce something that we put together, the Flushing Tech Manifesto, with all of our learnings to help you get started from scratch. And it's very simple, it's direct and very bare bones, exactly so that you don't have to go through a lot of stuff, because we know that not a lot of people have a lot of skills in organizing these things. They just want to go to these hackathons and start building and engaging and having fun. So the manifesto is very simple, easy to use, hopefully, and it's open source. So if anyone has any improvements, we can definitely make it better over time. And it's published online for everyone to use today. So I'll give you a QR code at the end of the deck, but it's always at flushingtech.org/manifesto. And just a little additional thought here is that all the stuff we built was built in hackathons. The website was built there. The manifesto was built there. So that's one thing that you have, is that once you have your group running, you can build your own stuff, and people in your group are going to want to build stuff. And the idea is that, you build stuff and you share it with other groups in other neighborhoods, and so it spreads. It's really fast. So here are some things that you can find in the manifesto. And there's going to be, like I said, more coming. There's going to be way more improvements. There's going to be some guiding principles and values. There were a lot of content, so I didn't put them on the slides. But basically, there were a lot of helpful thoughts and ideas that would focus your, because when you have a group of people, there's a lot of directions that you can go into. So having a set of core beliefs and a compass, I think is going to help you. Again, this is there for you. Make use of whatever you can use, but it's there. We have some values we're not coming there to build something to ship it, a product. We're coming there to make connections, learn from each other, and have fun. So that's an example of a value.
I'm sorry, we're having an issue with the slides on the stream.
Oh, sorry.
So I'm just going to repower this.
So that's a blessing, because I think I'm going way too fast.
You're doing great.
Thanks.
Really good. Thank you.
Try rebooting this box here.
Okay.
See if that does it.
So
Hopefully your slides will reappear.
we unplugged it and we plugged it back in. This would be some nice time for some elevator music. Has anyone been to any other talks? Okay.
There are tech issues at most of them.
Can I ask you a question while we wait for it to read?
Yeah, definitely.
What have you learned on the other side of this you would tell us who want to organize things like this?
That's what the whole deck is about, kind of.
Alright, it's back. We can put a pin in that.
Okay. All right, let's keep going. Remind me though.
Yep.
Yeah. So here are some things that you can find in the manifesto. Some guiding principles and values. Some of the more useful things, practical useful things, are the roadmap and a lot of checklists, because again, a lot of us are not professional community managers. So a lot of these resources hopefully are going to help you get started right away. And I'll go into the roadmap and some checklists later on. There's a lot of tools that you can use right now, because we've been doing this for 18 months and we built some tools that might help. And we have a lot of supporting materials as well that you can use yourself. Again, all of this is out in the open. We're a nonprofit, and all of the stuff that we produce is yours. So some of the tools and supporting materials are things like the agenda templates, email templates to get your venue. I think that's going to be a big thing for a lot of people. It's actually super easy to find venues. You just need to go out and get it. So I think an email template is going to help a lot of people. We have social media, so you can use our profile descriptions, our posting templates. That's all yours. We're on Meetup, so you can use our event descriptions. Pretty much everything that we use, you can use. We have Vote, which is I'll go into Vote a little bit. Vote is also built in the hackathons, and it was built out of the need for some platform to manage all the ideas that are coming through, and for people to be able to vote easily on which idea they thought was the best. So it helps streamline a lot of the stuff so that people can focus on the hackathons themselves and focus and just have fun. So that's yours as well. That's open source. And a lot more. So as you build your own hackathons in your neighborhoods, I'm pretty sure you're going to come up with stuff that a lot of people can use. So feel free to dump that into the manifesto as well. I think I just went through this here. So, like I said, we have some event descriptions that you can use. You can use them on Eventbrite, Luma, etc. Because we use them on Meetup right now. Social media profiles, posting templates, and then Vote. This is a picture of one of our templates that we have a marketing committee that helps with this sort of stuff that they put together. We have a picture of what Vote UI look like. And then we have a picture of our Meetup page. So all of this stuff is there for you to get started right away. Like you can use this stuff today, and you can probably start organizing your next hackathon today. Okay, so this is a lot of stuff. I'll try to go through this very slowly. And it's pretty much the roadmap to help you launch. It's a roadmap to help you launch. Feel free to modify it and extend it as you need, because I know that each neighborhood is very different, and your environment is probably going to impact how you execute the roadmap. So equipped with a framework and the support that you need in the manifesto, I think you're ready to start planning your launch, which is going to be pretty much your first hackathon. The launch roadmap is broken up into 3 phases, which can be, as I said, resized as needed. And so in the first phase, you initialize your community, which I think most people can do in a month. We have a checklist, and the checklist is broken up into 4 weeks. And it's very well-paced. So in a month, I think you can get your first hackathon going. Next, your community can start scaling up over the next 2 or 3 months. And that would mean stuff like launching supporting events, like office hours, workshops, Q&A panels, and so on, in addition to the hackathons. You might start inviting community members to take on roles that you've been doing as an organizer, like hosting, social media, and moderation. And you might also start forming committees to distribute that work. And then for the next 6 to 12 months, you might start growing. And that's where Flushing Tech is at right now, actually. Now we're looking into delivering solutions for local businesses and developing sponsorship relationships and community partnerships. And this is going to help a lot of people who are in the hackathons right now sort of give back to the community, because right now we're building stuff that we just think are fun. But there's a lot of reward as well when you build stuff that has an impact. So I think this is going to help a lot of people really feel that impact when they're able to like give back to their local communities. So this growth phase is going to be very important for a lot of people. And then I put at the end there evolve, because I think once you're launched and you have something running, you can take it in whatever direction your neighborhood feels like, your local neighborhood tech community feels like going, and you're gonna just naturally, organically evolve in whatever direction. So that's the roadmap, and that's, I think, what you can expect in about from 1 month to like a year. Okay. So that's it. And I just want to end with that all of this is only possible with you guys. If you believe that a thriving tech community can make your neighborhood better, and that your neighborhood can make the world better, I invite you to sign up now. And there's a QR code to the manifesto page, and there's a sign up button there. And that's just gonna get us in touch, and we can help you get started, or you can get started right away by yourself. I also invite you to explore the resources to maybe host your first hackathon, and to join Flushing Tech. Flushing Tech is in Queens College in Flushing every 2 weeks, so you're definitely invited to just come by and see what it's like. So yeah, none of this is possible without somebody taking the first step and just running your own hackathon. I came up here today and I had to give this presentation. This is my first presentation. Anyone? Thanks. Anyone has a first presentation coming up? Okay. Well, you're gonna be fine. I survived all the way to the end, and the world is still here. So same thing. You're gonna launch your first hackathon, and you'll be fine. You're gonna have a lot of people support you, and a lot of people are gonna be better off for you having done it. So I encourage everyone to give it a shot. And one last thing is that I tried a bunch of stuff, like I mentioned before in the first slides. We tried networking events, talks, and so on, and they failed. And you might try stuff, and they might fail. But each failure, I think we all know as builders, is an opportunity to get better. And you can come up here one day and you can be teaching me the next time something that might be better for a tech community in a neighborhood. So look forward to your failures is all I'm saying. And then you can share it. You can share what you learned with other people. Okay, so thank you for sitting it out. I went through that super fast. And we have like half an hour for questions. So any questions?
Thank you so much. I'm going to be fielding the questions in the chat room. I want to ask the first question, actually, so I'm taking advantage of my position here. My question for you is, I noticed that there's like a voting system, so I'm assuming it's kind of like a democratic type situation, but I'm very curious about what kind of governance model that you're using, and what kind of things, like what have you explored, and what your thoughts are on that. Thank you.
It's a very good question. The whole point of the hackathon is to bring neighbors together. So the governance model is pretty much how you would want to live in a neighborhood. So it's based on a lot of trust. We expect everyone to help out in their own roles and develop their own ideas of how they want to be a part of the community. And being a part of the community means that you behave in certain ways that would help your neighbors. So in terms of voting, there's stuff like you'd be able to vote twice in the system, and we leave it up to people to do that if they want. The whole point is to be very casual, be very sort of neighborly in your groups.
Is it okay if we take one from online first? Okay, I have a question from the internet.
Can you use the mic?
Yes. The question from the internet. I don't see a code of conduct anywhere in that manifesto. Has that not been needed for Flushing Tech?
It's a very good question. And that's been on my to-do list for a long time. It hasn't been the need for a very long time. Part of it is because the space we use is in Queens College. And so a lot of the people that come there are in the space of a college. So the code of conduct is sort of implied, as opposed to like a more public space where people are not sure how they should be conducting themselves. But it's very useful to have, and it's been on my to-do list for a very long time. So I think that's going to be the priority for the manifesto next, is to add that. Because, you're going to be opening your own tech communities in your own neighborhoods, in your own spaces. And people might not know the best way to conduct themselves. So that should be a priority. Okay, good.
So I was curious, you said like at the beginning you put out an ad, I guess on Meetup, and then you also did socials and stuff as it went on. So like, how many people did you get from each type of thing? Like, is it really worth putting time into Instagram?
Thanks. Okay, so the question is, we've done Meetup and we've done social media, and is it worth doing one over the other, and which one is better? So the ad itself was on Meetup. Social media came afterwards. Meetup worked really well because a lot of people, that's where they go to when they want to meet people in group settings. And that's worked really well, and we use it right now because it works really well. So definitely you want to spend time in some platform. I think Eventbrite is going to give you the same results. Loom is going to probably give you the same results. And social media came afterwards. Social media was meant to keep the community up to date with what's going on in the group. Not necessarily to like bring more people in. However, it does a really good job at that. We have a really good marketer, digital marketer that really spends a lot of time and effort building up our social media content. Because what happens is that there's a network effect that happens. People see the content and they're like, oh, I want to share this to someone else that might be interested, and they might come. So I definitely think it's good to spend time in both areas, but for different reasons. Go ahead.
You mentioned
Okay.
having office hours and
Yeah.
office hours and running workshops. Are those currently internal to the members who are coming for the hackathons, or are those outward facing and serving the community?
That's a good question. So the office hours, So the question was the office hours and all these other events, if they're internal or public facing. So first of all, Flushing Tech is a nonprofit, and your groups are probably going to be public nonprofits as well. And all the events and all the resources are going to be public facing. There is no such thing as an internal membership group, I think. It's all volunteer based. And the second thing is that the office hours and the Q&A panels and so on, those are all volunteer run. So you might partnership with someone else. You might partner with a group as well, and they might have certain specifications like, hey, I want to invite a certain segment of the population. Like, for example, I remember we did one workshop for seniors, and so you might lean towards trying to get the marketing out to attract more seniors. But other than that, most of the stuff that you do are probably going to be public facing. The person in the back had their hand up for a while.
Oh yeah, so what I wanted to ask was, so like I've had like the experience trying to get stuff and get started up, but one of the
already have like a pre-existing connection and like can form a base to start this versus like starting it on your own and trying to find that first 2 or 3 people to kind of like see that for. I was wondering, like, in that latter case, because I know there's a lot of people that find help too, like, who they might just be alone in their state, and they're trying to find other people to, like, even, like, start to have a club before you grow past that. Like, how do you really get through those initial stages, you know, of even, like, forming a community to begin with?
Right. It's a hard question. So the question is, for example, if you were in an area where there's not a lot of population to build a group.
Or even just, like, in an area where, like, you're not doing this with, like, 2 or 3 other friends, right? You're just trying to find people, right? You're just trying to find people, and, like, that first meeting, everybody might just be, like, strangers or whatever, and you have to keep coming back each meeting with the same retention until you get to the point where you draft. Like, have you had that experience, and how has that been for you? Or have you just gone in with, like, a couple people to start with?
Yeah. So we started with just a couple people that showed up, and a lot of times those people changed. And that happened for a while, and it was funny enough for the people who came to keep on coming. So I think it would depend on that. It would depend on like if people come and they get value from coming together and building stuff. But our experience was that yes, people enjoyed coming, even in very tiny groups, and it just organically, naturally grew from that.
So how do you like break the ice in the beginning?
That was hard. So the question is, how did we break the ice in the beginning? It took a couple iterations. The one thing that helped a lot was that everyone came for a purpose. They wanted to meet people that had similar interests and wanted to do sort of the same thing. Finding out what that thing is exactly took a while. Like I said, we tried a lot of stuff. So having just a bunch of people with similar interests are gonna sort of like naturally bring up those icebreakers. For us, it was just nerding out over like stuff that we were talking about at the time. Go ahead.
Thanks for the talk. So we have a group, like you said, finding a venue is, so I have 2 questions. You said finding a venue is easy. We have like a small, not small, but like a medium-sized FOSS libraries, internet in a box effort in Boston area, and finding a venue at times, like for workshops, has been challenging, right? It's like multi-weeks of legalese, negotiations, and figuring that out. So curious if you have tips and tricks on that. And then second, you mentioned like common interest at the hackathons. Like what are you guys hacking on? Curious about that.
Very good questions. So the 2 questions were the venue, some tips on getting the venue. And then the second question is
What are you hacking on?
what are we hacking on? And I should have put a slide in there. That would have been one of the best slides, what we've been building. So the first question, the venues were a challenge for us as well in the beginning. But again, our first ad was just, hey guys, anyone wants to come together, we'll figure it out. But does anyone want to come together and just talk about tech? So people said yes. There were signups on Meetup, and we just went to a cafe. So that's probably a good start for most people. But eventually what I learned is that you can walk into a lot of public spaces and just ask them, like tell them that, hey, we have a group that likes doing this particular thing. Would you be interested in getting a space for us for a little bit, for like an hour or so? So I went to places like community centers. At the time I was volunteering at 2 or 3 community centers in Flushing. I went to the library. I went to Queens College, and I just went there. I showed up and I asked them if they would be interested, and they always said yes. So I think just finding public spaces, going to them and asking them is a good first step. What I learned as well is that you can actually go to your representative office, and they have a lot of connections usually in your neighborhood. So like your council person, your community boards, they usually have a lot of connections to people who would definitely be very interested in bringing people to their spaces. So those are very useful places to find venues. The second question was, what are we hacking on? So some of the things that we build, most of the stuff that we build are apps. People like writing software together. There's a very low barrier to entry, so you can just bring a laptop and you get started. Recently, we've also been exploring 3D printing, so that's another thing that we've been doing. We try to do some hardware as well. That's the next thing that we'll probably explore a little bit in fleshing. So stuff like Arduinos, stepper motors, microcontrollers, that kind of stuff.
There's a question from the internet. It's relatively easy to get people to join events. It's much harder to get them taking ownership of organizing work. How do you handle this recruitment?
Very good question. So luckily for me, and I am pretty sure this is going to be your experience as well, is I think this is, again, a big part of because everyone comes there because they have shared interests. You do that for a little bit, and people really feel a part of your group. I think Fleshing Tech, I don't think I'm very grateful, and maybe we were lucky, but I think having people come and really be part of something that really gives them a rewarding experience, just naturally brought out people who wanted to own stuff. As an organizer, if there's any managers in here, you probably know this really well, is that you just have to find them. You just have to find these guys and see who wants to do what, and then encourage them to take that step. And I think, yeah.
I was curious, like at the stage of this development, are you starting to connect with other similar organizations? Like I know also in New York there's like Beta NYC and a few other orgs.
So the question is, have we been trying to connect with other similar organizations? That would be fun right now. I'm a volunteer / participant at Beta NYC. I volunteer at their open data conferences sometimes. And it would be fun to do partnerships. I haven't explored that too much. But yeah, I can see a lot of value with exploring those partnerships if you have the bandwidth. But unfortunately, I do not. Go ahead.
I see in the agenda that you've sketched out that there's, like at each hackathon, there's maybe an hour and a half set aside for the build phase. And like my first impression is that seems very short, but also I haven't organized this kind of thing. I guess I'm curious, have you experimented with like longer, more intense periods, or like why did you end up settling on that?
So the question is the building time, which is 1.5 hours in the agenda, if that's enough, and if we experimented with different times, and if that's sort of intentional. So it wasn't intentional. We had this space in Queens College for 2 hours, and the first parts of the agenda usually took up like half an hour. So it just happened as a factor of how much time we had in the space. But I do know from experience is that sometimes we run over it. The space is very forgiving about running over the time. And when we do run over into a longer period, I think it dilutes the energy and the excitement of having that short period. So 1.5 does actually feel like a very nice time to just spend hammering one feature or one part of a feature out with a bunch of people next to you. And I think that same thing as we work in our own jobs is that to hammer out a task, I think takes 4 to an hour and a half maybe. And once you get that done, you can grab a cup of coffee and feel very rewarded. So I think it's a nice natural time span that you can aim for. Okay, so we have a couple more questions. Let's get these guys that I haven't been. Go ahead.
How would you recommend determining the size or scope geographically of the community, especially especially in a suburban area where everyone's so spread out?
It's a good question. So the question is, how do we determine the size that we should be trying to aim targeting, the geographic size? That's a good question, and I don't have a good answer. But what I'm thinking initially is that a neighborhood is a good target because, so the reason that you would probably choose a neighborhood is because they usually share a couple things. They share like a favorite coffee shop, or they like share government representatives that they can talk about at the hackathons. So any space that shares a bunch of similar characteristics, I think, is a good target. Like any geographic area that has similar characteristics is a good target area. Physical boundaries, I don't think, mean that much. Go ahead.
I've always wanted to do another plug for libraries as a place for these kinds of things.
Yeah.
So just saying that, as a librarian, I'm also really curious. You mentioned wanting to shift to trying to do projects that support local nonprofits or organizations. Do you have any examples of things you've done or what you'd like to do?
So we got a plug for using libraries. And if we've tried to do anything for nonprofits in libraries or any.
You mentioned that as sort of a next step.
Yeah.
To do things to serve the community. So.
Yeah, and if we've done anything for the community. So we haven't done anything really as yet. We're still sort of like building a lot of stuff for Flushing Tech itself. So like the voting app, like you saw the website, like you saw the manifesto. We're building all this stuff, which in the long term is going to benefit Flushing as a whole, because we're going to have a strong community there. But we haven't like reached out to other nonprofits. And I think that's going to be a very rewarding next step, but we haven't done that as yet. Some places that I'm looking at is local nonprofits, because there's a lot of funding that's lost. There's very few hands in nonprofits usually, and there's a lot of tech needs, and the skill sets in nonprofits are usually more focused on their impact and not on the tools to bring them to that impact. So anyone in a neighborhood can really help a nonprofit by just volunteering those services in a group. Businesses would be also very rewarding, because in your neighborhood you might make a lot of connections that are going to be very strong. So nonprofits, local businesses, I think those are good first targets. Any other questions? Go ahead.
Kind of related to that, because you only have about a 30-minute ideation phase. When you were starting the hackathons, did you struggle getting ideas on what people would build in that first hour and a half? I feel like over time it probably got better because there's rollover, but how did the ideation at the start go?
Very good question. So the question is about ideation and how does ideation go? Ideation actually happens much more quickly than 30 minutes. Everything before the building phase is 30 minutes, but ideation itself is about 5-10 minutes, really quick. So like you literally come in and just off the top of your mind, what do you want to build? And even to this day, it's very hard. Part of it is because a lot of people come in and they don't read the full event description, so they're not super prepared. And that's okay. If people come, they just want to see what this new experience is like. So even right now, it's a challenge. And there's some tools, I'm not too sure if it's in the manifesto as yet, but it'll definitely go up there soon, is that there's a couple options. You as an organizer, or maybe you might see a couple people that always have really good ideas. Before the event, you might ask them, or you might put together a list of possible options that you might start off with, just to get people thinking about some options that they can build. So you can prepare beforehand. I really like the idea of just like putting people on the spot and like forcing them to really think about stuff that they want to build that's close to their hearts. But it turns out that if you want to run it smoothly as a group, you got to do some preparation sometimes, and you got to like prepare some ideas beforehand. It does help the group as a whole just to really hammer out some good ideas. We have an agenda for each hackathon as a slide as well. I should have put it up as an attachment. I'll send it out whoever signs up. And in there are some things that you can think about, like when you're thinking about what ideas. And having a visual, a visualization of some things that you might build helps people come up with those ideas. All in all to say is that it's going to be hard. It's still hard for us today to get people to come up with ideas. All right, I think we're at time. Okay, so we're at time, so thank you all. If any more questions, just... Thanks.
Top 10 democratic open source software defined radio and amateur radio app.
Thank you for the awesome intro, Moon. All right. Audio test. All right, we're good to go. All right, so yeah, that's the title of the presentation. When I came up with the idea for this, I thought it's almost like an easy one to say, well, what are the top 10? But there's always going to be some bias in that. And so I needed to come up with some way to say, with some fact-based way, why is it why are these the ones that matter? And that's where the democracy comes in. So I bet everyone in this room is familiar with GitHub. Is there anyone, if they want to raise their hand, that's not familiar with GitHub? Okay, I'm really glad to not see any hands raised. So yeah, I think everyone here is the right audience. So it goes without saying, it's the most popular repository for everything. And there's lots of cool projects. And when you go and search on GitHub, searching matters. And so when I started the journey on this presentation, what I soon discovered was when you do a search for software-defined radio or SDR, you get drastically different results. And same thing also with amateur radio. As most people know, amateur radio is ham radio. And so this data that I have on the screen right now, this was August 5th. The numbers have actually increased. I think on SDR, it's up to like 10,400 results. And then software-defined radio, I think was like 890 now. But amateur radio and ham radio is roughly about the same. But again, it doesn't really matter. But just to show kind of the scale, you know, if you do a search for SDR, you're going to get a lot more results compared to if you spell it out. And I think we all like shortcuts, right? So no surprise there. And what's funny is there's not really a lot of overlap. And so when you go on Git, you go up to the top and you type in, you click and say, well, show me what has the most stars, you know, or maybe some of you want to see what's the most forks or what's been most recently updated. But in this case, I thought, well, if we go by stars, if everyone's logged in and they're voting, that's where the democracy comes in. And so this way, it's a community of everybody in this room and around the world that ideally what's going to have the most stars is most likely what's popular or most popular. And that was kind of where I started. But then that kind of took a little weird turn because when we run these searches, I'll use SDR as the example. So hopefully nobody's too colorblind here, but the long stripes that are orange, that's the official color. But you can see like things are taking a very different turn here. So looking at the total number of stars, the fact that the #1 most ranked SDR app, which I'll get to, has over 11,000 stars, that's pretty crazy. And it drops off from there. But then when we go and compare like SDR to software-defined radio, which is in like a light blue color, gets smaller. And then when we look at ham radio and amateur radio, it's almost like you have to really look close to this. But again, I wanted to try to figure out a way. How do we really look at this? And just because something has the most stars, that might actually not be the most popular or like the most innovative or what's really driving things. And so what I wanted to come up with was a way to figure this out. And so if we added up all those stars, so let's just use SDR as the example. So if we said SDR and software-defined radio, we add up those top 10 applications for each, 71,000 plus stars. That's crazy, you know, and that's just the top 10. And on Git, there's various APIs that you can do, and you can do all sorts of, you know, clever math and stuff like that. But just at a high level, to give you the context for when you take all the stars for SDR and software-defined radio, 71,000 stars, that makes amateur radio seem like really sad, right? Like in comparison, I think charts do the messaging here. And then for the top 10 amateur radio and ham radio applications, only 9,100 stars. And I thought, well, that seems kind of bad, but there's a lot of positivity in this, and that's what I want to kind of get across. So I came up with something that I call velocity. Out of curiosity, has anyone used the starhistory.com website before? One hand or 2 3/4 or so. So yeah, so I thought, all right, well, star history is good because basically you can type in the repository and it'll do all the math for you instead of me having to go and do my own APIs. So that was cool because it showed me when a project started and how many stars it has, and it takes little periodic measurements over the span of the project. And as we can see in this green stripe, and some of you might see that this is actually related to the Universal Radio Hacker project, That's how I'm calculating velocity. So basically, all we're doing is we're taking the number of days and the number of stars and dividing them into each other and coming up with a score, and that's how it calculates out these charts. And you could flip things around, and because we all like QR codes, anyone who's seen my presentations in the past here at Hope know that I love QRs. So hopefully a bunch of you are going to scan this QR. What it will bring you to is across those 4 search terms. So for software-defined radio, what are the top 10? Amateur radio, top 10. Ham radio, top 10, etc. We don't have time to go through 40 applications. This will be a long presentation. A good one, but a long presentation. So when you scan this QR code, for anyone who's doing this, it's only going to show you the top 8, which is in that box to the left. If you have an API token, which is super easy to set up, if you have an API token, probably some of you have this, but probably not on your smartphones. Just click off the little box that says you need a token, and it'll show you the list. So you can click into all of these. The little landing page that I created on one of my Ham Radio Club's websites, it'll show you these charts specific to those 4 terms. And so hopefully everyone scans this, brings it to the landing page, save it in your history, and you can click back and look at things. Again, I'm only going to look at some of the top ones here, but again, there's 40 really cool things, and I like analyzing data, and anyone who knows me knows that I like analyzing things. So we're going to really look at the top 8, so the top 2 in each, plus 2 others, because again, I don't want to let anyone down that this is a top 10 presentation, so I have 10. But like I said, there's 30 other applications that are not captured, so definitely go to the QR code and hopefully everyone, could I get like a thumbs up and make sure that everyone's decoding it? You good? All right, sweet. All right. So before we dive into the meat, I don't know if anyone remembers the ShamWow guy. I was looking for like a clever infomercial kind of guy. So this is like the infomercial. You know, what I really try to encourage when I give like radio related presentations, which is a topic that I'm very passionate about, is learn more about this stuff. It's not just about amateur radio. SDR is not about amateur radio. There's folks like Moon, who has an SDR that I just learned. Don't know what they're doing with the SDR yet. I'm sure I'll find out in Q&A time. So learn about all this stuff. Most importantly, meet other people into this stuff. I know the last 2 Hopes that I presented, I've met a lot of people, and we've stayed in touch because events like this are really awesome people connectors. And so that's definitely a takeaway. Big shout out to Ed, N2XDD, Nicole, 82IM, and Dan, KB6NJU. They're giving a get your ham radio license in 1 day. And for anyone who feels like they've already trained, they can get their ham radio license. So there's stuff like that going on. So again, hopefully some of the things that I cover here are going to encourage you to either get on the amateur radio path or go further in that path. And so we have that. And then new for this year, kind of weird. Some of you have probably seen some weird yellow signs around. Toilets on the air. This is a clever amateur radio activity. It's safe, the way that it's set up. So again, just a kind of a brief infomercial of some things. Look for me at the RF Village over across the street here. So if anyone wants to chat afterwards, I'll just be here for the remainder of the day. And there's a lot of my my cohorts that are into all this cool radio stuff, as well as the NYC Resistor folks at the opposite end of the show hall. So we're doing cool things. So there you go. So all right, so let's dig in here. So going back to velocity, like I said, stars divided by days. That's how we come up with these velocity. And don't worry, I'm not going to go through this bar chart because this is a light and fun presentation. But going from the top 10 of the highest velocity, the big takeaway here is you can see at the bottom, URH, Universal Radio Hacker, it's almost like a velocity of 3. That has been around for a long time as a project, and I'll come back to that later. But you can see just for like out of all 40 of these applications across the 4 search terms, all 9 of the 10, those all actually come out of SDR, not software-defined radio, SDR. The one that I've highlighted here is the only one that does not come in, and that's one under ham radio, and that's something called KV4P-HT, which I'll cover. But the point here is there's a lot of cool things, and I think it's fair that if people talk about projects and more people vote stars, it creates higher velocity, right? And then when you find out that this is a cool thing and you tell your friends about this, then they want to figure it out, and it just drives more engagement. And so that I think is a cool way to kind of look at this, and maybe you might want to even consider applying this to other things. Maybe if you're into AI or crypto or whatever, different ways that you could use star history to calculate these what I'm calling velocity. The last thing before I move on is the purple dotted line that connects to one project will not be possible without the other, which I'll come to. So just to kind of share that, and I thought that was really interesting, the fact that there's one that drives another, and both are actually in the top 10. And so that actually adds like a little extra weighting for why these are cool. But again, I'll go through these in detail. And here we are. Here is the top 8. Sorry, there's a lot of detail on here. So basically what I decided for this presentation is I'm going to focus on the top 2 in terms of velocity across all 4 search terms. And so if we look at amateur radio, I'll be talking about something called wavelog, and then GR satellites, software defined radio, Caribou Light and GQRX, ham radio, KV4HT, and AOIC, not AOC, local politician, and URH and SDR++. I thought it was also worth just kind of highlighting that just because something scored high velocity, how many stars overall? And so I have a number in the upper left-hand corner of each slide of like how they ranked overall. And again, I'm not trying to rank like who's the best, because this is like democracy and there's all of them are really cool. But I thought it was also worth just kind of giving a quick shout out to what was the highest star ranking, just to see if the math was off. So like, for example, when we look at amateur radio, Wavelog is first in velocity, but has 5th overall total stars. GR Satellites is 2nd highest in velocity, but 1st overall stars. And then there's something called APRS Droid, which is 6th highest velocity, but 2nd most stars. So again, looking at data, I think is really an important thing. And again, that's really the gist of this presentation is how did I come up with this? And again, we're looking at everything based on velocity, not total stars for what I go through here. So here's your last chance. I made this QR code extra, extra, extra big. If you want to go to that repository page, here's your last chance. And if you haven't been able to capture on the small one, here's your chance. But it's going to go to the same of where I directed. So again, we're going to look at the top 8, 2 per each, plus 2 special mentions. And then we'll take some Q&A. And again, toilets on the air. I'm getting a lot of mileage out of the ShamWow guy. Definitely check this out. This QR code goes directly to this. This will make a little bit more sense when I go to the next slide. But when you register, or even if you don't register and you want to check this out, you can look at where are these toilets here in the map, the data, the users who's registered, what frequencies they're doing, how many contacts. Like, it is like massive data analysis. The NYC Resistor and Todd specifically have helped bring this over from Europe. This is not like our original idea. Toilets on the air has been a thing, hence the website at totawatch.de. So it started in Germany, but this is the first year, and hopefully this continues going forward. So everyone who has like a Baofeng radio, check it out, especially if you're a ham radio, or if you just want to listen. Quickly, what activity are we doing? We thought it would just be like people talking back and forth on radio saying, hey, I'm at toilet 01 and you hear me good, and we log it into this application. But what's actually happened since yesterday is there's people holding their cell phones up to their radios and sending what's called slow scan television. And don't worry, nobody's taking weird photos in the toilets outside or in the vicinity of things related or unrelated. But again, keeping it fun. I think it's kind of a neat hack, if you will. So definitely check out totawatch.de. That's where the QR code Mr. ShamWow is pointing to. And hopefully we're not using ShamWows as part of Tota. All right, so here we go. So the first one, and again, these are not like in order. So I just kind of put them in what I thought was just a good talk track. So the first one, this is something that's related to amateur radio, not ham radio. So wavelog. So anyone who's been around the amateur radio world for a while knows that amateur radio people love to keep track of who they talk to. So this way, 9 years later, they can say, hey, Fred in Germany, I spoke to you for 3.5 seconds, 7.5 years ago. And we did this on this frequency, and the temperature was whatever. You know, amateur radio is all about like data analysis, or even if they don't data analyze it, it's all about collection, it seems. But this is a really cool project. The fact that this was growing as fast as it is, I largely attribute that to the fact that this is what's known as a forked project. So it actually started life as something called CloudLog, which currently has the 3 most amateur stars. But now Wavelog has actually overtaken that in terms of velocity. So not only is there a lot of crossover technology, if anyone's familiar with containers and self-hosted PHP applications and stuff, there's a lot of cool things. And this actually is something, as we see in the right-hand corner of the slide, something that actually relates to toilets on the air. So this is kind of neat. It's a lot of good crossover technologies. You can see some of the different keywords over at the left, which is always a good thing to search for. So not only if you're doing a search for amateur radio, if you did a search for something like web app or what's not amateur radio related. Yeah, pretty much. And self-hosted. Yeah, that's pretty much it. But everything else is like an amateur radio kind of related term. So this is a pretty cool project, and it started life in Europe. Those are the call signs for the main developer team: DF2ET, DJ7NT, HB9, HIL, and LA8AJA. Are any of you present? No? I just figured I'd ask. So yeah, so logging, it's kind of a cool thing. And again, just to show, amateur radio is not just about, talking on radio. There's lots of other things, and there's lots of hams that I personally know that do cool things like this, and they never touch a microphone or a Morse code key or anything. They just like doing cool stuff. So that's Wavelog. And moving on, again, another European ham. He splits personality between Spain and the UK, is Danny. And this is a satellite-related project, and this is the second highest in terms of velocity, 27th overall in terms of the stars across the 40 that I have. What's neat about this, for anyone who's been around software-defined radio for more than a minute, you probably come across something called GNU Radio, which is like super daunting to figure out what is going on, but he makes it easier. So basically in GNU Radio, he's created a number of workflows, and he's been at this since 2015. So every time that amateur radio communities launch satellites, there's telemetry, which means like they're sending down parameters of operational or maybe some, images or, other data for communications back on the ground. So he has all these projects worked out, built on GNU, and has it in his project. So it's actually pretty easy. It's super well documented, and it's overall really cool. So I would highly encourage people to check that out if you're looking for, GNU Radio, there it is again. What could you do with it? So you get your SDR, you run this with GNU. Hopefully you have the right antenna, because if you're picking up signals from outer space, you got to figure that out, which is a topic for a different day. But again, this is pretty unique that this is a project that's been around for 10 years, and it's ranked up there pretty high in terms of velocity. And in more recent years is where it's got more notoriety compared to when he started this. So I think that's really an amazing accomplishment to stick with a project for this long. All right, moving to some hardware stuff. Here's something that's SDR. This is called a Caribou Light. I don't know if anyone's come across this. Probably if you're going from like a $30 SDR receiver, you then probably think, how do you transmit? Well, this is like one of the lower cost ways to do this. There's 2 versions. There's one that goes from 0 to 6 gigahertz, and then another one that does 2.4 gigahertz like Wi-Fi, and then sub-gigahertz. So for anyone who's into like 900 megahertz or ISM communications, there's one that's roughly about half the price. But basically the way that this works is you attach it to a Raspberry Pi Zero. You could attach it to like a regular full-size Raspberry Pi, although there's some dependencies that are in the works for the Raspberry Pi 5. But for the most part, running this connected to a Raspberry Pi 2. Now, what would you do with this? Well, let's say if you want to make some kind of crazy like IoT transmitter or receiver or data aggregator or whatever. The point is, this project is not just hardware as open source on Git, it's also open source software, and this would work across a lot of other projects. And so this is kind of unique. This is 11th overall stars. It's the fastest growing one under software-defined radio, not SDR, so software-defined radio. So it's interesting how things get tagged. I find intriguing that there's not as much crossover as you'd think between all these terms, which I'll touch on a little bit later. So that's what this is. Moving on, there's a demo over there. If anyone's been to the NYC resistor table, they have this application running. called GQRX. Again, if anyone's been into SDR for like more than a minute, chances are you come across this, especially if you're on the Linux side of the house versus Windows or Mac. It is able to work across multiple softwares, but this is kind of like the good universal way to start. Cool software, allows you to visualize, allows you to decode, the first capture flag on this is probably taking your $30 SDR, running GNU radio, and then tuning in some like local FM broadcast and watching it on the screen and thinking it's the most amazing thing. But then you can do other things too, receive, amateur radio, police, Coast Guard, whatever. Also a lot of data signals. So there's a lot of cool things, and most importantly, it's a great way to learn about the dreaded dependencies when it comes to why things break when people upgrade different things in a project. So the nice thing with this is kind of like a good failover. If you're experimenting with like the leading edge software and something breaks, usually people fail over to GQRX just to make sure that you troubleshoot. Did you blow up your hardware, or is it a computer issue? Some people have faulty USB ports. This is like kind of like a good way to test, is it your SDR, or is it your computer, or is it something with your software? Is it doing what it's needing? And so this is interesting. This is, of all of these, it's the only one that crosses over between the different terms. So both between SDR and software-defined radio, this has what I'm calling double stars. I'm not surprised. It's also been around. It's the OG. It's the old gangster of SDR, as I like to think about it, or pretty close to that. So again, if you're starting out or interested, I'm sure you probably have this already. So again, it's pretty cool. And like I said, toilets on the air. They're decoding some stuff that we're doing at the RF Village table. And again, I'm not going to give you spoilers. Go and check that out over there in the across the street. All right, moving on. So here we are, 5th highest overall. This is the most highest velocity as it relates to ham radio. This is something called KV4PHT. That's his call sign. Show of hands quickly. Who's familiar with Meshtastic? Okay, good. This is not Meshtastic. I just want to make that point clear. But it's kind of a similar form factor. Basically what this is, it's like an SP32 device with like the low-cost radio on a chip that you'd find in a Baofeng radio glued together. And basically you just take your USB-C cable, connect this to your smartphone, draws the power off of your phone, and it creates either a 2 meter or a 70 centimeter transceiver. You can communicate over voice. You can send and receive your GPS location. You can send little text messages. This is all off grid. So again, why I say it's not Meshtastic, it doesn't use mesh, it's not ISM, it's its own thing. But what's really cool about this is when this started about 2 years ago, this has grown really, really fast. And for like under $30, you can go and buy one of these. Now, yeah, you can also buy a full regular radio, but what fun is that? This is something that you connect to your phone. And there's no air gap. You're not doing Bluetooth like Meshtastic to go Bluetooth to your device. So again, this is pretty cool. I was hoping to have this here in time for the presentation, but the old trick of I thought it was being shipped from New Jersey. Well, there was the shipping to New Jersey after it arrives from China. So it's somewhere in New Jersey now. I'll probably have it tomorrow, but that doesn't help us today. So anyway, it's still a pretty cool project. Highly expect people to look into this. All right, all-in-one cable. Make your $20 radio into a $200 radio. That is a tough feat. So whoever has like a basic Baofeng, again, I just use it kind of as a generic term, but basically anything that has the speaker mic ports on the side, the two plugs, the 3.5 and 2.5 millimeter plug. This is both a combined hardware and software project. So basically what this is you plug this into the side of your radio, and that little circuit board has like a sound card and a keying circuit and converts it to USB-C. So what happens when you take a radio and you get this, you plug it in, take your USB-C cable, maybe you plug it into your smartphone or your computer. Now you have like full access. You can program the radio, you can send and receive messages and data and images and whatever. So that's what they call it, the all-in-one cable, because basically it does everything. In the past, you'd have to have like 2 different cables to do some of this. So it's a really cool way that you can take low-end radio equipment and do other cool things with it. Again, also TOTA related there. All right, moving on. Here we have something called SDR++. So probably once you get past the GQRX and you're looking for something like the next level, probably you come across something like SDR Sharp, which is older software, but it got a little too bloaty. And so Alex started work on this a couple of years ago called SDR++. It's similar in look to other software. So it has a same look and feel as like GQRX and SDR Sharp. It's very different than SDR Angel. What's unique about the way that he's devved this, and he's still a young fella, went back to school, took a little bit of a break. Anyone who follows him probably knows the whole history of this. But what's weird is when you go on Git and you look at it and you say, oh, well, maybe he's still busy doing school stuff. It looks like it hasn't been updated since 2022. That's not the case. It's because the way that he has this, where a release automatically updates after each commit is pushed to the master branch. I'm so glad everyone's familiar with Git, so I don't have to explain that. But you all know what I'm talking about. But why that's important is when you go there, it's like his latest revision is like dated in June. So it's constantly evolving. So don't go off of the fact. And again, when I look at stars and velocity and stuff like this, I could have almost made the fact to say, oh, disqualify that because it hasn't been updated since 22. If a project's not been updated for 3 years, it's probably not too popular, but that's not the case. It's just the way that he's decided to craft his Git. So this is a really cool software. There's a lot of special features that he's built into this, and there's other people that integrate this into other projects. And so I would highly encourage people to check this out. It is way more advanced than he makes it look. So really hats off there. And this is the last of the 8, and we only have like 3 1/4 slides before I take some Q&A. So this is the best of the best of the best. You really need this. This is called Universal Radio Hacker. If anyone remembers that big green stripe that just looked like it was going to pop through the roof. This is a project that's been around for a really long time, and it continues to gain a lot of traction. Basically what this is a way that if you're looking at data signals, you want to figure out what that data signal is actually comprised of. This allows you to figure that out. And let's say if you wanted to clone that signal, let's say if you have like a temperature sensor that you bought and you want to ingest it into some custom home energy management dashboard or something like I have. I used Universal Radio Hacker to figure out the way that that signal is structured, and it allowed me to figure out how I can ingest that. You could also use it for another purpose, which is a bit of a gray area. So let's say if you had like a garage door opener and you wanted to clone that signal and use an SDR to transmit your garage door signal as like a replay, you can use Universal Radio Hacker for that. And again, I'm just touching on the surface, but that's not just me being a fan of this. This is another like 11,000 people that have already said that this is really cool. So Universal Radio Hacker, like I said, something you really need this. Another project out here, just for a quick shout out, RTL 433. If anyone's tried to decode like tire pressure monitor sensors and weather things and whatever, it's kind of a fun thing. It's 3rd most stars, 6th highest velocity overall. The two of them kind of go hand in hand, sort of. But again, URH, Universal Radio Hacker, super cool. Finding all sorts of things in all sorts of spectrum. All right, so as we start to close things up, I'm sure some of you out there are like, man, how come there's some other common ones that haven't been talked about? And that's where we come to our friend HackRF. Then we're going to talk about something related to that called Mayhem or Portapack. Depends on who you ask, but I'll clarify that in a second. Then we have the last one on here called Open Wi-Fi. So that's cool. But again, the takeaway from this chart, number 1 through 10, highest velocities, and then where do they rank? So again, like I said earlier, SDR as an abbreviation, almost everything that is thought to be the coolest things based off of stars, it's clear right here. All but 2 are in that category. One from Software Defined Radio, which is a make your own cellular base station type of project at the bottom called SRS RAN 4G, which I'm not going to cover because I'm not getting in trouble with like Verizon and T-Mobile by saying how to make cell phone mini base stations, but you can do that. That's cool. And then we already talked about KV4P. So, all right, here we are, HackRF. Super big news. This I'm super excited about. So since 2014, when they came out with the original, Michael Osmond came out with the original HackRF, it changed the game. I think it's hysterical that when you go to Git and people put descriptions on projects, this is the official description of HackRF, low-cost software radio platform. Less is more. That's all he has. I had to actually come up with more words just figuring that somebody might want to see this. So this is the official project description. 2014, this was true, and 10 years later, it's still pretty based off of what the HackerF can do. However, now here we are in 2025. That hardware has been getting long in the tooth, and so now he has an updated version called the HackerF Pro. It's targeted for official release in like October. There's some pre-samples floating around out there, but basically this offers wider frequency coverage, so it goes up to like 6 gigahertz instead of, I think, like 3.5 gigahertz. Has a USB-C interface because we're probably starting to not know where our stash of USB microcords is hidden. And overall, it's basically the same thing. There's a lot of other things that have changed, but for the most part, those are like the two biggest like ahas: more spectrum and faster interface. And again, this is a piece of hardware. You need to connect it to a compute device, and you need to run software. Like the GNU logo is that orange one. One of my favorite ones, which I couldn't talk about because, again, I didn't want to show bias here, is something called SDR Angel. Even though it's in the list, but not in the way that I've structured this. So there's lots of cool software that you would use. I have a HackerF at the RF Village, which is transmitting 9 simultaneous signals on different frequencies at the same time. So if anyone wants to figure how I'm doing that, come on by. I'm doing that with SDR Angel. And then we get to something called PortaPack, or the Mayhem firmware. So basically, if anyone remembers like an iPod or a Zune, that's like an obscurity from like Microsoft before Apple iPod took over the world. Basically, this is like a hat. You attach this to the RF deck, and it has a screen and a jog wheel and the processing power. And basically, you can do a lot of cool RF things right in the palm of your hand. Has built-in battery and everything. So if you want to like monitor spectrum or do replay attacks, or mess with like your neighbor's Tesla and open its gas door or whatever, there's like all sorts of cool things. So you can buy these online. The cost has come down since the original PortaPack. So this is what it looks like. But I think the big takeaway on this is expect the increase in stars as the HackerF Pro is released. So even though it's held its own over the years, I think now we're coming to like the next generation. So there's going to be a lot of extra development. I really think that everything beyond HackerF that Michael Osmond has done for software-defined radio, he's like one of the original guys that's like hacked the drivers and figured out how to take these TV tuners and create like what we know as like hobbyist SDR devices. I think this is going to really blow up. It's going to gain velocity. So I'll keep that page active. And I think, much like we saw with Universal Radio Hacker, I think you're going to see this really start to take off even more as that comes out. And again, this is like both hardware and software. So the Mayhem firmware really added a lot that the original PortaPack did not do. And again, very TOTA related, because I'm broadcasting TOTA related contact stuff over at RF Village. And the last one, this is kind of like very different than like everything. And again, when you kind of dig into data on things, you kind of start to discover like these neat little trends, like the KV4P. Here's Open Wi-Fi. This is the 4th highest velocity. That's out of the 40 things that I've reviewed. Well, 10 of them today. But basically, this is using software-defined radio hardware and creating your own Wi-Fi type devices. Now you'd think, well, Steve, you can buy a Wi-Fi chipset dev board for like $9. Why do you need to spend like $180 on HackerF? Well, because you do. So that's why you do it, right? But joking aside, there's other things, especially those into amateur radio. Now, when we think of Wi-Fi, we often think about like 2.4 gigahertz or 5.8, or now we have 5.9 and 6.0 gigahertz. But let's say if you're an amateur radio person, you want to do Wi-Fi like as like an 802.11 based standard over 900 megahertz. Here's your development platform for that. And there's other devices that address that 900 megahertz gap, which is its own topic for a different day. But I think that this is really cool. And since I mentioned it before, the RAN 4G project. Now, let's say if you wanted to make like your own cellular base station and your own like software emulated Wi-Fi, if anyone's like an aspiring network dev or you want to do cool stuff, this is like leading edge. And again, the fact that overall this kind of sneaks in there, this is technically hidden under SDR. And again, like I said, it's the 4th highest velocity. So this is something that's come on fairly quick and gained a lot of popularity. Not the total stars, but again, how fast is it gaining in popularity? So something definitely to take a look at. And as we kind of wrap things up here, like I said, Git search matters. don't just apply this like, you know, SDR compared to software defined radio. If you're doing a search for like application security versus AppSec or operational security or OPSEC, do different variations because you're going to pick up different things. It doesn't have a relative search. So if you're looking for something, get creative. You might find some other things. Also, just because a project's been around for a long time doesn't mean it's the best. This is kind of an issue within the amateur radio repositories where there's things that have been out there for like forever, but like they've pretty much stayed flat. Like nobody's really cared, even though they're underpinnings of a lot of other things. So again, showing just because a project's been around for a long time doesn't mean it's the best, but also just because it's the newest doesn't mean that it's the best. So that's probably making your brains hurt a little bit. But again, just because it's the newest, maybe they need to develop it, kind of like with CloudLog got forked into Wavelog. If we look at like HackerRef and PortaPack and Mayhem, again, people learn, people fork, things always get better, but like keeping an eye on things, it's always exciting. Like when you find something early and it becomes to be like a really popular thing, it kind of makes everyone feel good that they were like an early adopter. And like I said earlier, go meet people here. You know, we all have unique talents and skills and knowledge and stuff. Don't be afraid. Some of us are afraid to interact with people, but we all have goofy hats and other trinkets with us to strike up a conversation. So hopefully everyone gets to meet some new friends here. And because I have to say it, you know, get your ham radio license because you need it. So that is it. Thank you. And questions? We're good on time for questions?
We're so good on time.
All right, I thought so.
I'm going to ask the first question. Hey everyone, I'm going to ask the first question. I haven't had lunch. So a question that I have is, it might be slightly adjacent to everything that you've been talking about, but I've got this RTL SDR and it's the V4 version of it. And I know that the drivers are slightly different from like the Osmocom ones. What is your understanding of like which tools are compatible with this new driver and hardware?
All right, so that's a good question, and I'm glad it's a question that I could actually answer in pretty good depth. So for what Moon asks, RTL SDR or RTLSDR.com. So like in the early days of like when people started to find these little TV tuner dongles, they want to find something, well, you got to have drivers for it to convert it to do things that we want them to do. So there was RTL SDR version 3. It's been around for a long time. The chipset's actually getting a little harder to source. And so they found a different one. It's actually a better quality chipset, which is what rolls into what's called RTL SDR version 4. The difference is, and again, like you could search for RTLSDR.com, and there's like a wiki that kind of covers some of this. Some of the benefits of the V4 hardware is that it runs lower temperature. If anyone has an SDR, they know that it runs pretty hot after a while. The V4 runs a bit cooler. It also has better what's called signal to noise ratio in certain areas of spectrum. The exciting thing is it's like areas that actually are fun to explore, like what I call ISM spectrum is license free, where you're probably going to be doing most of your, you know, exploring anyway around 433 and 900 megahertz. So it actually has like a little bit better oomph is the way that I call it. So the hardware is better. Now the problem is, as Moon asks, it needs a different driver. When it first came out, it was hard to get this thing to work, and I was part of like an early dev on it. Today, a lot of it's all went downstream, so it's integrated for things easier. But if you do run into issues with like a driver, if you buy a V4, and the difference is the V3s are silver and the V4s are black. If you buy a V4 and you plug it in and you go to GQRX as an example, and it says no worky, you go to the RTL SDR website and they have their own Git repository. You can download updated drivers from there, but they also have that integrated into the Osmocom ones now. So it's all downstream. And so if you haven't tried it in a while, Moon, try it again, and it should probably work pretty easy.
Cool. Thank you.
Good question. And that was not seeded, I swear. Not seeded. We just met each other like a few minutes ago. Question in the back?
But also, do you know how that compares to the Mayhem? Is that kind of like the same type of thing, or is that totally not understanding?
No, you need both. So the question for those that didn't hear it is asking about the Flipper Zero, which is a really cool device. Question is, why was that not covered? I'll get to that. And then how does it compare to like a Portapack or a Mayhem? So one, why it was not covered, because again, I went like full on democratic mode. It's not tagged. And I think this is what's interesting is like the Flipper Zero is kind of a weird little side area. It's not really SDR, certainly not ham radio. Can it be used for both things? Probably, but on Git, whatever the key tag words are, that's why it didn't come up. I think if we expanded it, like to see like what are the tags for Flipper, like probably CC1101 is one of the ISM chips that are in there. I bet if we did a search for CC1101, I bet it's probably going to be in there, and it's probably going to be super high. But they do totally different things. That's a presentation for the two of us to collab on next year, I think. It's a unique device with unique capabilities. I think both do different things different. There's also another type of device that's like a Flipper. There's a few of them like on Crowd Supply, and a couple of the other, like Kickstarter has like a few other ones that are kind of similar. It's a hard question to ask, but that's why it didn't trigger, and they're very different. I would highly encourage you to just buy both. You'll be very happy. And I do not get any kickbacks from these companies. Yes, in the back.
Yes, Steve, also to your point about the version 3, version 4 for RTLSTR, you're right, it did get downstream. I know on the Ubuntu repo, at least for 2404, it's all updated. And we discovered that when we were doing the update to the SIGPY R project.
So Joe and I actually know each other. So that was more like a validating thing, but was there a question in there, Joe?
I'm just validating what you're saying.
Okay, all right. Yeah, so basically for those that didn't hear what Joe said was, Joe and I worked together on quite a few projects, but one of them, which was kind of fun timing, was we worked on a project called SIGPY, which as its name sounds, involves signals and Raspberry Pi. And it was kind of fun timing because many of these projects like SDR Angel continue to update, and then hardware was updating, and it was really starting to irritate us because, sort of going back to Moon's question, was where are the drivers? And one of the things that we struggled with was as we were building in other applications into our project, things weren't working, and it was really kind of a daunting task to get the V4 to get supported. And then literally, if we just said, you know what, let's just take a vacation from this and come back in 3 weeks, that's basically all it took. We just had to wait for it to just trickle down. So again, if anyone had a V4 and got annoyed, go back. It's pretty much supported in like any mainstream app now. But thank you for that, Joe. Any others? Yes.
Would it be just possible at the end to flip back for the QR code? I couldn't quite get it from here, so sorry.
Do you want the big one or the small one?
Biggest as possible.
All right.
Tiny one.
All right, see if you can get it from that angle. I guess I'll speak it. It's hvdn.org /hope16. I think that's the URL that I made.
Good to go, thank you.
Yeah, you got it. All right, I see people are moving on to the next. So any other questions, or we're good? We're good? I got an official thumbs up from the gentleman in the front. Double thumbs up, triple thumbs up. Thank you.
Steve, you did it. This was an amazing talk.
Todd Whitney. I want to introduce everyone to Todd Whitney, our speaker today. He's going to be presenting on air quality. This is a great turnout, so I guess you guys have been choking on some bad air lately. You want to know what's in it.
Yeah.
He's got sensors that he's built that help identify that. He is also a fellow at the Social Science Research Center, working to make it possible for others to design their personal priorities around the environmental issues that matter most to them. So I know he's going to bring that to us today. So give him a warm welcome, applause, and encouragement as he gets going here. We're going to do some Q&A here in the end. Todd, take it away.
Appreciate you. Thanks so much. Y'all can hear me good, right? Yes. Right on. Yeah, thanks. It's a nice little turnout. Appreciate everybody for pulling up. Yeah, my name is Todd. I'm going to be speaking a little bit today about some of the research that I've been doing over the past few years about indoor air quality and thinking about pollution. Really quickly, my background is as a radio journalist, so did a lot of reporting for NPR for a long time. So I've always had a big penchant for words and trying to utilize vocabulary in any fun way that we can. And so what I've been up to over the past few years is trying to bring together my journalism background with the tinkering that I do, also with the independent research that I do, to try and put together different types of like hardware materials that help us to learn a little bit more about the environment that we're living in, with a special focus around air quality. So yeah, it's my first time at Hope, and it's the first time that I'm actually giving any sort of like presentation or talk about this research as well. So yeah, I'm envisioning it. I'm going to be speaking it a little bit extemporaneously. I'm going to have my slides, but also just be riffing, because the main point of the talk for me is just to meet folks, and if there's anything that galvanizes you, anything that you're coming across that activates you in an interesting way, I'd love to rap with you as I'm just going to be around the conference for the rest of the weekend. But with that, just wanted to get into it. Yeah, and so big thing for me, I think I started getting more into like air quality and air pollution a few years ago, and things really hit the fan back in the summer of 2023, which is when we had the Canadian wildfire smoke coming down here, kind of like clogging everything up for everybody over here on the East Coast. You know, and I don't know where I think there's a lot of folks who aren't from New York, but even if you were in like the eastern seaboard of the US or like the northern states, you know that this was totally like the vibe back that summer, right? So a couple of years ago, we had this wildfire smoke coming down from Canada. And I just realized when I was in a situation, this is right around the time when I was actually starting to hack together different types of like hardware and different types of particulate matter sensors. So I was taking a special interest in what was going on. But you know, to add insult to injury, I remember not just dealing with like the smoke itself, but one of the things that was really disturbing to me is when I went to try and find some information about what was going on around me, really wasn't available. I could go online, there were a bunch of news articles that would just defer and tell me to like check out the air quality index, and I'm like, okay, cool, but that really wasn't saying anything to me that I couldn't feel in my lungs, that I wasn't seeing outside with my own two eyes. And so it became a big thing for me of trying to figure out different types of ways of thinking about air quality and like the ways that we're exposed to it, and trying to come up with more material and personal ways to think about how this air is impacting me, and different ways I could work on better practices of becoming proactive and protecting myself and others around me. So got me thinking, one, in the midst of all this wildfire smoke, these are becoming like more frequent environmental calamities for us. Wildfire smoke, not just coming from the West Coast or coming from Canada, but also out here on the East Coast, just so we're having like a drier climate, so more and more minor smoke events popping up here. But one of the things I wanted to get into was trying to understand, outside of these bigger events, what are the more mundane ways we can try and think about air quality? Because for me, that's one of the most important things about air pollution, or about the air that we breathe, is it's really mundane, right? We're breathing about 20,000 breaths a day involuntarily. You're going to be breathing when you're sleeping, when you're eating, when you're working out, whatever it is that you do. And so it seems to me, even aside from the bigger events that receive all of our attention, when we finally start paying attention to air, what are the more mundane ways we could try and think about air quality? So one of the ways that I started when I was researching, one of the things that got me a little bit interested, I tried to think about different ways of bringing it together with other things that were going on around me. And I think one of the fun things I was thinking about was this whole like 10,000 steps a day thing that seemed to captivate everybody like a long time ago. Like, that wasn't really my thing, but one of the magical things about it for the folks that did get into it, at least for me as from an outsider's perspective, was the way that this changed from something of just like measuring and counting, and it slowly started to turn into something that people were like becoming competitive about. It became like the 10,000 steps that people were into. It became like a figure that people like they could own. And so we can do that for 10,000 steps. I think, you know, that's something that's aspirational, something that you don't actually have to do. It got me thinking, what can we actually do when it comes to the 20,000 breaths that we're taking in each day? And how can we make some like meaning out of like a number like that? Sorry, just want to make sure. Yeah, and so with each of those breaths, especially, and it's not just the quantity of them, we get 20,000 breaths each day, but it's also important for me to think about what's the quality of these breaths. We don't actually know how many of those are going to be good, what's the chemical components in each breath that we're taking in, because with every breath that we're taking, it's pretty much just like a chemical cocktail, whatever is around us. Pollen, ozone, particulate, smoke, whatever it may be. So it seems important to me that one of the things that we do is trying to get like a better understanding of exactly not just the number of breaths that we're breathing, but what's the quality of each of these breaths that we're going through. Especially since most of the breaths that we're taking in are about 90% are happening indoors, and indoor air can be 2 to 5 times as polluted as outdoor air. Yet, most of the tools that we use to sense and understand the air quality around us are really remote, right? And so we got an image right here of one of the 4,000 federal regulatory monitoring machines that the EPA and other state governments around the country operate for over 330 million people. And then on top of that, we've also got this over here is the MODIS satellite. And what that is just like one of the satellites that NASA uses to try and get a better understanding of particulate conditions in North America. And so these things are cool. They've done a lot of good, especially thinking about the regulatory systems that we've had that popped up around the time of the Clean Air Act. What that's resulted in is a much cleaner outdoor air for most Americans. There's still a lot of work to be done though. Not just indoors, but also thinking about the airs that you're actually going to be breathing yourself. So with those tools, we get the air quality index, right? Which is the main communication layer of environmental hazard to most of us. And I don't know about y'all, but for me, this is like never really quite cut it. This is just like a screen grab from like not too long ago on my phone, but air quality index is 36, which is better than yesterday at about this time, right? Completely non-descriptive, not really helpful. And again, I'm always thinking about vocabulary and the different types of language that we could attach to these types of things, aside from just like satisfactory. And so for those tools, thinking about like air quality as the translation layer, for me became an important part as I was going about this process of building, not just for myself, but for others as well, and trying to engage other people in projects that allow them to understand the air around them. I started stumbling into like other ways that people are starting to think about air quality, and including one of the projects that I was working on in Salt Lake City a couple of years ago. One of the participants in this project, and I'm going to get to it a little bit later, she ended up designing her own personal air quality index based on her husband's farts, right? And so this is the type of thing that I'm trying to get at, is through different types of like measurement tools and really just like taking the numbers that you're looking at, but also more importantly, looking at the trends that are inspiring you and looking at the different air events and episodes that are happening in the air. If you can start to name those and call those out, you can start to put yourself in a process of being a little bit more proactive about what's going on around you if you can just go about the process of naming it. And so I'm going to be speaking about, like her own air quality index a little bit later based on these farts. But these are the things that are possible, right? As you're getting into this, you don't just have to stick to government standards and things coming off of apps when you think about the air that you're breathing, but you can come up with your own nomenclature and ways of thinking about this stuff. So all that to say, to get at this idea that you're not actually breathing data. I think so much of the work that so much of the effort, a lot of the money that we've put around air quality monitoring over the past few decades has been spent on visualizing something that's invisible. which is why when you check out air quality maps and we have the color codings for the AQI and whatnot, all of this stuff is important, but I think there's a bit of a fetishization happening around like the actual data itself. And instead of thinking about the data, I'm trying to like make it a little bit less visual and more sensible, right? So thinking about the ways that things are impacting you, and more importantly, thinking about the different types of ways that you're actually impacting the air around you that's going to come back and impact you. So we are exposed to a lot of different components in our air, usually as a stand-in when, again, like the chemistry of air is always going to be really complex, even like a simplified context. But one of the things that's happened is oftentimes when people are talking about air quality, they're kind of just thinking about particulate matter as a stand-in for everything. So thinking about particle pollution. So this bad boy that I built right here is focused on PM 2.5 and PM 10. But again, it's just a lot more complicated than just what we're looking at right here. But for the purpose of the rest of my talk, just going to be focusing on PM 2.5. And just a couple of things about that. I'm not sure where everybody is when it comes to like your particulate matter pollution and your literacy around like other pollutants. But when it comes to particulate matter, the key to know is that the damage is in the size it is. So the smaller the particle, the more deeply it can penetrate into your respiratory and cardiovascular system. So you'll see like right in the middle, we have PM 2.5, which is any particle that's going to have a diameter of 2.5 micrometers or smaller. PM1, which is also going to have a diameter of 1 micrometer or smaller, and then obviously the same concept for PM10. And so thinking about the differences in these particle sizes and what the different types of damage that they can do to you, it's important to think about what's happening on around you. And so PM1 and PM 2.5, because of their size, they're more likely to cross over into your respiratory and cardiovascular system, especially PM1, which is showing, a lot more research is showing its tendency to be able to cross the blood-brain barrier and actually have cognitive impacts as well, not just cardiovascular and respiratory. PM10, on the other hand, because it's usually the product of more coarse particles, so think about out here in New York, there's always somebody building something, so a lot of the construction dust is usually going to be more PM10 than PM 2.5. And so while these can do damage to you, it's much more likely that the PM10 is going to be stuck in your upper respiratory tract or kind of like at the back of your throat. But when PM 2.5 is popping off, it's important to think about not just the size, but a lot of research is coming out that's highlighting the importance of the actual chemical composition of these particles as well. For the longest time, the only thing that we were really focusing on was the actual size and the diameter size and how far these things could penetrate into the body. But one of the things that's been happening over the past few years is a lot more people are learning through their own personal research that when it comes to the actual components in the air and what PM 2.5 is composed of, you're going to have different outcomes. And so, for example, we'll just say PM 2.5 particles that are a product of car exhaust are going to be more dangerous to you than PM 2.5 particles that are a product of the olive oil that's spraying up whenever you're cooking something, right? For the longest time, we thought the size was everything. Now we're learning that the actual chemical composition is just as important. Now, why is all of this important? Like this idea of trying to get a better sense of your own personal air quality and what's going on around you. I think for me, one of the most important things that I notice, and it goes beyond anything with air quality, but environmental sensing and climate change in general, we don't seem to have a good sense of what we're actually doing to the environment around us. I think by developing better practices of paying attention to what's going on around you, you can also be a better steward of your environment, not just for yourself, but for other people. Because in these personal connections, these are the things that put us on a path to actually identify different types of things like environmental inequities, like pollution inequities. Because I think too much of our pollution discourse revolves around personal exposure levels and how can I protect myself. And that's the type of stuff that pushes people into buying $400 air purifiers, right? Just leaning into the individualistic, capitalistic way of just like a race to the bottom of what can I do to protect myself. But there are alternative ways and frameworks of thinking about this. And if you can develop these patterns of noticing your impact on the environment and the ways that it comes back to impact you, more importantly, what are the ways that you're impacting the environment that are gonna end up impacting other people who you may not see or may not even know? Because if there's one thing that we know about air, it doesn't know any sort of boundaries, right? No such thing as your air versus my air versus your air. We're gonna be switching it up all the time, right? So in terms of like thinking about these different types of pollution inequities, I think taking a note first and foremost on the impact that we're actually having on the environment around us can be a really positive step. And I think, that's not on an individual level, but thinking about the actual impact on a larger level, right? We have a good amount of research that suggests that the folks who consume the most and are just like constantly buying stuff and having stuff ordered to us, having stuff ordered to them, their impact on air pollution is higher than the folks who aren't ordering as much stuff, right? And so thinking about the impact that you're actually having every time you want to make this order on Amazon or anything else, it's not just the package that you're getting, but also the last mile delivery that's happening. And if you're ever curious, there's a lot of really good research reporting coming out of the team from Consumer Reports about this, something really similar to this, out in Red Hook, Brooklyn, where they've been looking at the impact of Amazon delivery warehouses and the impact that the trucks going to and from the warehouses as they're delivering goods to other folks throughout the borough of Brooklyn, the different types of impacts it's having on Red Hook, Brooklyn residents. And again, these aren't the folks by and large who are like ordering all this stuff, but they're bearing the brunt of the pollution that's happening from it. Here, I hope this is okay with everybody. This is just like a little bit on regulation, just trying to give a little bit of context. So what we're checking out right here is the EPA's National Ambient Air Quality Standards from 1997 up until today. And what we're looking at, I want everybody to, this is not an actual like measurement, but think of this as like a speed limit. This is the limits that the EPA sets on what should be considered a good amount of like raw concentration of PM 2.5 on an annual level. And you can see there's been a lot of work and a lot of change that's been happening over the past like 3 decades or so. Because in 1997, EPA started off with 15 micrograms per cubic meter for PM 2.5. In 2012, that got revised down to 12 micrograms per cubic meter. And as of February of last year, we are currently sitting at a really good benchmark of 9 micrograms per cubic meter of PM 2.5. Now, that may not seem like a really significant thing, just this drop from this tightening from 15 down to 9. But the EPA estimates that by 2032, tightening the standard is going to save about 4,500 additional American lives each year and cumulatively prevent about 800,000 hospitalizations for asthma over this time, right? And so these are the types of things that we're thinking about. Small concentration volumes can have an outsized impact on what's going on and what's the ways that things are going to be impacting you. And so every little bit counts. Now, saying that, we're at 9 right now as we sit, but there's a lot of epidemiological research and a lot of activism pushed out there by environmental justice activists that shows that we can actually tighten the standard to 7 or 8 micrograms per cubic meter and save even thousands of more lives. But we haven't, right? And so a lot of this regulation stuff, while there has been a lot of success, is still a trade-off. And so thinking about the different types of trade-offs that we've had to historically go through, and now where we're sitting at right now, as we're looking at a situation where our responses and resources to chronic air exposure and air pollution are just kind of like thinning out. We're seeing the rollback of environmental protections, the budget cuts at the EPA, and seemingly it's an agency that's like dissolving right in front of our eyes. I think one of the important things that everybody should take away is the fact that you're going to have to get a little bit more active about this stuff, right? You're going to have to start thinking about your own personal air quality a little bit more, because the traditional authorities that we've come to entrust with telling us what's going on are quite literally just dissolving right in front of us. So what can everybody do? I think everybody in this room is in a very special situation where no matter where it is, you can get involved in this fight against like air pollution and trying to think about different frameworks of engaging like your air quality. If you're thinking about hardware, you can try and put together like your own air quality monitor, think of different types of ways of going about a calibration process that you can share with other people. If your bag is software or design, you can come up with different ways of getting data from point A to point B. You can start to thinking about different types of indices and visualizations that'll help this stuff become a little bit more material and more personal for people. Or even if you're in a policy, thinking about different types of ways of engaging policy briefs and ways of adding some sort of like qualitative data to the quantitative data that we're usually picking up when it comes to air quality. So no matter who you are, you can get involved in rewriting this narrative anytime that you'd like. So what you're looking at right here is an air quality monitor that I designed for a collaborative project in Salt Lake City. It was a collaboration between the Salt Lake City Tribune, NPR Utah, and the Utah News Dispatch. And each newsroom was thinking about going about climate narratives a little bit differently. And they each wanted to get away from this traditional story of, well, air quality is really bad. Okay, so what do we do with that? And so working with these newsrooms, I decided to pitch an idea where I would just design bespoke air quality monitors for folks who actually were interested in their own indoor air quality, get these monitors into people's homes, and then from there try and get a sense of what was not just going on, but the different ways it was impacting people and their feelings that they were taking away from as they had a little bit more literacy and knowledge about what was going on with them. So we're going to be talking a little bit more about this in a bit, but what are we going to get into in terms of like hacking and just putting together different types of devices? There's an entire suite of like tools that you can pick up from SparkFun, Adafruit, DigiKey, a lot of different components that are open source that you can just pick up and start getting into your own process of putting things together. And I want to like put out a word for, putting together your own air quality monitor rather than just buying something commercially comes with a few different benefits. One, you can actually build around the pollution of your own interest. A lot of the things that are commercially available are only going to speak to particulate matter, but if you happen to have an ozone issue that you're concerned about, it won't necessarily speak to that. If you can identify and work on identifying the different things that you're interested in, the pollutants, you can build around that. It's also going to save you a hell of a lot more money. The little monitor that you're looking at right there is the same one, if you're familiar with the Purple Air network, the same sensor, that air quality particulate matter sensor that they use in their networks. It's called the PMS 5003. This bad boy usually runs anywhere from $30 to $40, and it's one of the most ubiquitous particulate matter sensors on the market. You'll see it pop up in a lot of different commercial objects. Thing is, a lot of those air quality monitors can sell for $250 to $300, right? And oftentimes they're just a $40 sensor shoved inside some PVC. So if you're looking for like something to be a little bit more cost effective and also just give you the advantage of being able to like stay on top of what's going on, because a lot of the monitors that you buy off the shelf, they're not really gonna allow you to like open things up. Trying to do like a tear down is not really, it kind of wants you to just go out and buy like a new monitor, but that's not really what you need to do. If you can actually just develop a literacy and familiarity with your own particulate matter sensor, there's a lot of resources online that can help you to like get into it, crack it open, clean it out. Because one of the things a lot of people don't consider is when it comes to especially particulate matter sensors, and they're usually, a lot of them are operating by sucking in like little samples of air into a little chamber. And if that chamber becomes too clogged up with too many particulates, and if it just sits there, you're going to start to notice some drift and data inaccuracy from the data that you're getting from the air quality monitor. So no matter what you're doing, whether you're building your own or whether you're going to be out there buying something off of the shelf, if you can crack into these bad boys and actually clean out that internal chamber, that's going to be one of the biggest keys that you can actually go through to actually make sure that you actually have good data for more than like a year. So this is a really simple circuit, the foundation of what I was building off of, and just wanted to, put this out there for really. This PMS 5003 is a pretty good particulate matter device if you have an ability to like co-locate it and calibrate it. Aside from that, the only couple things that you would need to get going and start getting data out of any of these devices would be the actual particulate matter sensor itself and a microcontroller of your choice. Now, I'm choosy, I like the ESP32, but if you want to rock with the Raspberry Pi or an Arduino, that's totally on the table as well. You can get down with that. But the key thing is that this is a really cool and like really simple sensor to work with. Utilizes the UART protocol. So you really only gonna have to like hook up 4 wires. Actually only 2 because ground and voltage are gonna be a thing. But thinking about just connecting your serial data and serial clock from your particulate matter sensor to the microcontroller via jumper wire cables, and then you're gonna start automatically getting some data out of this bad boy, right? And this is just a quick example. Damn, this is scrolling real fast. By the way, I'm going to be around. If anybody wants to talk a little bit more about this, I can talk a little bit about the interpretation of the data, putting your own air quality monitor together. But when it comes to like dealing with the time stream data, as things are coming out, you want to get a sense of exactly what you're interested in. Again, for me, the purpose of this project, I was focusing primarily on PM 2.5 and just focusing on that bin bucket in that data set. And so for me, I think one of the things it's important to note is that the actual individual or like isolated event, not really all that important. When you start to tie together a sequence of events and start to put those into like air episodes or trends that you're noticing, then you can start to develop a little bit more meaning and literacy about what's happening around you, right? And I'm gonna get into some of these projects that I designed for these newsrooms in Salt Lake City right now. Sorry. Yeah, so again, the purpose of this project was to go about helping folks develop a different type of vocabulary around their indoor air quality. Salt Lake City, the Great Salt Lake is drying up, introducing more pollutants into the air over there. And then there's also a situation where the town is in a valley, right? So it tends to like trap a lot of pollutants that are in the air. So it's one of those unspoken regions where there's actually a pretty significant and severe PM 2.5 issue. And these folks, these newsrooms just wanted to get about like a different type of narrative than the ones that we're usually used to when it comes to reporting. Not just the alarmism, but I wanted to try and get an understanding of what was going on with people. So the way that I went about that was designing a set of air quality monitors. Once we got them in people's homes, I was logging data and also working with people on helping them to interpret and understand the data that they were going through. One of the most important things that I got folks doing is because of my background in journalism, and again, I like to hear people talk, I had everybody diarize each day, right? Taking down diary notes of not just what they were noticing on the dashboard that I gave them in their air quality monitor, but also getting a sense of like the different types of activities that they were going through over the course of a day. And just even like this little push right there was pushing folks into a position where they could become like a little bit more familiar with making different types of associations between the things that they were doing and the different types of impacts it would have either on their carbon dioxide levels or on their PM 2.5 levels. So I'm going to get into a couple of those households right now. So one of the households that had one of my air quality monitors, what we ended up doing was kind of just like showing like there's no such thing as pure air. Again, I think when you're buying something like an air purifier, it kind of promotes this idea that there's some sort of like pristine or clear air. Not a thing, there's always something going on. And working with this household, they had an air purifier and they thought their PM 2.5 levels are going to be like really, really good. So actually particulate matter wasn't all that much of a concern for them, which is true. But I showed them over the course of 3 months and just like taking like high resolution data over the course of these 3 months that indeed their PM 2.5 levels were down, but because they had a purifier and the air purifier promoted a behavior where they decided to consistently keep like their windows closed, what they ended up having were elevated carbon dioxide levels, right? So there's always a trade-off. If you're not going to have PM 2.5, there's going to be something else that you might want to be concerned about. And these are the types of things that I just, again, want to like highlight and front load because these are the types of things that we're not really thinking about. And the folks who are selling us expensive devices aren't really interested in telling folks. So it was fun, just like working with this household over the course of a few months and having them get a sense of the trade-offs that are happening by having this purifier. Particulate levels are going to be low, but your carbon dioxide is going to be a little bit higher. Another one of the households that had one of these monitors, I noticed a trend every night around 9 p.m. Really severe jump in PM 2.5 in a household that was otherwise pretty good. I think around 8 or 9 micrograms per cubic meter on average, but there would just be a consistent jump to around between 14 to 15 around 9 p.m. every evening. And so working with these folks, I asked like, what was going on? Like, what am I seeing right here? What's good? And they told me that these partners, they had their love language. One of the things they would do right before bed every night was they would roll a spliff and have a smoke and then go to bed, right? And it could pick that up in the particulate matter sensor and the data that I was picking up. Now, never gonna be my bag to try and have any impede on anybody's love language. If that's how you get down, by all means. But the important thing for me, once we can start to notice this trend and highlight it, there are different things we can do to be a little bit more proactive about what's actually happening. And so after noticing this and speaking with this household, one of the things we did was just like, hey, a really simple opportunity to, if you're gonna smoke, do your thing, but make sure you turn on that overhead ceiling fan before you smoke. Make sure you open the balcony doors and just promote like a little bit more ventilation. Or, let me just say, or just switch to edibles. That's the whole thing too, right? But yeah, and so what you get from that is after we started to like notice this trend, we started talking about it, and then we just came up like a really simple mitigation factor of just, hey, ventilate your space before you're gonna do what you're gonna do. We had a significant drop, right? From 14.5 down to an 11.5 micrograms per cubic meter. And again, these may not seem like big drops, but 3 microns of chronic exposure over time is a really significant thing. And so these are the types of behaviors that we wanted to promote by just being able to associate, hey, the simple thing that we're doing every night, we didn't know the impacts that it was having on us, but there are impacts, right? And that goes for everybody and everything. It's not just smoking a spliff, but also lighting incense, lighting candles. So many of the different things that we're doing in our houses that make a home are gonna end up polluting our air a little bit, right? Especially if there's a combustion process involved. That doesn't mean you should necessarily pull back and not live your life. You need to enjoy the space where you live. You need to be in your home. But at the same time, you can start to develop different types of associations with these activities. You can start to mitigate in a preemptive way.
A lot of people don't think of air fresheners. That's another thing that pollutes indoor air pretty nicely sometimes.
Yeah, absolutely. Okay, absolutely. We got air fresheners, and this is another thing. In this same household right here, aside from the smoking, there was also a correlation that we started to notice between, I think, Thursday and Friday nights, when they would get ready to go out, and just started to notice things like dry shampoo and a lot of the stuff, hairspray that they were utilizing, PM 2.5 levels just skyrocketed, right? And so again, get gussied up, go look cute, but there are different things that you might want to do before you start getting ready to go out. And right here, coming back to the farts. So at this one household, a woman's husband comes home. He just wanted to let off a little bit of steam after a rough day of work. So he wanted to be a goofball, and he thought it would be cute to just like let a fart rip right into my air quality monitor. Cool beans. And when he did it, the PM 2.5 levels jumped up to 25 micrograms per cubic meter, right? Now, I want to be clear, his flatulence actually didn't have anything to do with that. If you have a stink booty, it's actually not going to get picked up by any particulate matter sensor. But what probably happened with that is when he was farting into it, probably kicked up like a little bit of dust, and that's what had the particulates spike up a little bit, right? We could do that too. We could build around that as well. Yeah, so just like noticing this jump up to PM 2.5, this is pretty early on in the project that I was building with this household, right? And so it became important for this person when she started to notice that, hey, my husband's farts produce about 25 microns of PM 2.5. Let me start getting a better grasp on other things and associating that number with other things that are going on in my environment, right? So these are just some of the things that she was saying, like cooking dinner, that's about 2 farts. Burning incense, 1.5 farts, right? And so over the course of 3 months in this project, she just started to think about every little activity that she did. When she would notice any sort of consequence on the dashboard, she would start to relay it in terms of her own like husband's farts, right? And so for me, this is like a big success. That way to like make things more personal, more material, and pushing in a way that you can actually understand the PM and the air around you was a really, really big success story for me. And I'm glad that she took that with her. Because she said, and it's funny, but it's also made the data real suddenly. Those numbers weren't abstract. They had a reference point we could picture, laugh about, and compare against. And again, if you can find these types of ways of making air a little bit more material and personal for you, you can come up with your own ways of doing something similar. So I am talking a lot, but I'd love to make this an invitation to just like hear from you all as well. So I'm just gonna like stop right here and let's do some Q&A. Please.
This is a great talk.
Thank you.
I'm wondering, you had mentioned the article about the metal toxins in LA. In my understanding, part of the concern with the Great Salt Lake drying is arsenic. So I'm wondering if the ship you mentioned, like what the breadth of the pollutants that it detects, and if you see improvement in the space that could be for the consumer grade sensors.
Totally. I think, again, this what I put together for this project primarily focused on particulate matter and carbon dioxide, and also picked up on relative humidity and temperature. But again, there's an entire like suite of different pollutants that you can buy sensors for to pick up on. Mm-hmm. I'm sorry, I think you had a second part to your question.
Oh, I was just gonna say, are they in the similar $30, $40 price range for maybe the more specialized sensors?
No. I think the technology for particulate matter sensors is a little bit further along than like others. So if you were to buy a sensor for like ground level ozone, you can probably get one for like anywhere from like $45 to like $60. But with like a lot of the particulate matter sensors, they're usually going to be a little bit cheaper than other pollutants that you're trying to measure for.
Thank you.
Yeah.
Could you say anything about VOCs, volatile organic chemicals?
Yeah. So the question was asking me to like talk a little bit about VOCs, which are volatile organic compounds. And again, that's another great starting place when you're trying to think about your indoor air quality, because so many of the things that you're going to be doing indoors are going to produce VOCs. And that'll be things, again, like hairspray. It can be oftentimes like a lot of off-gassing from the furniture and different things that you have in your home. They're going to be, contaminating your space with VOCs. And so there are definitely like a good amount of like sensors out there that can pick up on different volatile organic compounds. By and large, they're usually not going to be, I think the ones that I've usually come across, they say a little bit less about the actual particularities of the pollutant the actual organic compound that's being measured, but they all usually have like their own proprietary index, where they're just like trying to take an entire like chemical cocktail of different VOCs and put that on a scale that you can try and like make sense of. But there are definitely VOC sensors out there.
You had mentioned that you need to clean these particulate sensors
Yeah.
fairly frequently, maybe.
Mhm.
How did you determine like how often they need to be cleaned? How did you communicate that to people?
Yeah, so I think one of the things, even with this bad boy right here, it can be a little bit difficult, if I'm being honest, to get into. Again, because when you start getting into it, you don't want to actually mess anything up. And so if you have like any sort of experience with like tearing down hardware, I'd say go about it like that. There's also some tutorials online that you can get into. But in terms of like frequency, I think it depends on the actual like sensor that you're going to be utilizing. But I'd say by and large, every like 9 to like 12 months if you have an opportunity. But again, I think this is also kind of contingent on what it is that you're actually going to be having come into it. If you're living in a space that does have relatively like low levels of PM 2.5, the internal fan chamber probably won't get as clogged up. But if you're noticing you have like a lot of data going, like you have a lot of particulate, high levels of PM 2.5, that's going to put you in a position where you want to be a little bit more proactive and a little bit more responsive to trying to get in there and clean down this internal fan chamber. So I think a lot of it is just contingent upon the actual like sensor that you're using and the environment that it's going to be deployed in.
Yeah, I guess in your case, maybe you weren't asking them to do it.
No, not in my case. Also for the project that I did in Salt Lake City, these were running for only like 3 months. And so at that point, it really wasn't anything to like try and tear down at that point. But I'd say when you start pushing, closer to like a year or so, no matter your situation, you want to start to think about that. Hey, Fred.
So kind of along those lines, how do you calibrate it? If not like officially, is there some standard like light a match, light a candle, you know what you should see?
Totally. So the question is about calibration. I'll be honest, I was really fortunate. I was a researcher at Columbia University, and so I just started like hanging out with some folks over in the atmospheric sciences department, and I had a really cool opportunity to co-locate my air quality monitors alongside some scientists who had like calibrated sensors, which is how I got my calibration process. But I understand that's not something that everybody can do. So a couple of things on that. If you are absolutely thinking about like data integrity, going about the calibration process is important. But again, with these sensors right here, depending on what you're going for, I think you can get away with, you can get away with not actually having like absolute fealty in terms of like the data that's coming out, right? Like you're gonna wanna understand the data, you don't wanna have things that are like totally off balance and totally out of whack. But I think by and large, between the responsiveness and the responsiveness of these types of particulate matters, you can start to pick up on the different types of trends that are going on around you and develop a different type of like signature of what's happening in the air. Because even like on a stock value, each of these bad boys is gonna be like a little bit different coming out of the box. So I'd say the only way that I've come across when it comes to the calibration process is one, if you can come across some sensors that's already been like calibrated before and just like co-locating like that and getting something, that's your best bet. Aside from that, I've seen other people toss things up online, like different calibration factors for if you are measuring for PM 2.5 and you want to use the relative humidity and temperature as ways to help you to calibrate, there are different types of algorithms that you can deploy on that front as well. Now, I've seen people doing that. I haven't personally gone about it that way, but I know that that's something, if you don't have access to co-location ability, it's something you can do.
Yeah, but then again, keep in mind, as you were saying, it's good. The exact value is less critical than seeing a change.
Mm-hmm.
If you get an approximate number from one of those references, that's good enough. Look at it, if you have a bathroom scale, and it's not quite accurate, you don't care so much if it's 80, let's say 180 versus 183. You're worried about, did it go up from one day to the next? Were you 183 last week, 186 the next week? It's the change that matters a lot more. It's the same thing with this mostly.
Totally. And that's what I'm getting at. It's more significant to think about these changes and what you're actually picking up. Because again, the actual particulate matter sensors operated by the EPA that I showed a little bit earlier, each of those devices is anywhere from $30,000 to $40,000 for a machine. That particulate matter costs about $30, right? So you're gonna get what you pay for. Which isn't to say that you can totally like trust what's coming out of it, but I think the legwork that you put in on interpreting what's coming out and what's significant to you is where you want to put the actual emphasis and value in your own personal air monitoring process. Can I get you back here?
Yeah, recently there's, been a big uptick in skepticism around science-driven approaches. Can you hear me?
I'm sorry, I can't really hear you all that well.
Recently there's been a big uptick in science-driven sort of, I guess, approaches or expertise around both environmental sorts of things and health-related impacting things. Did you engage with any people who were like kind of deep in that and were able to like move the needle with them?
Was I engaged with anybody who was thinking about like health and like science? I'm sorry, I didn't.
Like people are really skeptical of science-driven approaches to
No, I hadn't. Like, maybe I'm just like really fortunate because I feel like everybody I speak to, like when I talk about like, I do stuff around air quality, they get super geeked about it. Like, I've never met anybody who's like skeptical, like, no, stay away from that. We don't want to touch that. I think by and large, everybody's been like really cool. But that's something I haven't come across that I'd love to wrap a little bit later. Okay, great. Thank you. Please, Frank.
Hi, you mentioned that the air purifiers aren't the silver bullet for this. Would you recommend like continuous extractor fans in houses? In addition, have you looked into any kind of detoxing from this?
I think the question was about different types of devices to purify aside from like air purifiers?
Yeah, like, you mentioned that the particulates indoors are higher than outdoors.
Mm-hmm.
And I was wondering about, bathroom extractor fans, you can get them that continuously run to replenish the air, I guess.
Mm-hmm.
Would you advocate them?
To be perfectly honest, I haven't considered that. I'll be perfectly candid. Over the course of like my research, I haven't considered anything like that. I think a lot of the folks who I've been working with, there's oftentimes like one of the more pressing things that they have to deal with is the fact that they can't afford like more expensive technologies, right? So one of the simple things that folks have to do is just like thinking about more simple solutions of like productive like ventilation of spaces. And so if you have the ability to like buy different products and actually have like the wherewithal to install it in your home, that could totally be a thing. But I think a lot of the folks that I've usually worked with are usually just trying to think about like more simple processes. Right.
Does it essentially wind up being kind of a balance between where the air is better at what point in time? At what point is it better to open the windows to sort of ventilate, and at what point is the pollution outside worse than whatever off-gassing or whatever content you have inside?
Totally. Yeah, I think this is a question about the interplay between indoor and outdoor air pollution. Yeah, this is one of the things that I looked at for this project in Salt Lake City. Is like taking data from like outdoor sensors and seeing what the impact would be on folks' indoor air quality. And I think that's absolutely something to like take into consideration, even outside of like these like wildfire events, but even thinking about one of the households I worked with in Salt Lake City, their neighbors were like barbecuing a lot in the summertime, right? And then this barbecue smoke would come back and impact them. And so they were really interested and curious about that. And so it became a situation of, yeah, sometimes when like we know where they're going to be out there barbecuing on like Thursday evenings, we're going to like close the windows for a specified amount of time. And then when they get done with their stuff, we're going to open things up. But I think if you ever have an opportunity, yeah, it's not just about the indoor air quality that you have, but if you're able to like complement that with what's going on outdoors and try and put both of those into conversation with one another, that puts you in a position to have one, not just like a more holistic understanding of what's going on around you, but also being able to like think a little bit more about when you should ventilate and when you shouldn't. Because if the outdoor air is really bogus and bad, the last thing you want to do is going to want to crack the windows. Unfortunately, for a lot of people, that's kind of like the only scenario or situation they can find themselves in. But if that's not you, yeah, the ventilation process. Is she back here?
Yeah. Did you have multiple sensors throughout the house, or is there like a particular part of the house where you think it's more important to be tracking this kind of stuff, like the kitchen maybe, or the room where you're sleeping? I don't know.
Yeah, for this project, I worked with people and so the question was about, did I have like multiple sensors and monitors in people's homes? For this project, each household only had one, and we placed it based on folks' curiosities and their own priorities around their own individual air quality, right? So one of the households had a school teacher who also just like did her own art projects, like her own like water paints and like oils and stuff like that. And so in like her art space, we had like one of my particulate matter sensors to pick up what was going on. And we could like notice things whenever she was applying fixatives to like any of her like art. Other households, we had like in the bedroom with the smokers right there, which is where they had theirs. And so for me, this project, and I'd also advocate it for anybody, thinking about where your own priorities and curiosities lay, because that's something that I feel like I've come across. Everybody kind of like has their own curiosities about a particular room that they don't spend a lot of time in and stuff like that. I'd say building in like placing one sensor there. In my own house, I have a few of my own things that I've made, just kind of so I can like try and get a better understanding of how things are changing over the course of the space. And I'm sorry, I think I cut you off in the back with the red.
So outside of individual action, what do you do with this data? Do you take to City Hall? Could you combine this with, I don't know, the more bicycle infrastructure, advocating for stuff like that? What would you do with it outside of just, for your own gratification?
Me personally or in general? Because the answer for the question is, what would you do with this type of data? I think you can do anything that you want. Again, and I don't mean that to be a cop-out, but if you can start to attach the qualitative associations with the data that's coming out at you, you can start to go about advocating for different things that you want to. This is
maybe time for one more. But.
Okay, cool. No, I just didn't want to keep going. Yeah. Cool. So I think for me personally, the ultimate goal is to produce different types of data sets when it comes to regulation, when it comes to different types of resources from government, oftentimes the only type of air quality data we have is going to be quantitative. But I think the qualitative stuff is important, right? So when I mentioned the consumer reports reporting a little bit earlier, one of the products of reporting like that, by adding different types of like very specific neighborhood associations and people's qualitative experiences of having Amazon trucks on their streets all day, every day, is they can start to promote different types of definitions of what like warehouse pollution is. Because the way we're usually thinking about warehouse pollution is actually like the edifice itself in the warehouse, and not really thinking about the truck traffic that's leaving and actually dropping packages off. But I think that's something I've seen a little bit more in environmental justice circles, is actually trying to like combine the impact of the transmission of like the transport of goods and associate with that with the warehouse in and of itself, and started having a more expansive definition of what's going on when it comes to warehouse pollution.
Todd's going to be hanging around for a bit,
Yeah.
right?
Yeah.
To wrap,
Cool.
To follow up with some questions you all have. Thanks for coming.
Thanks, y'all.
on her talk here, Design for Neurodiversity, Creating Neuro-Inclusive Spaces. It's going to be exciting. Have your question, data scientist. So she's got some great stuff for us today. Give her a good welcome and take it away.
All right. I'm very honored to have been invited on the program. And I know this is not an average talk, but I think in Tobin there have been several talks related to psychology, and I find that very interesting. I think psychology is a perfect match for helping us understand how we can work better together. So for this talk and for some of my values for approaching the subject of neuro-inclusivity, I've been thinking about awareness, inclusivity, training, civility, fairness, and also flourishing, because I think that ultimately we want to use technology and the arts to create better societies, and in order to do that we need to understand ourselves better, and we need to understand how we can work together better. So my purpose for presenting this talk is to discuss a subject that I think matters to many people, that has not been previously discussed in this conference as far as I know. And in the intro to his book right here, Neurotribes, Steve Silverman discussed the tireless curiosity of a tribe of industrious hermits who invented the modern digital world. And in his introduction, he describes hacker communities and specific retreats where geeks got together and formed communities through the internet, and how that relates to the subject of autism, which is a complicated subject. I have been exploring madness as a subject in my research, and there's all of these different depictions of mad scientists, right? The mad scientist, it's like an archetype. Some screenshots from Maniacs, 1934, Cyclopses, we have mad scientists in cartoons. I've been thinking about the relationship between depictions of madness and disability and genius, because I think a lot of depictions of genius and information workers have also depicted madness and disability. So I've been exploring this in literature and images. I was thinking about Rain Man and different pop cultural moments where savants were sort of popularized in the public eye, and Dustin Hoffman and Tom Cruise made this huge movie where Hoffman was this savant learner, brilliant man, but also very misunderstood by society. And I was even looking at Magic the Gathering cards, and this is an archivist card, and there are all these archivist cards where they're halfling creatures and disabled and mad archivists and information workers. And so why is it that librarians, data scientists, information workers have been depicted as geniuses and also disabled folks in all different kinds of cultural contexts? So this is just a Wikipedia screenshot, but there's this concept of sanism or mentalism that refers to the discrimination and oppression of people based, Why is it cut off right now? Can we fix that? Oh. Okay, I'm not sure what's going on there. Anyway, based on actual or perceived mental disorders or cognitive impairments, this discrimination and oppression are based on numerous factors such as stereotypes about neurodiversity. So I was thinking about this concept of saneism and how it's approached in our society in relationship to information workers and computer scientists and hackers. And marginalization and biasing may appear in a lot of different ways. So ableism is something that's discussed in disability studies, which is more about how ability is distinguished. And then we were just discussing mentalism and saneism. People also use other words to describe discrimination, such as stigmatization. Masking and camouflaging is an area of interest in the subject of marginalization and biasing because sometimes people do not express their needs because they need to protect themselves, and that can result in other kinds of marginalization. So these are, I'm not going to go into all of these bullet points. I have a lot of text because I was taking the Staten Island ferry and was trying to get my images to load and they wouldn't. But anyway, an important point is that the presence of the neurotypical gaze, the presence of non-autistic researchers may transform the autistic space, as the autistic space is fragile to the neurotypical gaze. And I was thinking about this a lot in the communities that I live in, where people understand each other, but then when other people enter that may not understand neurodiversity, it does change the environment and people may not be able to express themselves in the same way. So there's all sorts of biasing factors that may occur. And we know from much research that neurodivergent people face inequities in work and society. In a study analyzing a sample of 25,000 people in the UK, Brannicky et al. Found that neurodivergent people are twice as likely to be in precarious employment and are more than 10 times as likely to be in temporary employment, in addition to being significantly more likely to experience underemployment. So there's a lot of research about how the relationship between autism, ADHD, OCD, and many other kinds of expressions of what we might call neurodivergence and the relationship to employment. So in this talk, the problem space that I'm going to continue to discuss, it's related to stigmatization, but also what I found from writing accessibility guides myself and writing accessibility documentation, that I found that accessibility guides do not focus on neuro-inclusivity. They focus more on legal definitions of disability, which hardly include any psychiatric diagnoses or psychological diagnoses. We do not have, nor do we necessarily want to gather stats on neurodiversity in our communities either. So when I've been doing this research, people are always like, oh, so what % of programmers are autistic? And I was like, do you really want us to do that research? I don't think that would be, some people have tried, but I don't know if you're gonna do a good job at that. Some people have tried. Accessibility funding is also in the decline right now, at least in the US. So this is kind of negative stuff, but we are gonna arrive at some more positive stuff. So, for instance, Vikram Jaswal from the Department of Psychology at the University of Virginia spoke in a review about this book. He spoke that the legacy of autism is not a happy one. Throughout history, autistic people have been misunderstood and marginalized, isolated and ignored. They have been bullied by peers, abandoned by parents, and murdered by the Nazis. They have been the subject of and subjected to some of the worst treatments and science imaginable, involving everything from chelation to electric shocks, and that's just within the last century. And I'm speaking about this because it's very close to my heart. So, now we're going to proceed to attempt to define the concept of neurodiversity and related terms. And the purpose is to increase our awareness. And we're also going to explore the implications of neurodiversity for design in our computational communities and other communities. So I did not introduce myself yet. I have 13 years of experience in open source communities, hackerspaces, and decentralized communities. And in these communities, I've developed anecdotal experiences, which I've come to trust because in feminist research methodology, it's important to take your emotions and address them and realize that your emotions matter and that they can tell you something about the world. So I've been thinking about these topics related to neurodiversity and autism in computational communities and hacker communities because I have been in these communities and I have talked to hundreds of people about this, and I'm seeing some patterns that I wanted to explore in my own research. And then I found a mentor, Steve Silberman, who unfortunately passed away, and I would like to dedicate this talk to him because he wrote this very amazing book called Neurotribes about the history of autism, and a lot of it discusses Hans Asperger's and just how diagnoses work in general. And Steve wrote a lot of liner notes for the Grateful Dead, and he was like living in the Haight-Ashbury, and he was like a gay man who's like so fun. And we really lost a great soul, but he contributed a lot to our understanding of the history of autism as a diagnosis, including as an editor of Wired, where he wrote this article called The Geek Syndrome that was about the expression of autism among youth in Silicon Valley. And there was research done, and I was inspired by this because many of my friends were isolating themselves, and the idea of the geek, I think, is not a very clear archetype. And so I ended up contacting him, and he allowed me to explore the idea of autism among Wikipedia editors. So there's this like really fun, what is it called, web series or series called Asperger's Are Us. And it's about a comedy troupe of people that identified as people with Asperger's. I'm saying that because the diagnoses had changed, but he said in a joke, obviously Wikipedia was written by people with Asperger's. So after seeing that, I was like, I'm definitely going to start researching this. So I recruited Steve and my friend Lane, and we started investigating the experiences of neurodivergent Wikimedians. But then we did all these text analysis of different forums where on Wikipedia people were talking about how Wikipedia was a honeypot for autistic people, and how we agree always to try to really hard to assume good faith when dealing with an editor of the other type from ourselves, and that's easy for us to misunderstand our own abilities. We agree to try really hard to remember that Asperger's, autism spectrum, and savant editors really can have trouble with intuitive interactions and processing of unclear, imprecise, or ambiguous language, and that does not mean that they are thick or disabled or intentionally disruptive. And I was thinking about this a lot because I think there was this perception of Wikipedia editors as trolls that was coming from a misunderstanding, when Wikipedia editors, a lot of them were just people with Asperger's or autism or whatever you want to call it. And then there was like hundreds of forum discussions about this, and the idea that somehow Wikipedia attracts people with autism, and that that it brings people in. So now I'm going to continue to discuss the idea of neurodiversity, and we're going to continue to discuss design after that. So, the wider neurodiversity movement has begun to reposition and embrace a destigmatized conceptualization of neurotypes, representing a diversity of human experiences. Yet, neurodiversity frameworks have yet to be incorporated into existing medical ontologies. So, a lot of people, I think, rely too much on diagnoses, yet language is continuing to evolve with debates about best practices for contemporary usage of terminology around neurodivergent populations. Some members of the neurodivergent community disapprove of some terms which the research community has applied to them. For instance, the term high-functioning autism has been heavily criticized for focusing on deficits and problems to account for human differences. So the idea of high-functioning itself already distinguishes between some that are more intelligent than others. So then you have to have a language to talk about intelligence. Yet, I am from the tradition of disability studies, which would rather focus on people's lived experiences. I'm sorry there's so much text, by the way. There is a tension between attempts to be inclusive when using neurodivergence as an umbrella term, and the value of self-determination in terms of groups themselves choosing to update the term neurodivergence. So I think going back to the idea of inclusivity and collaboration, transparency, collaborating and consulting with community groups can help inform researchers of how to represent people. At the same time, no one person or group can speak on behalf of large populations, even when they may claim to. All right, so going back to what is the history of the actual term neurodiversity? I did a lot of research on this, and I contacted many people to verify these things. And it turns out that the term developed on a mailing list, which was called the Independent Living Mailing List. And it was a mailing list that started in 1991 that people discussed the idea of living with others, like leaving your parents' house and living somewhere else, and the kind of complications and resources and things that you need for that. And people started discussing the idea of biodiversity and how ecosystems end up being much more successful, let's say, or ecosystems end up being much more sustainable when there's more biodiversity. And the same thing goes for how communities end up being much more successful when there's neurodiversity. So that there are disputed accounts of how these terms developed, and people love to coin things, which I really don't like, because you can say, oh, this person coined this thing, oh, this person coined this thing. What about how we're a community and we're developing these ideas together? And I really appreciate Botha's idea that there are multiple origins in collective development for this concept that emerged through the mailing list and the mailing list discussions. So different people that were participating in the mailing list claimed that it was their term, and yet it really emerged from this collective discussion. Armstrong is one of the leading scholars of neurodiversity. He claims that the category often includes autism, ADHD, dyslexia, OCD, dissociative disorders, personality disorders, anxiety, other brain disorders, behavioral disorders, personality disorders, mood disorders. However, me and my colleague Claire Cronk at Mount Sinai Medical Hospital have been developing a corpora of terms associated with neurodiversity, because no one has developed an actual corpora for it. So these are the terms that we've assembled based on analysis of how neurodiversity has been used in science and medical journals. And yet there is no fixed definition. So when people refer to this concept, they may not even know what they mean. For instance, I think, as I said, Armstrong kind of limits it to this. He's not including fetal alcohol syndrome. He's not including hypermobility, which Steve Silberman made sure to tell me that we must include. And Silberman made sure to express that joint hypermobility needs to be represented. And so looking into these categories, it's actually very useful, because if we can develop a corpora of neurodiversity, we can then probably advocate more for folks. However, diagnoses do not translate well and are designed for insurance purposes. So do we want to do the diagnoses thing? Because that's not actually the way that neurodiversity was originated as a concept that was against medical definitions. So future researchers analyzing topics related to neurodiversity should investigate the development of any recent ontologies as ontology projects evolve, including the level of community involvement in shaping the vocabularies, which we have been also trying to do, is include communities in the shaping of the ontologies themselves. Although it's an umbrella category, many terms associated with it emerge in biomedical contexts. However, diagnoses and access to medicine differ internationally. All right, so I'm gonna continue on to, oh yes, this point that a challenge of doing this research on neurodiversity is the tension between striving to be inclusive across types of brain differences when research might involve needing to generate key search terms about unique conditions and discussions about the effect of different diagnoses on experience. So how can we be inclusive and yet be protective of these definitions? So now I'm going to shift to discussions about how we can incorporate our appreciation for neurodiversity into our own communities. Because I was part of discussions about incorporating women into computer science and open source. I was part of these discussions about incorporating diversity and diversity advocacy. And yet, we didn't really talk about neurodiversity, even though I believe from my research and anecdotal experience that a lot of people, I do identify as neurodivergent in hacker communities and hacker spaces and in open source communities. So how can we incorporate this into our design of our own communities? For virtual meetings, using the live transcript captioning features when available. Do not require participants to be on camera. Remind participants to mute themselves when not speaking. Assign someone to be responsible to meeting accommodations and inform participants of who that person is. For the best results, test in advance, including any screen share media. So another thing is, you're probably familiar with these photography policies and having wristbands or stickers to increase consent around photography. The problems are that wrists sometimes are out of frame, people wear long sleeves, and people have disabilities. So these wristbands or stickers don't always work. And this has happened to me where people will, I'll put a red sticker on my badge that says I don't want to be photographed, and yet someone doesn't see it and they'll post it anyway. This happens all the time, so it doesn't always work, right? Another thing is sensory-friendly environments. So what is sensory-friendly? An environment where people are given the sensory input they need to self-regulate and decompress. An environment that lacks overstimulating sensory input. So, sensory rooms it's one thing, but there's also multi-sensory rooms and there's also low sensory rooms. And the way they're characterized is through active, calming, or hybrid. So there's an active room that might involve play and toys or stimulating textures. More calming could be like low lighting and like very comfy chairs and things like that. And then there's other kinds of options that you might have. And you might think of these things as like adult play areas, which we don't actually have at Hope. We don't have like a sensory room, which I'm kind of surprised by. But at BOPST at NYU, they have a low sensory space for students, which is really cool. They've designed multiple rooms that are for students with acute sensory needs. And libraries are highly used by autistic students, and they're amazing space to incorporate low sensory rooms and spaces where people can play and relax. Another thing is that a lot of organizers of events have no training on accessibility, and so they end up not realizing that the spaces are being accessible even when they're trying to be. So I recommend making space in your budget for trainings specifically on accessibility and creating trainings focused on them and providing event staffs with resources to understand terminology related to different types of disability and accessibility and neurodivergent needs. Some other topics that might specifically be carried in the trainings are stimming, sensory hypersensitivity, sensory overload, burnout and autistic burnout, gender differences and neurodivergence, and cultural relativity. And I'm gonna publish a bibliography after this talk on all of this because I have like this giant bibliography of resources, but I didn't have time for it. Another thing that you need to be aware of is that many people don't want to tell you what's going on. And people engage in identity management and information management to conceal and select what they want to tell you. So being aware of when and how you are asking people to disclose any aspects of their identity is extremely important. And I think everyone at Hope kind of already understands that. Before an event, asking attendees about their needs is a very important idea. But in addition to that, actually inviting self-identified disabled and neurodivergent members to participate in the actual planning and compensating them well is important. After the event, creating accessible avenues for actually collecting feedback relating to access and inclusivity. So a lot of event surveys are like very spammy, and they continue to spam you and not really ask the right questions. But if you ask people about how did our event do in relationship to food, access, other services, and actually reviewing that feedback and incorporating it into your event organizing. In addition to that, publishing details about timing and breaks. And one thing that I've had a real problem with at Hope is, and maybe I'm doing it too, is people not knowing how to speak into the microphone. And I have like low hearing too, and I'm like, I kept going like this because I couldn't even hear the Doge speaker guy. And I was like, is he doing that on purpose or am I just not hearing him? I'm confused. And that kept happening, like, where I think that presenters need to be given the information they need to successfully be accessible. And interruptions are also an access issue. Sometimes people speak so fast I cannot understand them at all. I don't think people realize that's an access issue sometimes. And then also, if a presenter wants to do an interactive thing, they should not require that. They should make sure that they say that it is entirely optional. They're having large text signs, maps, and multiple ways to identify rooms and locations can also be extremely helpful. In addition to publishing specific guidelines for journalists, filmmakers, and researchers about obtaining consent for different kinds of information collection. So those are some things related to documentation. As far as hybrid events, testing in advance to ensure that online participants and in-person participants can see and hear each other can be a really nice way to increase access, because I think there are online participants, but we don't have any interaction with them. And then those online participants may be participating online because they have access needs, so they're not able to attend in person. I I had to go on a ferry, a train, and a bus to get here. And it took me like 3 hours. So like, and I was like limping. So if some, like, people can't attend these like events all the time. So how can we make sure that they're included? And reminding facilitators that the words spoken without a microphone should be repeated by a person with a microphone, and ensuring that the timing of discussions and breaks are conveyed to in-person and online participants. The list goes on and on. I think this is my last slide, and then I want to discuss all this with you. I think we have time, right?
2:36.
How much time do we have?
2:36 now.
Oh, perfect. Okay. So as far as in-person events go, providing a variety of seating, so seating for different sizes bodies, standing, wheelchair access, making sure there's room for wheelchairs to get in, publishing details about food served in advance, which also Hope is terrible at. The food is like, it was so confusing to me. And that also can be stressful because people need to eat. And then it's like, oh, the food's not around. Where do I go? So, and then also at Wikimania, when I went to Poland, they had this like really, really fragrant food, which was really nice, but it was also really intense. And I think that for a conference, it's a good idea to just keep the food a little bit bland, because some strong smells can be really intense, including like really strong onion soup or something like that, or like tons of garlic may not be a good idea. Just keeping the food, publishing what the food is in advance can really help people plan though. In addition to fragrance-free policy, and a lot of these things are extremely culturally relative, and I was discussing this with my friend who's from Iran, and she was just like, well, people wear fragrances, and, like, they do, and it's just part of culture, so you can't really set a fragrance-free policy, but a lot of these things are very culturally relative, but important things are related to quiet room sensory retreats, which probably, raise your hand if you know about these or if you've ever been to one. Oh, actually a lot of people, and they're really nice to have at conferences. So also at Wikimania, there was like a light show that was so intense. Thinking about bright lights and natural lighting, I like this room a lot, it's very nice. Flash photography policies, noise canceling headphones, having earplugs available. Hope could just have earplugs for people, that could help. Considering expanding transitions between sessions to give ample time for people to take breaks and not feel rushed, and offering virtual participation. So these are a lot of recommendations that are based on evidence and research, and I can provide you with the citations, but I am really excited to discuss this with you, and it's not really a Q&A. I think I would just like to hear from you about any thoughts you have on these matters, and I'm happy to respond, but I think it's a pretty new area as far as neurodiversity. Probably 30 years of research has been happening, so if you want to help moderate, that would be great.
Sure.
Thank you.
Do we have questions or comments about this? Yeah, right here.
I was just wondering if you could...
Do you have a mic or no?
Oh.
Do you have one?
I can stand up here.
Or no?
Oh,
it's okay. Okay, we can repeat it.
Yeah. I was just wondering if your experiences on dealing with some disability chafe. So I don't know, where two disabilities have conflicting needs. So for example, you're talking about no interruptions, where ones
Do you want to
was,
repeat the questions? Sorry. Oh, I'm so sorry, and I just interrupted you. We're all terrible with it.
you know, one person had a traumatic brain injury, which meant it was very, very difficult for them not to do interruptions. And so that's an example. Or for example, if someone is doing vocal stimming and somebody has a sensory issue with that, or,
Oh, yeah.
or even just very, very simply in terms of, you know, the way rooms are organized, I think navigation for instance, you know, for people who have low vision, you know, when stuff scattered around and stuff like that, it just becomes this very obstacle course, but for some people it can be very hard to be contained and neat and not, you know, take up space. So what are your experiences with dealing, like, how to resolve those kind of I mean, I doubt there's a meta policy, but, and what I found is work is maybe we have like a local agreement, that this is how it's gonna work here, but, you know, what are your experiences?
So the question for those in the back of the room or online is around competing needs that may be in competition. I understand this well. I have a son with autism and a daughter with Down syndrome, and their sensory needs do conflict sometimes, so I'm curious.
Go ahead. No, and anyone else in the room want to speak on this? Yeah.
Not about that, but, okay, two things that come to mind. As far as earplugs, it wasn't sanctioned by Hope, but in the main building, the Rave Safe guys are handing out earplugs for free by the hundreds, so they were available. Also, as far as other sites that tend to be big for neurodivergent people, Discord seems to attract them like a magnet.
All right, so someone in the front has commented on how there actually are earplugs available from some different areas in Hope, which is great. And going back to the discussion about competing needs, living in community, we're going to have competing needs. And this, I think, goes back to one of my first slides, just thinking about what are our values and how do we live together. And no one's ever going to have everything exactly, but we can collaborate together and through compassionate communication I love nonviolent communication. It's expressing your needs and your requests. So this is what I need right now. These are my needs, and this is what I need from you. These are my requests from you. So vocalizing these things, I think, can help people understand. But then sometimes people don't want to vocalize it because you're camouflaging and you don't want others to know that you have something going on. So, I don't know, I'm curious if anyone else in the back.
Well, so if that's not all on the presenter, and it's also partly on the people with the needs who may have competing needs, then the solution there would be to create a culture of acceptance and needs mediation.
So the comment here in the from the back was about working together to communicate the needs with the speaker and those who have the needs. Creating a culture, maybe not directly communicating, but the comment was about creating a culture so that there's an awareness of these dynamics, perhaps.
Love that.
Any other comments?
Right here, right here.
I know in past years I asked about mobility access, issues, and at least here they have the security person or whatever who's involved with that. But I guess it would also be useful to have someone who just kind of will field any kind of disability-related issues at the moment. For someone who's blind, you could have someone who can help navigate the person to the spot, whether it's a bathroom or a venue, one thing. I guess if someone has vocalizations, it's a matter of whether the space will kind of deal with that, or if they might want to have a remote place where they want to go. I don't know if that's what they feel is going to be helpful for them, because we have, we have a live stream of the talks here, so they can access an area, maybe the quiet room, and
Oh yeah, that's a good idea.
Yeah. So the comment here was around a coordinated effort to address disability on a broader level, and how a conference like Hope could do more there perhaps, to address both the physical disability access needs, but all these other issues we talked about here today.
Well, also I love the idea of having like a kind of a room where you can see the talks, but it's at the conference, like a waiting room where there's a live stream going on, but it's like a little more quiet. Great idea.
Or for people who just don't want to make that transition. You know, it is a lot. You know, the physical mobility you mentioned is certainly a lot to get for certain folks to get from one place to another. Having a place where they could just tune in. Yeah, I like that. Anyone else?
I guess sort of not directly related, but had a really interesting experience a couple years ago at Dollywood down in Tennessee. Their accessibility program there was amazing.
Nice.
My son's autistic, and we knew it was good, like waiting lines and all that stuff was going to be, you know, a situation. And like we went into a private room, met with one person, talked about what our needs were, didn't have to prove anything. It's like, okay, this is what we're at. They gave us all the information, different rides, and we go into the accessibility entrance with the whole family, just one of them ride, you know, and it was just like very, very well thought out. Like their whole programs seemed to be really well designed.
Yeah. So our comment here was from someone who visited Dollywood. I gotta say, this makes me really excited as a Tennessean to hear that report. I know, you know, I call her Aunt Dolly in our house. We love her, and we have plans to visit Dollywood this fall. So glad to hear that they're doing great work on accessibility there. We should take some notes from Dollywood.
Well, also the comment was about the entrances and just making people feel like just very natural, right?
Right when they come in.
Which I think is the big thing, is not making like people feel alienated, just making it very natural. Yeah. Yeah, and it's not just like a ramp or something. Like a ramp is like a good thing, but like we're talking about more than that.
Yeah, comprehensive.
Oh, the person next to the person that just had a comment.
So,
Yeah.
very, very interesting, good topic. So, you know, obviously now thinking about my organization, our events, there's not so many large-scale hacker events. Hope, DEFCON, there's Computer Congress, there's free software conferences, there are various open source conferences, obviously Wikimania. Of the conferences and also like communities you've interacted with, which ones have been the best at being accessible?
Okay, so the question was of all the different, there's Hope, there's DEFCON, there's Chaos, there's open source conferences, there's FOSDEM, probably more in Europe, but the question was what is the best one, and I would say the 100% best one, it's not a hacker conference, but Society for the Disability Studies is so amazing. They have a party that's live. They have live caption or live, visual description of the DJ and of the music too, and like it's all different modalities, and it's so beautiful. I think it the more modalities there are, I think the more beautiful it can be. 'Cause, even if you don't know sign language, having sign language around can help you understand.
Well, we're at time. Does anyone have one last question, maybe? Or comment. Right here.
So I'm curious about the difference between, like I had two interesting experiences this year with the photo taking thing, because like one of them was like going to everyone will freak out if you take out your phone to take a photo unless it's very clear that you're taking a photo of something with the people. I just thought that was really interesting. Like, it's kind of the same idea or the same sensitivity, but they're like handled in two really different ways. Obviously, if you defaulted to not being able to take photos, like NYU would be able to do like promo for the thing that they're having, and I don't know. I'm just curious about like different ways in which the default can be one way versus like having like a negative versus positive default on a certain thing.
The comment was about sort of red lanyards and different lanyard usage, and how sometimes people don't opt in to use the lanyards, and then it's like you're kind of on your own, like you might be the only one wearing the red lanyard. And yet there is, wait, say it again?
It was just like compared to having an experience at a different space where it's just like there's like a very intense no photos default.
Oh, yeah.
You can ask someone kind of take your photo.
Oh yeah, so like in comparison to an intense situation where there's like a no photos policy. And I think we need to discuss these policies amongst ourselves. We're probably out of time, but it seems like at Hope people don't really take photos. I don't know if that's a policy or if that's just the default, but I know with Wikipedia events, people take so many photos, and I've had so many people upload photos of me that I don't want. And so it really depends, and thank you so much for your time.
Yeah, you're the MC, not
to our next talk and our Tobin track. We have filled up this room because everyone wants to know about the invisible ink of compression, right? You're in the right place, right? I want to introduce you to Logic. He will give us this awesome presentation today about this cool topic. And the only thing he wanted me to tell you is that he's not a security researcher.
Streams in here. If we interpret it as a TCP stream, so, well, actually we'll get to that in a second, but as an HTTP stream, they are identical. You'll see two different colors of arrows. Green is the normal one, red is the suspicious one, because red's suspicious. And if we look at it in the context of a TCP stream, in this case, it's a little bit different under the hood. So it might be an eye chart here, but the top we can see the deflate. There's the garbage there, and the deflate there, it's just a little bit more garbage. That's the takeaway. And we're gonna, I lied on the program. This is technical. But narratively speaking, this is the foreshadowing. We'll peel it back and explain this all. So this is gonna be a little, but what I highlighted there in hex, that's the binary of the actual compressed data. In CyberChef, if anybody's familiar with it, it's just kind of a good Swiss Army knife for encoding and decoding things. We throw it in there with a recipe of from hex to make it binary, and then we inflate it with the deflate algorithm. And in this case, we can see the HTML that it's supposed to decompress to, which is, you know, the tags, and then the body of it, or the actual text of it is nothing unusual here. But yeah, we'll go back and take a look at the suspicious one. This one, there's a lot more binary to highlight. We take it into CyberChef, and it's the same thing. And that's kind of the thing to keep in the back of your head for the rest of this. And to get super technical, there's this really cool tool that allows you to pop the hood and look at the internals of deflate. It's called ImpGen. We'll get a lot more into it. I'm just kind of giving a brief preview, foreshadowing. This is kind of just like all the tokens or characters it's building up. And you can see like the matches, the pattern matches. You can look at the tables of all the symbols and all that. But this is just kind of what normal looks like. This is the table of the characters it actually uses, no less, no more. But if we look at the suspicious one, already there's a lot more stuff in here. Yellow is the table, blue is the actual data. For the first block of data, you see the building up of HTML, but then it ends the block. Yet for the actual table of symbols, it has way more symbols than it's actually using. That's suspicious. And then on the next block, it's just the letter B, and it ends that block. Yeah. And, you know, there's also a tool that I'll be talking about, just released a few days ago, that allows you to detect suspicious things in deflate. So it's definitely telling me about all this Huffman table stuff. It could even, it even has the ability to scrape the data out of there if there's data hidden in there. In this case, the hidden data in that one was, but actually there's something incredibly unusual here. So that was network proof of concept. Mostly it's doing some Huffman table manipulation. So it's the Huffman ignorance of some more general ignorance of different things you can do. And that's just a small part of what we're going to get into. So that's kind of the preview. So deflate. If nobody's heard of it before, which if you're into compression, that'd be weird. But you know, if you're not into compression, that's cool. Either am I. Like, this talk's not about compression. So it's really common. It's in gzip. It's HTTP, PNG, and a lot of other things. It's a really, really common, just general purpose compression algorithm. And actually, it's kind of two algorithms. It's LZ77-ish, because patents or something. I don't know. And then the Huffman codes, and we'll get into both of those. But fortunately, it's actually really straightforward, I think. It's not really super mathy. It's conceptually pretty easy to understand. And this slide right here kind of has nothing to do with the deck. I think it's just kind of something, just a hackery thing to keep in mind when you approach systems. I think a lot of people that are hackers kind of already know this. The difference between what a system's intended to do and what it actually does. And you'll be more effective if you can just throw away that first part, what a system actually does. If you think about what a system actually does, that's going to get in your way of progress. What the system does, compresses data, decompresses data. That's not what I'm doing. What it actually does, it does these words here, that whatever. So let's talk about that first algorithm, the LZ77. That's like the pattern matching. So if you have a bunch of text and then you come into text that like, well, I saw this word before, I saw this phrase before, you can, with numbers, you can say, well, that pattern that I saw before, it was like 10 bytes. I go back 23 bytes to find it. So that's just two numbers as opposed to a long string of text. It's just a shorthand. That's really all it is conceptually. I know this is small. I'll read this, but as a proof of concept, conceptually, we have the phrase, the hacker was hacking the hack system using hacking scripts written by other hackers who had hacked it before. Yeah, it's a terrible sentence, but there's a lot of repetition, so that's why I went with that. So, as we're building up the sentence, we can say the hacker was, and I'll zoom in here. So we start with the hacker was, but the next word is hacking, so we saw that word before. And we're going to say 5 characters, not 4 for hack, because there was a space before hacker, so we're cannibalizing that as well. So that linked distance pair is just 5, and then go back 11 to find it. That's it. That's all the LZ77 really is. And as we go, there's a lot of content. You just trust me. That's how the whole thing works. Those are all the linked distance pairs. That's what that would look like. And in just plain ASCII without compression, 112 bytes would be that sentence. But just using LZ and not the Huffman tables, that brings it down to 81 bytes. So now, and I'm going to be in and out of this slide a lot. These are just kind of the tools. I kind of organize it this way to when I talk about a tool, I kind of come back to this slide so you kind of have a conceptual idea of not just looking at a bunch of screenshots or videos. But CyberChef, I kind of already explained. That's for encoding, decoding. We'll use that a lot. InfGen is the tool to pop the hood of the compression and look on what's inside. Irreflate is a tool that I wrote to start under the hood and create compression manually. And then I'm using a fork of InfGen because mine spits out the whole binary blob in color-coded with all the fields. So yeah, let's breathe manually for a second here with Irreflate, just to kind of prove the example, the conceptual example. We'll get our hands dirty with it. So in this case, we're just going to be building up that phrase, character by character. We got the hacker in this case, and then a space, was, and then we're going to say 511. We can manually put in the link distance pair, and then ing, and then end the block. And then it spits out this ASCII hex. That's our binary blob. So to prove that that was doing what we expect it to do, we go into CyberChef, and we pop that ASCII hex in there. And we're going to do from hex to make it a binary blob, so then we can inflate it with the deflate algorithm. In this case, we get the hacker was hacking. So it works. And then just to show InfGen, just to show it, we can put in that binary blob. We just echo it out, and we pipe it to XXD -R-P to make it binary, and then we pipe it to InfGen, and then we can see every single field under the hood, but also I'm highlighting that 511. It has all the characters down the line, but then we see 5 characters, go back 11 to find it, so that works. I'm going to do the same exact exercise again, but to kind of revisit that ambiguity concept. So we're going to do the same phrase, the hacker was hacking. So build that up. But this time we're doing 411. So we're not cannibalizing that space. We're just saying, just take the word hack. We end up with that binary blob, and we come back to CyberChef. We have our from hex, and then we inflate it. Hacker was hacking. Whole point of that is, that sounds pretty obvious, but the ambiguity is what's important. There's more than one way to do it. It's not a one-to-one relationship, and I love that when that happens. And then in InfGen, just for illustration purposes, just to validate, you pop the hood, and what we're just looking for here is to see that 411. So yeah, down there we have the 411. All right, so let's get ignorant with LZ77 specifically, these linked distance things. There's 2 different things we can do and be ignorant with this. There's illegal lengths, like bad lengths, and also we have distances, so illegal distances. I quoted illegal for the links because, so we have the letters HA in our buffer, and then what we're saying with this linked distance pair is we're going to have 7 more characters, go back 2 to find it. So going back 2, we have the HA, but 7 characters, what does that mean? This is a feature, not a bug. And instead of saying what it is actually supposed to do, we have the tools. Let's just do it and see what happens, right? So we're putting in HA72, and we get our binary blob. Pump it into CyberChef, see what CyberChef thinks about it. And we get a lot of laughter. Yeah, that. And in this case, it ends with an H. So that's another side effect. I chose an even number for the length just to illustrate that it loops, and if it's an odd number, it just ends at whatever it was at. So that's not really that ignorant. That's what it's supposed to do. This, on the other hand, we're going to go into this for at least 10 minutes. This one is wild. There's a lot of different directions this will take us. So in this case, we have, again, the same HA. We're going to say 7 characters, which that's fine, but go back 20 in the buffer. Where's that? And you know, when you're using gzip or something like that, it's never going to create those linked distance pairs. But like, again, we have the tools. We can put that in there under the hood. Let's do it and see what actually happens. So we're putting in the HA. In this case, it did 742. You know. And we get our little buffer here. Let's see what CyberChef thinks. And this is what CyberChef thinks. This isn't what all implementations think. Like gzip might be a little bit different, but we're just seeing what this thinks. So we're going to do back 2 hex just because it's going to be unprintable stuff. And in this case, we have this 6861, which is the HA, and then a bunch of nulls. Yeah, where'd those nulls come from? We're going to get to the bottom of that towards the end of all this ignorance, and it's not as interesting as I wanted. I mean, of course, heartbleed for compression, that'd be great. No. Well, that wouldn't be great. But yeah, and then to look under the hood to see what InfGen thinks, it actually does throw the warning. Looking at the 42.2, it says that's a distance too far back, and yeah, it is. So instead of like looking at gzip or something super complicated, I wanted to see, well, CyberChef did this, where is it getting its nulls? I kind of looked at their source code. I didn't come to the answer right away, but I saw something really, really interesting. And this is if you know CyberChef, the authors, it's GCHQ, the British NSA, which is just, that's not relevant. It's just funny to me. So they put in this comment here, raw inflate sometimes messes up and returns nonsense like this. And you know, like the square brackets and dots, that's the nonsense that that 4 bytes of hex below that produced when they try to inflate it. So they didn't understand it. They just built an edge case around this to error on it. And like in shorthand, it's if it finds a payload that's larger than 158 bytes, and the first and 6 characters are square brackets, and that every 6 byte thing is a square bracket for 155 bytes, which was the exact case here, then, you know, do a warning. But like, it's not just like square brackets and dots. I tried, well, what if I did the square brackets with something else and just like hacks, and I still get an error because their edge case is just looking for the square brackets. So thing with this recipe to really pay attention to is this is legitimate. I'm taking the hacks, I'm deflating it and just reinflating it. That shouldn't be an error. But they put in a stupid edge case. What is this edge case? Well, we have the tools, so let's reproduce it. In this case, we just stored it in InfGen and see what the actual problem is. And it's related to what I was talking about. It is a length too far back kind of an issue. In this case, they had the square bracket, and then they said length of 158, go 5 bytes back to find it, and that's why it repeats that square bracket, and the dots are the nulls, because that's what it's representing, the nulls as its dots. So like I wanted to try to do something like that, but without the square bracket, just to see if it would err out on that, which you know it's not gonna, but I just gotta improve my point here. So in this case, I'm doing X instead of a square bracket, and then I'm doing the same 158.5. I take that, go into CyberChef, and you know, if it really should be erring out on that error condition, then it would for that too. And just to verify, you know, InfGen, it's showing that we have that 158. Or the 158.5 and then 5.1 too far back, but with the X this time. So when we go to CyberChef, we put that in there, and it's going to work this time. Of course, we're going to put it, after we inflate it, we're going to go back 2 hex just to see the binary of it. And again, nulls. I swear, we'll get to the bottom of where those nulls are coming from. But as an aside, I told the people that maintain CyberChef that that's dumb, remove it. And then they did. All right, so that gave me an idea. Those nulls, I want to build the biggest buffer I could possibly do in one block, which in this case is about 32K. So I wanted to do 32K of too far back. I wanted to see how far back I can peel and if there's anything more interesting than nulls. I mean, long story short, there wasn't, but you know, this is the proof of concept for it. So I crafted that in Irreflate, and then I paste this buffer into CyberChef. So from hex, then I'm going to inflate it, and then I'll do 2 hex again as well. Right now it's 32K. At the bottom it's really small, and then when we inflate it, it's like 95,000 something. That's because, you know, with the space of a delimiter and the 2 ASCII nibbles, that's like, it triples what it thinks. But anyway, so yeah, it's just nulls. Still haven't really got to the bottom of that. But before we get to the bottom of that, let's play with it a little bit. we can introduce nulls that kind of are illegitimate in a way, which is interesting. So as a proof of concept, I'm really not going to go into too much measures explaining why I'm going through some of these steps here. Like this first step, I'm only doing it to create a checksum because I'm going to create a gzip file. So it's kind of doesn't seem that sensible. But in this case, I'm using Airflate to manually craft the word test, and then I do 4-8 as the pattern. So going back 8, which I don't have, it should be a bunch of nulls, and the checksum is going to match what would be with the nulls. And in this case, I try to use pigs to extract it, which pigs, it's written, I mean, Mark Adler's behind that too. He's also one of the main people behind gzip. Pigs is pretty much like gzip, if I understand this right, except for it's multi-threaded, but it's more modern. And when I gave pigs this test.gz, it says no, this is invalid, which it is. That's what it should do. You shouldn't be able to be extracting this. Gzip version 1.13 and not version 1.13, but I'd say version 13. It also it's modern enough to be like no. And then I took the hash, the SHA-256, just to show. It starts with 3B, ends with F3. Just this is the file. Just to say, when we go into an older version of Ubuntu that I had, and this is going to be gzip 1.9, which is an older one. We try to extract test there, and we get it. So this is before they were doing this check. So let's get weirder with that. So now I have a file called lol.gz. This is a hex dump of it. We're going to do gzip with it. Same problem. The newer gzip can't handle that. But if we use the older gzip for it, we're going to, it's gzip compressed. There's the hex dump of it. We're going to extract it. No errors. We have our LOL. What is it? It's an ELF executable. Okay, let's make it executable. We're going to run it. Well, what? So the cool thing here is you can create a file that can extract something legitimate, but not on newer gzip. I mean, I don't know what to use that for, but I think that's kind of interesting. And just as an aside, how does a browser handle this? So, I made a proof of concept, same kind of thing, test, and then, 10 characters go back 50, end of block. It sort of looks okay so far, but the browser just pukes when it sees that. So the browser, that's what it should do. It shouldn't be handling that like CyberChef. Okay, so to really go into what gzip is doing, debugger time. And I'm not going to, don't have a lot of time to go really crazy with it. I'll give you the short of what's happening. But, when I get into this section where it's actually copying the bytes from the buffer, doing that part of it, you go up all the functions and you get to the mem copy. And for mem copy, it's just length, source, destination. If you look at the source and the destination, so the source is, they both start with 4.3 in hex, and then the source is FFDF. The destination is 7FE3. For those, really long story short, the destination comes before the source. So what's actually happening is it's not going back to find nulls. It's actually, it's coming around to the end and back. So it's like, in a way, this makes total sense, because if it was accessing a buffer and shouldn't have, like maybe the OS would be throwing an error, like that you would be having more problems. So it makes sense that this is why you're not getting an error, but also why you're getting nulls, because it's pre-initialized and there is no data in it. So I was glad to get to the bottom of it, disappointed that it was something so simple, but that's the story for that. Cool. I'm going to check the time real quick here. I think we're doing good, because now we're going to get to the next algorithm, the Huffman codes. A little bit more complicated, but conceptually still not that bad. So in this case, we're using the example phrase of no error to report. I use this phrase because there's repetition in the letters. If it were just ASCII, these are the characters in this table and the binary it would represent. That would be 18 bytes. What if we could say, well, we're only using like 7 characters, including the space. What if we just did 3 bits for each? Of course, we could save there, but that'd be naive, because of course, with real data, we're going to have more than just those 7 characters. But what if we could vary the amount of bits that we use for each one? Like, what if the letter E was really frequent, but the letter Z wasn't? So maybe we can code the letter E with like 2 to 3 bits, and yeah, the Z we might have to use like 9 or 10 bits, but that's okay because we only use it a couple times. That savings is worth it. So like this is an example of what that could look like with just these characters, like a little north of 6 bytes, 49 bits. And this is not just abstract. Again, I really like to get hands-on with this. So in this case, I'll just show like no error to report in CyberChef, and I'm gonna run deflate on it to actually compress it. I'm choosing to use dynamic Huffman coding, so we get that Huffman table and we get our blob there. So now that we have our blob, we can go to InfGen and inspect it and actually look at what that table looks like. That's one of the cool things about InfGen. You can really see all the internals. So, and in this case, color-coded. That's what the table looks like. I'll come back. Did I mess it up?
No, I'm just checking it.
Go for it.
Just wants to be a little more pointed towards your gob there. Yeah.
All right. So I'm just bringing the table back from InfGen to show this is the same. It's not hypothetical. So it makes sense if we look at the ones that are really short in bits, like the O is 0, 0 and the R is 0, 1. If you look at no error to report, there's a lot of O's and a lot of R's. But if you look at the ones that are a lot of bits, 5 bits each, the N and the P have 5 bits each, and really there's only one N and there's only one P in the phrase. So conceptually, that's Huffman tables. Like, yeah, if you want to breathe manually and encode it yourself in binary, like I'm not going to talk about that. Like, we could after, but that does get pretty crazy. But that's conceptually all you got to do. That's kind of the algorithm for doing it. So one of the things is like, well, what about delimiters? The beauty of how it's encoded is it's a binary tree, so there actually is no ambiguity. It's really clever. In the RFC 1951, this is kind of talking about that, but yeah, no time for that. Let's talk about some Huffman ignorance now that we're in here, now that we understand Huffman tables. So what about just filling up the whole table and not using it? Like, we make a table for all of our alphabet, and then we just end the block. Like, what would that look like? This video is a little bit longer. By that I mean like not more than 30 seconds, but I'm using Airflate to just max out everything, max out the whole alphabet I'm going to be using, and all the bit links for all the characters, just to make this table as big as I possibly can. And interestingly enough, the Huffman table itself is encoded with another Huffman table. It's and it's like, while Airflate is pretty useful to be able to manually create your own Huffman tables, it's still tricky. You kind of still have to understand what you're doing, because you can do things like oversubscribing or underutilizing. Like which like I try to make it a little bit easier with the tool that it'll tell you how many codes you have left and all that as you're building it up, but it's still kind of an art. But okay, so now we finally got our buffer. We're gonna go over to CyberChef, and it's a lot of data. That's, now it's binary. Let's inflate it up. Nothing. It's funny to me. And to pop the hood, we'll tell InfGen to analyze this. And really, I just want that color-coded bit pattern. So, like I said a long time ago, yellow, that's the Huffman table. There's a lot of Huffman table in this. If we want to look at that and just kind of pick the pieces apart, bit by bit, that purple bit, that's saying it's the last block. So if it was 0, that would mean there's more blocks to follow. We want dynamic mode, means using Huffman tables. We want the max amount of literal length codes, the max amount of distance codes, the max amount of code length codes, which is that's the part of the Huffman table encoded as the Huffman table. And then that's the actual codes that are building up the Huffman table. And this is the Huffman table. And then end of block in blue, and those 3 white 0 bits are the padding. But yeah, you're ending the block before you even use it. So that's how that one works. What about this? This is just another stupid compression trick here. So we have this blob here. I think this is the legitimate one. What we get out of here is the word hacks, H4X. But point is, for this, it's a binary blob. What if we took out the conversion of from hex, and we have this phrase, 5, carriage return, IR, $, blah, blah, blah. This decodes to hacks as well. But the cool trick with this is that this is not binary, this source input. This compressed data, this compressed blob of data, it's all ASCII printable. That's actually kind of hard to pull off. The way that looks, I'll go into ImpGen and pop the hood on this one. All right, so still lots of Huffman table, but we actually are using some of it. In this case, we have our 4-bit literals, so H, 4, X, and end of block is also a token we got to use. Each of our bit links are 4 bits long, and so the reason I did that is so they're all aligned, because I don't get that many characters to choose from when my Huffman table is only really encoding for 4 different things. But yeah, another stupid compression trick. And we already talked about packing in arbitrary data with the network proof of concept. So now let's just talk about some general ignorance that uses all of those tricks. R.zip. This one's really cool. So r.tar.gz, you extract it, it puts r.tar.gz into a directory called r. You go in there and you extract it and you get the idea. The hash is the same every time. That's some just dark arts right there. Because you are having to do manual crafting manual compression there, and also the author of this being that this is a GZ file and also the .zip that this applies, you have to recursively understand the checksum too. And I read his blog. They brute forced that. Well, what else are you gonna do? That's what that one looks like. R.zip. It's cool. Another little bit of ignorance. For a little while, I was handing out this business card, a hacker card. A lot of people thought that this was like just like a PGP key or something like that, but it's not. The idea was I saw a lot of hacker challenges at conferences that were just like decode base 64, you win. It's like, that's kind of dumb. So I wanted to make something not to challenge people, but like I'm big into satire. So that this is base 64. There is a clue here for what the next step is going to be. It's hard to see from here, but there's a couple of characters that are light blue. So those characters spell out deflate. So at least you know when you go into CyberChef and do it, you know what the next step is. So let's solve this code in like less than 2 minutes. We'll go into CyberChef. We put that in there from base 64. Obviously, it's binary, so let's do 2 hex. And then in this case, we're going to inflate it. And there's a couple clues here with what we end up. It says 100 or 1024 at the bottom for how many characters we have. Know that this is ASCII hex, so it really means this is 512 bytes. It's clue 1. It ends with 55AA. It's clue 2. The other clue, this is kind of obscure, but if anybody does a lot of reversing and looks at machine code a lot, that 31C0, XOR EAX, EAX, like that just kind of pops out at you. So it's executable. That's third clue. Long story short, that's a boot sector. So let's boot it. We're gonna echo this buffer out. We're gonna use XXD to make it binary. Call it card.bin. We're gonna use Chemu to boot it. And it asks us enter the last 9 LZ distances. It's asking for a password, and it's XOR encoded. So well, now we got to actually pop the hood and what are the last 9 LZ distances of the compressed blob there? And there they are. So there's some like recursive stuff or self-referencing stuff going in here. The challenge was harder to create than it is to solve, and I kind of like and prefer that asymmetry. Of course, it's easy to make something that will confuse people. It's easier to do that. But anyway, so the result of that, I'll make it a little bit bigger because the screen. But so this is what you end up with. You enter the password, and it says hacker challenges are pointless. Am I right? So let's talk about forensics. We're kind of getting near the end of this. And then I'll talk about the covert channel stuff right after this. So we'll go through this pretty quick. But there was a tool out there that looked really cool. It's called ZipRec, and it takes the same approach that I ended up taking, except that they also apply some LLM stuff to fill in the gaps, which I thought was really clever, honestly. But my problem with it is the same problem all the other 3 open cases are with this GitHub repo, is you can't compile it. I mean, I felt dumb, but then being that everybody else was not able to do it, I'm like, I'm just going to make my own. So my tool is not as good as this tool, but you can run my tool. So hypothetically, consider a fragment of data. It was the part that was in red. Alignment is the big issue. You can't just paste it into CyberChef and get something sensible. So in this case, we're going to try anyway, and we're just going to delete bytes off the front and see if we get anything. It's like broken buffers. Oh, this looks like words, right? And then we keep on deleting. Oh, no, it's garbage. It's garbage. And so that approach doesn't quite work perfectly. You kind of do need a tool for it, but I just kind of wanted to show what that would look like. So we get back to a demonstration here of toe knife, because scalpel, toe knife, forensics. So we put the data in there, and this kind of allows us to just look at examples, and when we land on the right one, it'll tell us what we have, but it also will give you those linked distance pairs. And then once you land on it, this version just shows you what the table would look like, so you can have a good idea of what you might want to guess. I'm going to give it some guesses for those linked distance pairs, the word for and the ERS, because that seemed right to me, and give it that as hints or clues as opposed to using an LLM. And then I'm able to get the result, which is it even backfills for what the link distance would be before the fragment. So in this case, we end up with ERS and then a bunch of questions, and then four is the only of those that has 4 letters in it, is the phrase. If you want if you want to see what the whole thing looks like, that's a screenshot of like the full buffer, not the fragment. So that's what the original sentence would look like. So really, the RFC says that 1951 for deflate says you shouldn't really, it's not meant to look at arbitrary data, which makes sense, but that doesn't mean it's impossible. So let's talk about some covert actions. This is Stego territory, and I'm bored of Stego, but like I know it's possible here, so talking about it. What is interesting about this PNG-based Stego, though, is that the bits or the colors aren't going to change at all. That because traditionally, change red a little bit and you can code a bit. No, we're not changing the actual data at all. So, here's all of our PNGs, different file sizes, different hashes. We're going to look at each one of them. That's one, that's one, that's one. They're all the same. The data is identical. So if we look at these kind of one by one, looking at the hex dump and the impgen output of it. In this one, this is stored mode, so not compressed at all. So we see the first 0 is not part of the actual PNG data, but the 25500, that's your red. The 02550, that's your green. The 00255, that's your blue. In this case, we're using dynamic mode, so we do have a Huffman table, but if you look at the literals, again, that first 0 is not the color, so we have a 25500, that's your red. Then we say match 6, there's going to be 6 more bits, or bytes in this case, and then go back 4 to find it, and it kind of like, that unevenness is what gets your green and blue. We do the same thing without a Huffman table, so we do fixed mode, and it's the exact same approach there, just a different way of representing the same data. Again, fixed mode, we do it a little bit differently with our linked distance pairs, but the end result is the same data. Same data, same data. Many ways of saying the same thing. So I got to a point where I kind of wanted to automate not just this concept of creating many different arbitrary variations of a file, but also to hide data in the Huffman tables. And I am writing this tool, and it is working pretty well. I haven't released it, and I don't know if I plan to. I could not in good conscience make this tool public without writing the tool that can detect this nonsense. And not just the nonsense of my tool, but all nonsense of deflate. So this tool I call deflate defector. It detects anomalies in deflate. The 5 big ones that I do is unnecessary repetition. So let's say we had the phrase OMG hacks, OMG hacks, OMG hacks. If you were to look at some deflate and you saw those as literals, like no linked distance pairs, but just literals down the line, that's suspicious. You should never see that. If you're compressing with anything legitimate, it is going to make those patterns. So that's suspicious. The tool detects that. But even if you're not splitting the pairs right, or if you're not like crafting the pairs the most efficient way, that's still suspicious. So like, let's say OMG hacks, we could say 6 characters, go back 6 to find them, 6 characters, go back 6 to find them. That would work, that would decode, but that's still suspicious. Your compression tools are not going to make that. What it really would make is 12-6. That's what you'd expect to see. And for proof of concepts like the r.zip and my business card, they both, split pairs ends up in both of those. Empty blocks. Well, we saw that with the me just crafting an empty block to see what would happen. But like, yeah, that's also suspicious. Underutilized blocks, that's definitely the network proof of concept. So I have a Huffman table built up, but I'm not using all the characters from it. I built the Huffman table to put the data in, but not to use it for the actual message. And if that wasn't enough, what if you were clever enough to make your Huffman table to put all of your encoded data in, that your secret data, but you were clever enough to actually use every single symbol in that table to try to thwart this even? Well, statistics are still going to catch up with you. So it has this heuristic as well. So even if I used all of them, it would say, well, the bit length in the Huffman table for the letter Z, it's a little bit long, yet you use the letter Z a lot in your actual payload. That doesn't match statistically. So it does that analysis as well. So with this deflate defector tool, there's not a lot of wiggle room to do something sketchy. Pretty much any of the examples, any of the ignorance that I talked about here, this tool would pick up on all that, and other things like r.zip. I didn't write that, but this tool would definitely pick up on all the ignorance in there. So what's next? Honestly, I kind of wanted to do all this before this talk, but life gets busy. These are things I still want to do. This deflate stuff is something I've been kind of obsessing about for like the last 7 years. I just keep on putting it down. Like, yeah, there's nothing useful, and then I'm like, oh, yeah. But so this is kind of a passion project. I do kind of vapor some of the stuff I do, but this one I'm still interested in. So one of the first things I wanted to do is spider for anomalies, like just go out there on the internet and not just to help debug my tool and make sure it's better, but I don't want to give the impression that I even think that threat actors are using this as a way to, there's so many other ways to do it. And I mean, of course, I didn't find any evidence of it, but it'd be cool to find weird stuff out there. If there were people using it because there's no evidence of it, it's those kind of people using it. And one of my friends, Lambda Calculus, he's been doing a lot of stuff with DPRK, the Red Star OS. Like they definitely do some sketchy stuff, and it's been on my mind, which is why I put more energy in the deflate defector as opposed to the deflate tool, and also kind of probably why I called it deflate defector. But yeah, so it'd be really interesting to find anomalies out there in the wild. Not to say that they're going to be malicious, but if I do find an anomaly, it's probably going to be at least interesting. And if this is going somewhere, it'd be cool to write a web service where people could upload a file and get the result back. I guess the use case for that is, maybe it's somebody that doesn't want to download my script off of GitHub and maybe not technical enough. That's fine. So, make something easy for it. But I do want to take considerations with this because, I mean, as far as privacy goes and all those kind of things. And then browser plugin, one of my other friends, he was talking about, first we were landing on the idea of, there's HTTP has deflate, so we can kind of sniff that coming through as a plugin. But at a browser level, it's to the best of what we were finding, it doesn't really see it at that layer of abstraction. So then I guess maybe you'd have to do something like burp and kind of get it at that level. But if the whole point is usability, well, then having somebody set up burp and then use a custom script, that doesn't work. But another thing we're thinking that might be possible is just the cached content, so that the PNGs and that kind of stuff. And by the way, that guy is the one in the black hat over there calling him out, putting the pressure. He didn't want me to. But these are the three things that I have looking at going forward. Beyond that, I'm just going back to this like I've been throughout the whole talk, just to show these are the tools involved. And cannibalizing it as the questions last slide. So that's all the content I have. And I can do Q&A.
What questions do we have? One back here.
Okay, is there a mic or just?
You can run with it if you want.
Okay, cool.
Or we can repeat questions up here. Or if you want to come up to the mic, you can come up to the mic as well. Either option. No, well, this was the mic here, but maybe it's been.
Or you can just use my mic, right?
We're making this complicated.
Yeah.
Ask the question.
Yes, yeah. What's
thank you. Actually, did my graduate thesis on deflate,
Whoa.
and you just hit a bunch of awesome things. So, good job. If you want interesting data sources, have you looked at the hardware compression devices that will do deflate? Because they have some interesting characteristics.
No, maybe we should talk after, because one thing you know how I was talking about with gzip and other things, I was kind of expecting maybe there's a heartbleed for, well, there wasn't, not because of deflate, it's just implementation specific. That's just how gzip handles that illegal distance. But if somebody else is reinventing the wheel, they might do it differently. So I am kind of interested.
There's hardware, and then I have not investigated them deeply, but there's a vast number of re-implementations of deflate, especially for embedded hardware, which could be interesting targets.
Right, especially because they're going to probably be doing some savings on code size. They might be doing some tricks that, yeah, I'm interested. I'm absolutely interested. I really mean it, like maybe after this, like I can get some notes from you. Cool.
Any more questions? Right here.
One excellent talk. This is really cool and very educational. I'm curious, so you start off with the LZ77 compression algorithm kind of going through. I'm curious if you've seen or if you've played around with the LZ78 or LZW. That I think LZ78 is what is it? It builds its dictionary and then it builds a secondary dictionary on top of it and references the second dictionary for repeated instances. And then LZW pre-initializes the dictionary. And I'm wondering if that might be like for deflate, that might throw some interesting curveballs for it.
Yeah, maybe I haven't played with those. No, yeah.
The question was on LZW?
Yeah, if I played with LZW or LZ78, yeah, no, I haven't played with those.
Gotcha. Okay. Any more questions?
Cool. Well, for the people that accidentally came in here and weren't interested in compression, we can get 10 minutes back. Thank you.
Ready? All right. Hello. Welcome. Thank you for coming to my little talk here. There's that CIA whistleblower seems much more interesting, so I thank you very much for trying me out here. Couple quick disclaimers right off the top. These are my personal thoughts and not of those of my employer, the Free Software Foundation. I'm not a lawyer, and this is not legal advice. I'm not sure I needed to say that. And I'm also not a life coach, and this is not life advice. First of all, I'd like to thank Hope. This is really an opportunity. It's excited to be here and excited to be giving a talk. A little later today, I'm giving a workshop on how to review a program's licensing. So maybe check that out. Of course, I said before, my name is Craig Topham. I started to become a free software activist in 2006. And years went by, and I eventually started working for the Free Software Foundation in 2018. And that's kind of where it went from there. I care very much about free software. And I'm also a playcyclist. Objective, oh, what's that? So what's playcycling? Oh, let's see. Playcycling is this. Essentially, I pick up garbage while I ride my bicycle. So yeah, just there's a cigarette butt. I've been doing it like 11 years, and by my calculations, I've probably picked up over 7 to 8 tons of garbage off the streets. Yeah, there's another cigarette butt. Yeah. So that's kind of what I do in my spare time, and we'll actually touch on that a little bit later. So the objectives is I'm going to give a quick, very brief history of free software. I would suspect most of you know it already. And then I'm going to talk about my experience, how I came to free software, and why I find it so important. And hopefully my little experience will inspire others. It's a bit of a stretch, but got to do something. And then I'm also going to get into why the freedom aspect of free software is very important. And then I'm going to shamelessly convince everybody to become associate members of the Free Software Foundation. I memorized all your faces, and I'm going to find you. Just kidding, just kidding. So very, very quick history of free software. In the mid-'80s, the GNU project was started to create a fully free operating system. Shortly thereafter, the Free Software Foundation was created to basically be the business side of what is otherwise a technological project. From there, in 1989, the GNU General Public License version 2 was released, which of course ensures the 4 freedoms, which are of course to run the program however you wish, be able to modify it, study the code, be able to make copies, and then of course make modifications and share your modifications. It also established what's called copyleft, which basically ensures that once that license is put on your software, it will continue to be that license moving into the future. Little soon thereafter, the GNU Lesser General Public License was released, and that was more or less a compromise. The idea is that people are going to be using these libraries. They might as well be free libraries, even if they're incorporated into proprietary software. Then in 1992, this thing called the Linux kernel was released under the GNU General Public License version 2, and the combination of GNU with Linux, of course, makes the world's first fully free operating system. A little bit later, in 1998, some people got together and decided that the word free software wasn't good enough, so they came up with the term open source, which seems to have, by and large, taken over the vernacular of the community. And then in 2007, the latest version of the GPLs were released, version 3, and then the AGPL, which is essentially the GPL with an additional section about distribution. So what triggers the obligation to provide source code is the distribution of the software. And what the AGPL does is that if you interact with the program over a network, that is more or less triggering the distribution, which gives you the source code. And of course, the LGPL v3 came out as well at the same time. So, given that, so now we're going to get into my experience here. It starts off with the American dream, which I'm not complaining about it. I grew up in a home more or less without want, free of violence and other terrible things that a lot of people deal with. But the American dream is, I'd like to quote George Carlin. That's why they call it the American dream, because you have to be asleep to believe it. And again, I feel overwhelmed with gratitude that I got to grow up in the American dream. And I can only focus on America. I can't really speak to other countries, so this is a very specific thing. to here, but of course, dreaming implies sleeping. And so if you're asleep, you might not notice things that are going on. So maybe if you start to wake up and look at the world, it might look a little like this. Things are not great. It's pretty brutal out there. I don't mean to make light of our predicament, but nobody wants to see a collage of nightmares which would truly represent what's happening in the world. Lots of unnecessary strife and suffering. You know, and once you kind of see it, because you see it, but then if you like really take it in, it's very painful. Lots of crying myself to sleep at night, like, you know, why is the world like this? I once read a bumper sticker that said, if you're not outraged, you're not paying attention. And I think that very much still is applicable today. So for me, when I start to kind of see the world, there's this kind of realization, like you go, okay, something's wrong. Why do children starve when we like waste like 50% of our food? Like it's obnoxious. And I don't want to rattle off a bunch of horrible things, but I think most folks, you know, get where I'm going with that. So from there, once the realization sets in, the next phase is comprehension. Like, why is this going on? Why is this happening? This takes a while. There's a lot of research involved. I honestly don't know where to tell you to begin. But like if you were to read like some Noam Chomsky, Howard Zinn, Carol Quigley, what do I got here? John Perkins. There's some patterns that you'll start to notice about what's going on in the world. And I was very lucky when I first got out of high school. I went to community college and studied journalism for a year and a half. And it really gave me some tools on how to read media, kind of a media literacy, be able to fact check, cite sources, you know, these critical little pieces that we need. Because it's really challenging. There's a lot of nonsense out there, and there's a lot of people deliberately making that nonsense. So it's a struggle for folks to actually get the truth to kind of develop a functional worldview. So many years later, what I came to discover is there's this really very tiny slice of the human population that has extreme, like their wealth and influence is off the charts. And I don't necessarily, that's a very simple explanation of what's going on, but apparently these people don't care about us and they don't care about the environment. And it's problematic in my opinion. So, yeah. Let me see, make sure I didn't miss anything here. Right. So it takes a while to get, like I said, like a comprehensive worldview. And then the next question is, okay, now what am I going to do about it? I'm just a regular guy. I'm not particularly smart. I don't have a lot of resources. And so I tried to get involved. There was like some like grassroots, like political stuff. I went door to door getting money for things and I just kind of was disenchanted. And then also I'm like living my own life. Like I have to work and pay bills. And again, I'm just one person. But long story short, I was looking for something to do. Like, what can I do to make the world a better place? And so I discovered the free software movement. And that didn't happen until 2006, which I find a little shocking because I grew up since like 1981 or 2 with a computer in the house. It was just there and I used it mostly to play little games and stuff. But I was surprised to learn about the free software movement so late in the game there. I remember I was online, I'm reading things, learning stuff, and I was with a coworker. And I started repeating what I had read online, ranting and raving. And he goes, "You sound like Richard Stallman." And I went, "Who?" And I didn't know. And so I got my hands on the Free Software, Free Society, the selected essays of Richard Stallman, and I went, oh, this is where it's at. This is something I could do. And so, and it didn't disrupt my worldview, like it just fit right in, and the simplicity of the four freedoms was very like just simple and clean, just straightforward. It didn't feel confused at all when I read it. And so I highly recommend that book. So the next stage is, okay, act. I got the free software thing. I want to do something to make the world a better place. Where do I go from there? And the beauty of free software is all you have to do is just start using and talking about free software. And at the time, I got involved with neighborhood associations, and I was using Drupal, which is GPL-v2, and I was showing people how to set up their websites. I did like 4 or 5 different neighborhood groups, and my trick was to say, hey, I know how to set up websites. Let me come talk to you about that. But they first have to listen to me for 10 to 15 minutes talking about the history of free software and the difference between free software and open source. So I kind of snuck that in, but it went pretty well for a while. And then I basically became an FSF associate member, and all of you should too. And I really just engaged the process, and it really gave me a sense of purpose and focus. But what happened over time, I didn't immediately realize this, but the importance of free software developed over the years. And so, skipping all over. So going back to the nightmare, it's like we see this and now we need solutions. And one of the things I actually learned about Plycycling, it's basically a random act of kindness machine. And so when people see me doing it and they understand what I'm doing, they don't think I'm a homeless person that has a grabber to fish cans out of the dumpster. When they see me do it, their inner light shines a little brighter. And I really think that that's like a very important thing that the world needs right now. And so, but free software is a little more involved. So I really wish I had a better way to describe this because I'm a pacifist, but we are locked in combat for free software and our very future. The proprietary software, the major proprietary software developers of the world would make free software disappear. They would make it disappear if they could, but they can't because they would have done it already. So clearly they're not able to. If you ask Microsoft, hey Microsoft, do you want to own all free software? They would say yes. And so, and it doesn't mean they've given up. They're still trying to not have free software, and that's my opinion. But there's a bigger picture here I'd like folks to consider, because it's more than just free software is at stake. Hold on a second, lost my train of thought. Yeah, it's more than just free software that's at stake. Our battlefront is computer user freedom, but the war is multifaceted. I mean, there's people that are fighting for things all over the world. They're fighting for like clean water and food, freedom of speech, freedom from being oppressed. I mean, these people are fighting. They're out in the streets. Some of them even giving their lives for these fights. And if any one of those battles is lost, our future it's going to be very, very bleak. And so I believe that control over one's computing is a human right. And if the free software movement fails, you can say goodbye to privacy and freedom of speech, amongst other things, I'm sure, especially online. I mean, it'd be over. And so that's kind of why we fight. Because what do we want? We want freedom. They want to take it away. And one of the most important defenses that we've had over the last 40 years is the GNU General Public License, which works with the legal framework of law and to make sure. So the GNU General Public License wasn't the first free software license, but it was the first free software license to guarantee freedom then, now, and into the future. That's how it was designed. So this is why the free software movement exists, and this is kind of what it means to me. It's to spread and protect computer user freedom. But it's also up to the community to kind of make sure it stays strong. So when somebody says open source, instead of talking about freedom, it kind of weakens the cause. If somebody chooses a permissive license over a copyleft license, it weakens the cause. If somebody uses a DCO over a more substantial legal agreement for their free software contributions, it weakens the cause a little bit. And heaven forbid somebody uses a non-attribution permissive license for their work because it weakens the cause. And now everything I just referenced, I'm just going to leave dangling there and not explain it. And you can come find me at the Free Software Foundation's table. And I'd love to talk to you about it. And this is also one of the reasons why I say free software instead of open source, because I learned a long time ago that if I want to talk about freedom, you put the message first, even if it requires a little additional explanation. I think it's kind of funny because one of the excuses that was given as to why they had to say open source is because people were confused by the word free. You know, oh, is it cheap? What is it? Not quality. And it's funny because you can say free society, and nobody goes, "What do you mean free society? What? Nobody pays for anything, and just the government just does all the work?" It's like, no, it's a society where people live in freedom. But if you say free software, people are like, what? It's like, free isn't freedom. It's free as in freedom, not free as in beer. Free as in free beer. You say free beer? It's like, yeah. And that's fine. That's fine. It's just part of the process. So now I'm going to talk a little bit about. So that's kind of my story. I guess that's the summary there. That's how I got here. That's why I'm passionate about it, because I really do think that it's if we don't have control of our computing, we're donezo. That's just my take. And so now I'm going to share with you some of the things that the Free Software Foundation, if you wanted to get involved with free software, there's plenty of opportunities that the Free Software Foundation offers for volunteers. And so, I missed my conclusion. I suggest everybody find a position and gird yourself for final combat, because that's kind of where we're at. And that again, the free software movement is about freedom and a fight for a better tomorrow. So now we get into the opportunities. So the licensing and compliance lab, which I am a part of, we have several things that we're looking for volunteers. The first one on the list here is we have what's called the Respect Your Freedom program, where we basically certify devices that are run on fully free software. It's the same thing like you would see like a little organic stamp on food. It's just that kind of certification. And that's in tied with, it's called hnode.org, and it's basically a catalog of software that we know, or hardware that we know runs on free software. And so if you want to get involved with that, the RYF, there's a lot of kind of preliminary work that needs to be done, being able to get the source code from the person, compile it, put it on the device, if somebody's interested in doing that kind of work. It just basically, it would create like a report for us, and then we can, we would double check it and then work towards certifying the device and getting more devices certified. We also, so the GPL compliance is a big part of our work, and we receive reports from the public, and a lot of times it just says XYZ won't give me source code, and that's it, and it doesn't give links to anything. And so what we would need from volunteers is just a more comprehensive report that's actionable, that we can see that they're distributing binaries. Where is the source code? And maybe even the volunteer takes time to like reach out to the thing going, where's it at? Because a lot of times it's just a misunderstanding. They don't understand what their obligations are with distributing source code for especially GPL software, because that's obviously what we focus on. So that's something for volunteers to do. The next one is, this is a fairly new activity for the FSF, and we're calling it GPL stewardship. And what it is we are no longer tolerating people modifying the GPL outright. Sometimes they just put like a section in the middle of it, and it's a document that is not authorized to be edited, or it's just you can't edit it because it is copywritten work by the Free Software Foundation. And they also, what people will do, will add on an additional restriction, Like they'll throw on something on the bottom of it that says you can't use this for commercial purposes or something like that, when the GPL clearly says you can use it for however you wish. And we look at that as, one, it confuses people, because this day and age, if you see the GPL, you kind of know what you're in for. And if all of a sudden there's some extra clause on there, you're going, well, what is this? It might confuse some people. And also, it helps understand if they did put an additional restriction on that license, the GPL allows you to remove it. It clearly says if this license has additional restrictions, you are allowed to remove it. So it's like, well, why put it there in the first place then? And so there's kind of a back and forth, and out of the handful of people we've been interacting with, they're all pretty responsive. Some of them go full proprietary, which isn't optimal, but at least they're not confusing people with our license. It also affects our trademark. I don't know how else to say this, but we're protecting our brand. Basically, when you see GNU, much like the GPL, you know what you're in for. You know what you're dealing with. And if they do something to make it confusing, then that confuses consumers, and that's kind of what trademarks are all about. Another one is if you're really our website says Law Geek. I wish I would have said something else, but we actually answer licensing questions from people who are interested in developing and releasing their software developing and releasing free software. They write into us, and myself and my coworker, along with some very talented volunteers, answer those questions. It's a pretty valuable service. We can't give legal advice. It's more or less consultation. But if you put a dollar amount on it, it's like $300 or $400 to answer a question. Basically an hour or two of our time. But if you're developing free software, that's a pretty nice thing to do. And it's also, if you're really interested, it puts you on kind of the front lines of software licensing. I mean, we get a lot of routine questions. We have a lot of materials. We have a FAQ that's like 170 plus questions and answers of how the GPL and free software licensing is supposed to work. So we get a lot of questions like that, but we also get like some really tough ones that we have to think about and do some research. And if that's of interest to you, that's a great way to get that exposure. The next one is the free software directory. So every Friday from noon to 3 o'clock Eastern Standard Time or Eastern Daylight Time, we have what's called the free software directory, and that's actually what my workshop is about later, is taking a program, examining its license, using tools to kind of look at the files, discovering non-free stuff in there. And the beauty of that is, and this happens all the time, is we will find there'll be 2 files in there that are non-free. And we have the volunteers reach out to the projects. They'll file an issue, let's say on GitHub, and they'll fix it. And that's really kind of grassroots, helps free software. The next one is endorsed distros. So one of our programs is we review distributions that are fully free, and then also don't promote non-free software in their materials and stuff. And that's a lot of work because these operating systems, they're very complex. And so if that's something you're interested in, we have those available to you. And then the last one is, it's not really licensing related, but we have these GPL interviews. So if there's kind of cool, interesting projects out there that use the GPL v2 or AGPL v3, or no, what did I say? The GPL v3 and the AGPL v3, we try to promote the latest, even though the AGPL v2 is a quite nice license. So if you wanted to learn your editing skills, interacting with interesting people, doing interesting projects, that's certainly an opportunity for you. And that's kind of the licensing side of things. The next one is the campaigns team. And they do a lot of stuff. It's more, this is like actual activism. And there's all kinds of things to get involved with. The first one is the Freedom Ladder. And that is where we're trying to, for people that are stuck on proprietary software, we know they're not going to use an X200 that's fully free, but we can get them going. It's like, take that first step, get off of Windows, use something that's not Windows or Mac. We have the Fight to Repair, so that's basically our contributions to the Right to Repair movement, with of course focus on software, because you can't repair something if you don't have the source code to it. There's the free JavaScript, so if that's something you're interested in. We also have a set of high priority projects. If you're a hacker, that actually ties into the GNU project. If you want to contribute to GNU, that's a great way to get involved. There's secure boot versus restricted boot. Basically, it's just making sure your computer boots up on free software. And of course, we have programs against surveillance, getting off of Windows. The working together for free software is just trying to collaborate with other free software projects, getting us talking to each other, that kind of thing. There's the Defective by Design, which is we're against DRM. It's digital rights management, but we like to say digital restrictions management because that's what it's used for, is to take away your ability to have control over your data. The end software patents, that's a pretty big one. Basically, software patents need to go away entirely. They never will, but they need to. So endsoftwarepatents.org is a really good resource if you're interested in that. And then there's work to be done in that area. It's a little more kind of lawyery stuff, but if you want to help out, there's a place you can get some stuff done. Then there's the campaign for open documents. This is just a general, we need to not have proprietary formats. The campaign for hardware that supports free software. Of course, that's like the RYF program and the H node, and then the free BIOS. That's a pretty challenging thing because most BIOSes are locked down. And I think that's it. If anybody has any ideas of how else to get involved, you get to shout them out. Not at the same time. And if there's any questions, I'd be happy to ask them. Yeah, go over there. Oh, thank you, sir.
GPL view on all the LLMs that are trained on all the free software?
Right, that is actually an ongoing thing. Earlier this year, the FSF made an announcement that it's going to make an announcement about LLMs. It's pretty complex. Earlier this year, or maybe within the last year, the Open Source Initiative had published a thing called the Open Source Definition, Open Source AI Definition. And it was done with the community. It was a group effort, but I don't think it was as well received as they would have liked because apparently it's really complex for some reason. I don't know why. I have my opinions that aren't very well formed. But yeah, so to answer your question, the FSF is going to comment on it. So at this point, the models themselves can easily, it's licensed under this. But then once you start dealing with the weights and the kind of training aspect of it, people don't know how those should be licensed. So, yes.
So I guess my question is, like, I really like the analogy of comparing the situation to combat, and like, but at the same time, like, I see like a lot of the stuff listed is like stuff that's either like defensive or like stuff to just like maintain what already exists. Do you think like the FSF has like a proper roadmap for going on the offensive again?
Well, I would say that the GPL stewardship that I talked about earlier, that is, I guess, as offensive as it gets, because it's not that hard to find people violating it. Like it's really, unfortunately, very common, and we can only deal with one or two at a time. Yeah, well, just kind of the thought on that is one of the things I realized, at least for me, is whatever solution that we get to, we can't make an army to defeat an army because then we'll have an army with nothing to do. You see me? So it's got to be a peaceful solution. But yeah, I think the FSF doing getting a little more with the compliance and the stewardship stuff is kind of fits that.
As you
Yes.
see, as a potential focus area is phones, because it's sort of meeting the people where they are. A phone is the most common computing device that the average person has, and I don't see a whole lot of space to help people move to phones that are free
free software, largely free software. It's walled garden after walled garden after walled garden. And unfortunately, if you want to have a freer phone, there's a pretty high barrier to entry to it.
Yes, yes, and actually, I don't know if it's public information yet, so I don't think I'll get in too much trouble because it's right around the corner. But we, the FSF recently got a grant, and we're hiring a contractor to address that specifically, the mobile devices, and because there are options out there, they're very far and few between. But again, this is going to get broadcast, so I'll just take my lumps if I wasn't supposed to say that.
In my view, this is the most important thing for a computing device to be free for
Right.
freedom is in liberty of the individual.
Right, right, yeah, it's working on it. Yes?
As far as promotion goes, is the FSF doing anything in regards with Software Freedom Day this year?
Probably. That's something the campaigns team typically handles. It's not really, I mean, I'll participate if there's something to do, but they're the ones that orchestrate any kind of official activity. I think they organize something. They try to put some meetups or something together. And
Yeah, but this is a veiled thing. We are doing one in New Jersey this year, so come join us, free software.
Right.
That's what we're doing.
Yes. In the back there.
I just had a question. I want to say, I can't say recently, because I don't know how long ago this was, but there was a startup that used ChatGPT to generate their license. It was a bad license, a little bit of kerfuffle. I was just curious if, like, in the age where a lot of folks are using AI in various different ways, if you've seen a lot of it being used with licenses for software, or has that sort of impacted sort of not just like in the training stuff, but more like in are people like generating licenses with AI, and then has that sort of led to not necessarily issues, but interesting situations where somebody might have like maybe copyleft language in a license that they weren't intending?
No, that's a fair question. A good question. So there's this thing called license proliferation. It's people keep writing licenses, and I really wish they would stop. We've got plenty, unless your license is addressing a very specific thing that doesn't exist in other licenses. That's great, but most of the time they're just kind of repeating what's already out there. I will say unnecessarily. If they're using some kind of machine learning application to create this thing, that's probably not going to end well. Because basically people send us licenses to review, and it's like the first question is, has a lawyer looked at it? And if the answer is no, it's like, thank you. Because that is definitely legal territory. And if, like I said, if they're using an ML for something like that, it's probably not going to get much adoption. And if it came across our plate, if we did review it, we would probably, we'd give it a fair shake. But normally, if a new license shows up, we ask like who's using it, who wrote it, how many, if it's being used by 3 programs, it's like, oh, okay. But if, something's catching on, yeah, we want to address it because we do maintain a list of licenses that are 1, free software, 2, are they compatible with the GPL, and if they're not free software, or free software licenses, yeah. Thanks.
Thank you.
Over there.
Say you find some repo is not using the license properly, right? What are your enforcement actions you can do? You just take them off the list of ones that are following it properly, or can you sue them if they're using it properly? Or?
So you're talking about the GPL stewardship where they've modified it. Well, typically, the ones that we've done, we just reach out to them and say, point out our concerns with it. Like I said, some are more obvious than others. There was a company that, if anybody's familiar with the Commons Clause, it's an additional restriction. It basically says you can't use this for commercial purposes, and they'll just tack that onto the bottom of the GPL, which technically is fine. They can do that, but they should know that whoever receives that license can just remove it. So it's like, what's the point? So yeah, we just reach out to them. A lot of times it's just a mistake, especially if it's like a little project with like 10 contributors on GitHub. They just don't know, and they'll fix it right away. The responses have been generally cooperative, and teachable moment. So, cool. Anyone else? Oh, oh.
Just to expand on that last question, what happens if the response isn't cooperative?
Oh, you actually sort of asked that as well. So technically, what's happening is if it's not responsive, they're violating our copyright by modifying a document that's not allowed to be modified. And I mentioned earlier about the trademark. Because we do allow people to, if you really like the GPL, but you wanted to make it your own, as long as you take the preamble off, remove any reference to GNU in there, and the how to apply it to your program, you can do it. And we won't say anything as long as it's now yours, and you can do whatever you like with it. So yeah, does that answer your question? Did I get it? Okay. Cool. Yes, sir.
Can the general public license or the copyleft be applied to other things? Like, for example, I've made up some video that I ultimately would like to publish on YouTube. I'm not looking for any monetization, but I want to be able to prevent somebody from copying it and then charging people for it in the future.
Right, okay. Well, that is possible. It's just about finding the definition of source code in the whatever you're licensing under. So video might be a little more trickier.
Creative Commons has
I was gonna, yes, Creative Commons. Yes, and we do. If you look at our license list, we do recommend the Creative Commons licenses. There's a non-commercial CC by NC. Yeah. So that would do it. That would. And feel free to come by the FSF booth, and I'd be happy to talk to you. But yeah, the look in the Creative Commons licenses, and they're copyleft and cool. All right.
Yeah,
Oh, question.
I can give a quick benefit of open source from working in the research side of the world with scientific instruments. I've had issues where the vendor goes out of business, and if you don't have the source code to it, as in if you haven't pressured them to make it open source or free, you're out of luck.
Yep.
If you need to support it, there's just nothing you can do because otherwise it's binary blobs and good luck.
That's
And
unfortunate.
It
Yeah.
may be very expensive in terms of the equipment.
Right. That's how that happens. Oh, yeah, back there.
Did you say that the new license is copyright?
Well, it's copywritten. Yeah, the GPL right at the top says copyright Free Software Foundation. This document is free to distribute, but modifying is not allowed. Yeah. But it serves as copyleft, if that's what you're getting at. All right, well, I'll be at the FSF table if anybody has any more questions, and thanks again.
to capture that moment, and we did. So we
It really started as a bar bet, let's be honest.
So we created a set of tools to study global peer-to-peer file sharing and the distribution of media on the internet. Through Alpha 60, we are learning the quantity, location, and time of uploads and downloads via the BitTorrent protocol. We put our anonymized results in public on our GitHub, and since 2018, we have collected data on approximately 568 media texts and over 4 billion downloads. That's approximately 7 million downloads per text. What do we sample? We sample media texts, by which we mean films, TV series, music, and books. We also sample leaks, such as leaks related to the Russian-Ukrainian war. So I think we should put invasion in that sentence. We sample leaks pertaining to Iran, to China, the Tashera Discord leaks. We also sample files pertaining to 3D printable weapons, also known as ghost guns, like the Glock 19, allegedly used by Luigi Mangione to murder United Healthcare CEO Brian Thompson in December 2024. What Alpha 60 measures that other systems don't. So Alpha 60 captures a more complete picture of information flows than official systems like Nielsen do, by quantifying and mapping informal, quote unquote, pirate network activity. Alpha 60 measures global information exchanges, not single country ratings, which is mostly what you get from official systems. Alpha 60 makes our data public via our GitHub, whereas streamers offer little data transparency. Alpha 60's methodologies are cross-platform, unlike streamers, which use proprietary per-platform metrics. Alpha 60 measures peer-to-peer sharing of information that is expressly prohibited or illegal, such as leaks of classified government documents, queer media texts in China, Russia, Saudi, and other countries with anti-LGBT laws, and US media texts that are not given official releases in China and other countries. Okay, these are some of our generated outputs. This is an animation of Game of Thrones Season 7, Episode 1. This is the first 5 days cumulative downloading around the world. And so you can see certain places are awake, other places are sleeping. And then as time goes on, after the premiere on HBO, certain cities wake up. And as the circles get bigger, that indicates more downloading. Purples and pinks indicate higher res. Greens and blues indicate lower res, and when downloading's really hot, the name of the city will appear in letters. So you can see now Seoul's really awake, Athens is also very awake, but if I forward it a little bit, you'll see different cities start to wake up. Toronto, Sao Paulo, and so on. Okay, and then let me just advance one slide. All right, I'm gonna let Benjamin talk about this one.
This is a different map. We're going to go into the maps later. This is Stranger Things, the last Stranger Things. The weekly, this is a much shorter one. So these are the maps. Week 1, 2, 3, 4, 5, 6, 7, 8. That's it.
I'll talk about the orientation.
Well, I'll talk about the maps a little later.
Okay. All right, and then, oh, I think this is still you.
Yeah. So this is another output. We are, this is a experimental map of Black Panther. This is just the this is a slice of the Americas just for the high resolution peers, or high def peers. So this is 1080p peers in the Americas, and you can basically, orange is 4K, pink is 1080p. So this is just a 1080p slice, but you can really see the kind of big usage in Rio, South America, which was a little bit surprising. I don't think the Americans stuff is not surprising, but what's kind of interesting about this map is the Caribbean area and the circle of high activity in the islands part. And this is much smaller. It shows you just an idea of kind of like the distributions we're looking at. And so this is a 4K distribution from 2018 for the same text, Stranger Things. And you can see this is a little bit more indicative of the wealth of the people downloading and who has access to 4K display technology. So you can see that, again, East Coast United States really heavily represented, and then the Sao Paulo, Rio also as hotspots in this. So we have a whole bunch of mapping techniques that we've developed as part of this. And part of this is refusing to use projections that are known flawed to represent internet phenomena in the year 2025. We got to get beyond this. So I work with some people at Constant in Brussels, Philippe Rivière, and we're using a Cahill-Keyes projection modified, which was originally an anti-war, anti-nuke projection, which seems appropriate for us. And this is actually a map. I'm using this just to show the Americas slices here. We see the lines as fiber, and then we have various other infrastructure markings on this, Tor exit nodes. We have points of presence for CDNs, and a couple other network niceties in this. I have, this next slide is just the CDNs for North America, and this would be stuff like Netflix runs its own CDNs, then we have Fastly, we have Cloudflare, we have all these people that are trying to get you that video streaming so that it's not janky at your home thing. What they use is servers all over the world to kind of cache data, and that's what a CDN is. So in the distribution of video on the internet, CDNs are really important. Of course, peer-to-peer operates as its own CDNs. So this is kind of what peer-to-peer is competing against. Here's our GitHub. we talked about it. This is how we put structured data in public about all our releases. Here it is. If you have questions, shoot us an email. The other thing we do is we have a website that talks about the bar bet, which is how are these media texts in relations to other texts? So from our sampling, we see in 2024 that Dune 2, 26 weeks, we're looking at about 89 million downloads, unique peers during that period. That is an all-time record that still stands. We'll see what Stranger Things later in this year does. But Squid Game also very impressive. Fallout, top 3. Godzilla, Inside Out, Arcane, What If, House of the Dragon, Shogun, etc., etc. So this is a kind of a way to get relations among media texts that aren't usually relatable across platforms, film and television, and some other things which we'll get into later.
Okay, so now we're going to do a deeper dive into volume of peer-to-peer traffic sampled by Alpha 60. So these are the number of media texts sampled by our toolkit per year from the year we started, 2018, to now, the total number of downloads that we tracked per year, and the average number of downloads per text. So you can see that we've been mostly increasing our sampling, although 2021, California was still under COVID lockdown. We sampled quite a few more texts, but we've sort of evened out into the 60s per year, 2022, 2023, 2024. But if you look at the total number of downloads column, you'll see that even though we maintain this roughly the same volume of text sampled for between 2022 and 2024, the number of downloads that we were tracking greatly increased. So in 2022, 65 texts yielded 353 downloads, but in 2024, 61 texts, we saw almost 2 billion downloads across those texts. So the average number of downloads of text has been increasing pretty dramatically, where, in 2022, we were seeing 5.4 million downloads per text on average. In 2024, we're seeing 32.6 million downloads per text on average. And we only have, up until mid-August in 2025, but it does look like the 2024 downloads per text numbers are sort of, at roughly the same place. They haven't sunk back down to the 2023 or 2022 numbers.
Hey, didn't you give an interview to Wired Magazine in 2023 saying it was a golden age of piracy?
Okay, my interview to Wired Magazine was actually, or my op-ed for Wired was actually in 2020. So I was a little early.
Okay, but
yeah,
these are some
but
receipts
I predicted
claim.
that COVID would yield a huge spike in piracy, but it looks like that came a little bit later than COVID. Okay, this is just fun facts. So when we compare the total number of downloads that Alpha 60 tracks to the total number of subscribers that Netflix has, you'll see that we were sort of on that par in 2019 and 2020. So it's not really, it's not like a solid data point that we need to advertise or anything, but in 2019 and 2020, the volume of downloads we were sampling was roughly equivalent to the volume of subscribers that Netflix had. And then our downloads far outstripped the number of Netflix subscribers in 2021 and 2022. And starting 2023, our total downloads that we were sampling was roughly equivalent to the total number of subscribers of all major streamers combined. Netflix, Amazon Prime, HBO Max, Hulu, Disney Plus, Paramount Plus, and Apple TV Plus. So just so you know how much we are downloading, or how many downloads we track. Okay, now we're going to dig deep into one case study, one universe, which is the Star Wars television universe.
Yeah, right. Thank you for that. I just want to remind people that Disney Plus is an American company, and it is not available everywhere. As a matter of fact, it was pulled in Russia after the war. So no surprise that we saw a lot more downloads in Russia after that. But here's an idea of kind of like, as we show you more maps and as you can kind of put this together yourself, you can see that Places that Disney neglects are Russia, China, large parts of Africa, large parts of the Middle East. They have a subsidiary in India called Hotstar that they bought. So we're going to count that as Disney Plus, even though it's technically a separate entity, but it's the same content. So we're going to go with that. Here is our sample set, okay? From 2019 to 2025, these are all the specific episodes of media text that we sampled. And you'll notice that we're not sampling every set. We're sampling kind of the first 2 or 3 episodes, the last 2 or 3 episodes, and then we can interpolate kind of results from that. So this is the sample set for the rest of this talk. And then what I want to do is just kind of clarify a little bit of things when we say sampling, and we start saying things like billion. We are not downloading a billion movies. Just let's be really clear about that. What we are doing is we have a set sample length of 10 weeks, 15 weeks, 26 weeks. This is somewhat arbitrary. Nielsen uses a 5-week limit, and we wanted to kind of establish long tail and try to come up with more interesting metrics. The procedure is we collect torrents. We create a torrent set for each media text. So let's say and/or 101. I can't actually remember the size of that set right now, but they're all between 100 and 500. We put in a cloud samplers, that architecture is a separate talk. We're not going to talk about it. And then we just run that every 3 minutes for weeks or for half a year. Again, we are sampling metadata only. We are not downloading movies. We consider the ability to track distribution a feature, not a bug of the BitTorrent protocol. Okay, here's some results. There's a lot of ways to look at this, so I'm gonna present a couple different views of this data. This is normalized start. So what does that mean? So that because we're starting things over different years, we're gonna normalize everything to the first week that they were released. So on this, you can kind of see this is a weekly cumulative of unique peers or unique downloads. And you can see on the right side labeling, you can see that per week, Mandalorian 208 at the time of the creation of this graph was sampling very steadily at about 2.5 million peers a week, which is pretty impressive for peer-generated CDN. And you can see the next performant title would be the Acolyte series, which Abigail's going to have some commentary on later. And then Ahsoka also coming in really strongly. You see kind of Mandalorian fading a little bit, and Andor first season, Obi-Wan, and Mandalorian third season kind of tailing all the rest. Here's another way to look at it, and that is instead of like every week, we think of every week cumulative. This makes the situation a little bit different. We can see that in terms of the unique peers, Acolyte is very far ahead of Mandalorian. I did this graph before we had a complete sample. So I can tell you now that Acolyte 101 did indeed surpass Mandalorian 208 at the 26-week mark. So Acolyte, that Acolyte series is actually the top sampled Star Wars property that we have dealt with so far. And then when I presented this result in San Francisco, they were asking about, we would like to see this in time. So you normalize these starts, it's really interesting, but tell me about how this was actually received at the time. So here we go. So 2019, bottom right, sorry, the slide is not labeled, that little green line. So these are all normalized for the kind of bigger downloads we see later in the years, like 2025. So Mandalorian, huge success. These are like the first 4 or 5 weeks. We hit like, I don't know, 6.5 million. This is the next year. So it's kind of continuing in through the first part of the year. It kind of tops out, Mandalorian 101 tops out around 19 million. And then you see a dark green line on the right side of the screen. That's the second season of Mandalorian starting. And And then, so that's continuing in the same line. You'll notice if you have a visual memory that these lines from Mandalorian are roughly the same. They're the same slope. They're about the same height. So Mandalorian season 1, season 2, we're inferring are relatively the same in terms of distribution. We did sample all the Star Wars animated things. We think they're really important for the Star Wars universe, for Star Wars fans. But this is not really what we're going to dwell on this talk. Okay, here's where things start to get a little bit more interesting. Book of Boba Fett. I liked it. Not as many people did the other ones. Obi-Wan Kenobi, you know, there was some Mandalorian in that, but maybe people didn't realize it. Again, these are kind of underweight the other ones. Andor season 1 starts out, kind of ends in a nice place. I would say Mandalorian season 1S, maybe a little lower, a little flatter line. Then we get to Mandalorian season 3. Maybe that's underperforming a little. And so on these lines, we see a dark line is episode 1. The dashed line is the last part of that. So we see that the dashed line is...
it's the last episode of the season.
Oh, yes. It's the last episode of the season. So it's about the same slope. So it's about the same, but yeah. 2023, things start to pick up at the end with Ahsoka. Ahsoka, you can see the slant on that line is a lot higher. So that just means like more interest. And you can see the dotted line on Ahsoka is the end of Ahsoka season 1. And so you're seeing that those slopes match. So you're looking at that series having continuity through the life of it, where there's as much interest at the beginning as there is at the end. Whoa, what's this? So it turns out Ahsoka ends up above Mandalorian on this, which is pretty interesting. And then the real interesting thing is Acolyte, which looks like, wow, that looks like a huge success here. Also, wow, that it ends stronger than it starts. That's also cool. Abigail, why do you think that got canceled?
Right. So I think that there's just a couple hypotheses we have about the success of Ahsoka and Acolyte, which if there are Star Wars people here, you already know this, that Ahsoka is a character that debuted in the animated series called The Clone Wars. The Clone Wars, you know, like some people think redeemed the terrible prequels, and Ahsoka has been able to like build her fandom over more than a decade. So when a live action Ahsoka show debuted, perhaps that accounts for this, you know, outweighted success. But it doesn't really, that hypothesis doesn't really account for the fact that Obi-Wan Kenobi, a beloved legacy character from the original trilogy, doesn't get as much play in the Pirate Network as Ahsoka does. So there wasn't as much hunger to see live Obi-Wan as there was live Ahsoka. But it's notable that Ahsoka and Acolyte, the two highest performing texts, according to Alpha 60 in the Star Wars universe, are both led by women of color. I just want to note that. And that Acolyte was canceled after one season, despite what we are tracking as its very strong performance. It's like, you know, it's basically top performance in the Star Wars television universe. Now, the Acolyte had some very distinct characteristics in the storytelling, one of which was that it was all people of color who were leads in the cast. Another one is that the Acolyte is the story of a young Padawan, you know, somebody who was in Jedi training, who goes over to the dark side, led by a Sith Lord who tempts her sexually. So I think that's maybe the first time that's happened in the Star Wars universe, that there is, that evil wins, and evil wins through, you know, of course, lust is probably a part of the dark side, but we never saw that on screen before. So I think that there's some reasons, some story reasons why the Acolyte was canceled, but it is notable, according to our findings.
And then that brings us to this year to date. So again, the sampling is not done. We're still at mid-season on this. And this, we have 3 confusing lines instead of just 2. So we have the dark one is
Andor.
Andor, sorry. Andor, this is Andor season 2. The dark line is the episode 1. The small dots are the last 3 of Andor. And then these...
What season?
Season 2, the most recent one. And then these little dashed lines are us sampling season 1 right when season 2 was released. So what we're seeing here is long tail, right? And we're seeing that after the second season was released, season 1 got a lot more popular. So this is important to think about in terms of what's going on with media and seriality and streaming, and why are they doing things like all these sequels and then breaking up things like Wednesday into part 1, part 2, et cetera, et cetera. And they're doing the same thing with Stranger Things. So this could be a reason. Okay, and I just feel like I have to gratuitously show you a map. This is a map of the Mandalorian distribution all throughout the this Pacific plate. Again, really strong representation in South America. And this is Europe. But one of the things we really notice is that Europe has about over 50% of piracy always. Asia kind of brings up 27%. Americas is kind of like around 20%. So this is kind of like routine for media distribution on distributed networks. The other things to note here is Africa. So Africa is tremendously understudied in media distribution in this country. And you can see the parts of Africa that are lit up by this text are Ivory Coast. And if you remember the network maps, you can see that there's very strong network linkages to that part of Africa. And South Africa also is the major player here. The other thing of note here is, of course, India, super hot. And I didn't do separate high def, low res separations on this, but in general, Korea, Beijing are the hotspots for 4K downloading. This is definitely related to the more advanced network infrastructure in those countries where they can download a 4K movie, no big deal.
Okay, so now we're going to get into the rankings of the top downloading countries and cities for specific titles. So I just chose 3 titles in the Star Wars TV universe, Ahsoka, Andor, and Acolyte, probably because they all begin with A. So here are the top downloading countries and cities for Ahsoka season 1, episode 8, so the season finale. So you'll see downloading countries, Russia, Korea, USA are the top. Downloading cities, Moscow, Seoul, and Shanghai are the top. And you can take a look at the rest for a moment. And then we'll look at Andor season 2, episode 10. Top downloading countries, Russia, Korea, USA. Top downloading cities, Moscow, Shanghai, Seoul. And take a look at the rest of the lists. And then Acolyte season 1, episode 7. Top downloading countries, Russia, Korea, Turkey. Top downloading cities, Moscow, Seoul, Shanghai. And you can take a look at the rest of the lists. Okay, so here's our comparison across Ahsoka, Andor, and Acolyte. There are 9 countries that are top countries for all 3 texts. Russia, Korea, USA, Brazil, Turkey, France, China, the Netherlands, the United Kingdom. There are 7 cities that are top cities for all 3 texts. Moscow, Seoul, and Shanghai are the top 3 for all 3 texts, but not always in that order. So what's going on in those 3 cities, I don't know. Maybe they just have an especially strong Star Wars fandom in those places. And then the other cities that are consistently in the top cities lists are St. Petersburg, Amsterdam, Istanbul, and Ashburn, Virginia. Now, Ashburn, Virginia is a place that... So a comparison across Ahsoka, so continuing the comparison across these 3 texts, let's just hypothesize, do countries that don't have access to Disney Plus download a lot? And so Russia is a top downloader, China is a top downloader, but all the rest of these countries do have legal access to Disney Plus. So it's not always about legal access. The other thing to note is that, the other question I asked is, well, do countries whose first language is in English download text whose language is English? So the USA is a top downloader, the UK is a top downloader. They are, speakers of English, and that's the language of Star Wars. But nevertheless, all the other countries on this list are not English first language countries. So language isn't, apparently a super motivator. It does seem like, because we know that Disney Plus releases text with subtitles and dubs, and they're really good, the Pirate Network gets those files right away as well. So it probably doesn't matter what the language of the original, what the original language is, because people in any language can consume these texts right away. Okay, these slides just basically say that. All right, what about Ashburn, Virginia, which was in a top downloader of all of those 3 Star Wars TV shows? There were other cities that appeared in the top 10 for several of those shows. One is Yekaterinburg, Russia. Another is Novosibirsk, Russia. So then I just started hypothesizing about what might be driving super traffic in cities that we just haven't heard of, because every other top downloading city, except for these 3, are like global cities, like Amsterdam, like Istanbul. So what's up with these 3? So the first thing I looked at was the number of data centers in each of these cities. And Novosibirsk only has 6 data centers. Yekaterinburg only has 9 data centers, although it is called a critical regional data center hub in Russia. But Ashburn, Virginia has 143 data centers. So a lot of the traffic we see in Ashburn, Virginia might be VPN traffic.
Hosted by AWS East.
Right. Amazon. So another hypothesis I wondered about is, what about military installations? Because just anecdotally, what is there to do if you're in the military and stationed on a base? You pirate a lot of TV, or you pirate a lot of movies. So I just looked at how many military installations are in each of these places. Andrews is in Ashburn, Virginia, or at least within an easy drive of there. But Yekaterinburg is the headquarters of one of only 5 military districts in Russia. So Yekaterinburg is a major military hub of Russia. And Novosibirsk also has the 41st Army stationed in Novosibirsk, and several other military units, including Air Force bases. So it does seem like military presence might account for some of this super downloading there. I looked at universities. There's just a kind of, conventional wisdom that universities do a lot of downloading. There are a couple universities, within 10 to 35 minutes of Ashburn, Virginia. There are 9 universities each in Yekaterinburg and Novosibirsk, so that could be driving traffic. Maybe the orange cells are the maybes, and the green cells are things that I think really are probably drivers. I'd also put a category in here called other, and I just wanted to say, you'll see the green cells under the Russian cities, that Yekaterinburg and Novosibirsk are cities that rank at the second fastest downloading speeds among Russian cities. They tie in terms of downloading speeds with St. Petersburg, Russia. So Moscow has by far the fastest downloading speeds in Russia, but there are 3 cities at that second fastest level, and Yekaterinburg and Novosibirsk are 2 of them. So a high number of data centers, 1 or more military bases, and very fast internet may be contributing factors, sorry, that's a misspelling, in high volume, far above average peer-to-peer downloading. Okay, thank you so much.
We will accept questions if you have them.
Yes. Oh, okay, sorry. You first, and then you. Yes.
Are you, for 2025, doing only murderers in the building?
Yes, we will. We restricted this just to Star Wars, just to kind of like contain us a little. But yeah, we're definitely doing only murders, and we have done all seasons of only murders.
You have data on that?
Yes, we do.
Just go to your website, the GitHub?
Yeah, the GitHub does have the data for that.
All right.
Yes.
one, have, you know, the know-how into pirating media? Like, what kind of persons are there? The definition has kind of changed from like even 10 years ago. People younger and younger, getting more technologically savvy and having more greater access to devices and tools might have more knowledge than even millennials and Gen Z and how to torrent movies and such. And then I also wanted to know, like, you took the top 3 shows, and I know you're not screenwriters, but like, would people from non-English speaking countries or people who aren't as cognizant of American culture place a greater importance on plot structure for how good a show is? Because anecdotally, I have cousins who are very verbose in the entire Netflix catalog, more so than I have their finger on the pulse. They've probably seen everything without having been there and really absorb and dissect everything about the show into a high caliber, like almost Shakespearean. And so they might have more of a critical edge, like as more so as a movie critic, because it's like culturally different.
Yeah. Okay, I'll speak to the first question, and then I think we both have things to say about the second question. So thanks for those great questions. So the first question was about who is downloading, and could younger generations have more technical know-how and so participate more in the peer-to-peer network than older generations. So, I mean, I think that's probably true. I also have done interviewing of media pirates, media and information pirates, and so you can read my book that's coming out next year called The General Library from MIT Press. And the General Library that term came from one of my interviewees who misspoke. She said, I download all my science textbooks from the General Library. I said, oh, what's that? And I've never heard of that site. And she said, oh, it's called GenLib. It stands for General Library. And I mentally knew, oh, no, that's not correct. It's called LibGen. It stands for Library Genesis. But I found her term General Library to be so useful and helpful for just denoting that there's always been a way to get texts illicitly. There's always been a way to not have to pay for certain media and information and to still acquire it. And so I call all of the pirate network for all of time the General Library. And who uses the General Library? My book actually ended up focusing exclusively on people of color, queer people, women, disabled people, and other minorities, because the General Library is immensely helpful to those groups because, not just for, of course, socioeconomic reasons, but also because information is really restricted for a lot of groups. For example, girls who grow up in very conservative religious households cannot access a lot of media. They are told not to watch or listen to a lot of kinds of media. And the same with children who are suspected of being queer. Their parents put prohibitions, bans, give them talks about how we don't allow that kind of media in this household, and so on. So my book really focuses in on how people who are disadvantaged or minoritized or marginalized really turn to the General Library for media and information. And one thing that I argue is that these are people who don't have a lot of privilege, but what they have is technological privilege. So I feel like what you're talking about is technological privilege. If you know how to pirate, if you know enough about how to work a technical system, then you can get all the media and information that you want. And people are like, for example, college students who have scholarships to college, but they aren't given a ton of extra money to afford all of their science textbooks. They use their technological privilege in order to close what I call the resource gap. So I think that's really important, that young people are leveraging their technological privilege to, try to make their way in this world. So I think that's a really important, finding of my interviewing. But as for the second question, which is also really great about whether, for example, like people who don't speak English as their first language might turn to American media and prefer plot over dialogue or something like that. I do think do we see like a preference for science fiction over comedy, for instance? Like, I do think comedy is very dialogue heavy, but that science fiction has a lot of tropes that are just, you know, commonly globally understood kinds of significations. So that's just like, I don't know, one hypothesis.
She's the media expert. So yeah, and that, or the thinking is that comedy does not translate as well globally as things like sci-fi. So we do sample some comedy, and we do Only Murders.
Only Murders is a comedy,
and some other things, but we don't know, and we don't have the tools. We'd certainly be interested in thoughts about how to do structural analysis of text to kind of like quantify complexity, that kind of things. If you're doing research in that area, let us know. We would love to work with you on a data set. But getting back to your point about demographics, we're only capturing IP addresses and time. So we don't actually have demographic data like this subscriber was 17 years old. That's not information we have. However, with advanced databases, you can pick apart IPs. And so things that I would associate with a younger demographic would be downloading video on a phone, using a mobile network to download. And we recently got access to those kind of databases from IPinfo. And we're seeing some really interesting things there. And I would say indirectly, I would say that mobile downloadings I would associate more with younger people. I can't prove that, but I would say like that's probably a pretty strong argument. So we do have those kind of separations. We've seen some really interesting things there. We have seen Spain. It depends on the mobile company in the country that you're doing, but we're seeing very large variances in wireless downloading for media texts. And one of the things that's really interesting to us is there's like a third of the mobile downloads for media in Spain are wireless. They're on a mobile device. And what's interesting is that has also jumped continents to other countries in the Spanish diaspora. So you're seeing the same thing in like Mexico and some of these other Spanish language countries. So I don't know how related that is to demographics, but that's kind of where I would go with that. Yeah, and maybe the other thing we can pick apart with IPs is if you think younger people are more concerned with privacy, are using things like hosted services and VPNs, that's also data that we can get. But age, yeah, we don't know. We don't know that for sure.
You pick.
Wow. Okay, people stop raising your hands. How about black shirt right there?
Since y'all were tracking multiple torrents across the globe, were you able to see, like, for an individual peer, like, the group of torrents that they might be seeding, and also, like, aggregate that to see, like, this kind of peer is into this stuff, and other peers are into other stuff, and, like, what would be grouped together?
We haven't done that, but could, is the answer. Back, really quick. Yeah, we're really quick with the hand all the way in the back, yeah.
Can you talk a little bit more about the evolution of where the files are, how they're coming from, the DRM, and where you're expecting that to be a challenge in the future? I'm fascinated by how days after something can be released on Netflix that it's available, whether it's...
Oh, we do, I don't know if this is answering your question, but one of the things that's really interesting, especially in HBO in the earlier years of streaming, is they would have 0-hour downloads with correct subtitles in many different languages. Don't tell me that isn't leaked officially. Like, for sure. Like, 0-hour leak with multiple language subtitles, perfect. That no torrent team can do that. Not even the best Chinese sub teams can do that. In the back.
The pirates in the audience, I'm sure we're hoping for source code, but when you speak to some...
Email me, this is GPL.
Oh, yes. If you don't mind talking about the BitTorrent protocol and where these samples in the protocol we could find to reproduce this.
I use libtorrent, which is GPL software. All this software for Alpha 60 is GPL. You could read the sources. And just, that was probably the best answer for you. Yeah. Yeah. In the front with the mask.
How do you anonymize your results?
We strip the last octet and we don't release IPs.
Yeah. What percent of pirates do you see are using VPNs? And also,
those are two great questions. The VPN data is really interesting, and I don't have it at the top of my. That's not something I have paged in right now. But I would say that there shockingly low VPN usage in Russia. This may actually be because of the network blocks. Very high, much higher than expected VPN usage in the United States, and in it's like Germany, Netherlands, France are all pretty high on that. We got 5 minutes left.
Also, just which countries do you see are like the most generous eaters? If you know that.
It depends on the media text.
We do. You could look at our GitHub, and we do track the seeders. As I showed a lot of data about downloading, but we do also have these rankings of countries and cities for the seeding as well.
I guess one of the things we were surprised to find is that everybody is kind of like thinking that the peer-to-peer network's very moochy, but we were surprised to see the percentages of seeders. We're looking at like 20-30%. So really pretty high. Right there. Yeah.
So I deal with Nielsen data, and I know that it is.
You're stuck with 5 weeks. Yeah.
Yeah, it's not good. But I'm just wondering if you've ever had the chance to compare your data to Nielsen.
Yes, we didn't have time to do that for this talk, but we did a special data analysis. We knocked down to 5 weeks. And one of the things that we find really interesting is that for film, we have Box Office Mojo. We have a little bit more established ideas of popularity, and so the pirate numbers we're seeing are very similar to box office. So we correlate very well with box office. Nielsen is often made up junk, frankly, and it was barred by all the streamers for many years. They just kind of recently got into it. I think their methodology is, well, I'm not going to say because I don't want to get into legal issues, but. Yeah, I would be suspicious of Nielsen, for sure. Yeah. Yeah. Right there.
How do you, where do you, these are two related, where do you source your torrents and how do you choose what you will be evaluating so that's representative?
Yeah, I don't know if it's representative. We use a combination of top sites and DHT trackers.
And what we sample is often based on whatever we think might be important to sample. So there's not a standardized methodology from 2018 till 2025, but like, our first target was Game of Thrones final season. So if we think in advance that anything's gonna blow up the internet, we try to sample that, but we also try to sample, we also do sample a lot of women-led, minority-led, queer-led texts because there's not a lot of data on those texts, and so we want to just like make sure they're represented in our piracy rating system. But then we also love sci-fi, so then I think we kind of oversample in the sci-fi genre because that's just like what we're watching. So I think some of it is just like, we like Wednesday, we like Only Murders, so we're gonna sample that. So if there's not really a standardized method, but I think if this project grows, we are going to have to come up with a more standardized methodology for picking. So I think that's a really good question.
One of the real questions was, hey, there's an internalized racism in the U.S. Media production industry where they think that Black-led text can't be popular outside the United States, and that's total bullshit. So we were specifically sampling to disprove that because we think that's bunk and we want to move on from that. Yeah.
Two questions. Have you looked at the data that's like immediately following, I don't know, like Netflix subscription price increase?
Yep, that's the question.
That would be interesting, and we have noticed a steady increase over the last couple of years, which is because as the streaming prices increase, but it's a little weird because there's also things like the Ukraine war, and that massively influenced kind of the behavior we're seeing.
I had a second question that was completely other direction. So you said that the data you release, you mangle IPs and it's anonymized.
Yeah, we don't ever release any IPs.
So with law enforcement, certain texts in certain places in the U.S. are not legal for children and stuff like that, and law enforcement can go from IP to who was that downloaded it. Do you Have you had historically any encounters with law enforcement, and do you consider that when you store data internally?
Well, we do strip the last octet, so we do consider it when we store internally, but we have not had the joy of dealing with that. Yeah, and we obey takedowns. So there's automated content takedown services, and we have 24 hours to take them off our server, or else we're null routed. So we're really serious about that in general. Yeah.
We have been asked that question by a person who I strongly suspected had a state affiliation in a foreign country, and that pertained to the 3D printed guns. So he didn't press the issue with me, but I think we will have to formulate some kind of response for that query of, the query was, could you just release the IP addresses just to law enforcement? That was the question, and I think that's a question that you're correct to keep on our radar.
I'm sorry, but you're actually out of time.
Okay,
Awesome.
thank you so much.
Thanks, everybody.
Try and reset the switcher, and the stream will disappear for 5 minutes or something while we reboot that, so be ready for that. Okay, so
We'll start with the part everybody knows. This is Alan Turing, of course. He's the father of modern computer science, and he was the mastermind behind the German Enigma cipher in Bletchley Park in World War II. And this is his famous machine, the bomb machine, first installed in March 1940, and it helped the team at Bletchley Park decrypt Enigma messages much faster. And his work and his team's work at Bletchley Park helped shorten the war by 2 to 4 years and saved 15 to 20 million lives, according to historians. So, let's start at the beginning. The Enigma machine was invented in 1918. It was first invented for commercial use for banks or diplomats, not as a military invention. It was first invented by the Chiffriermaschinen Acting Gesellschaft Company, which is German for the Cipher Machines Corporation. Keep in mind, I'm going to be saying a few words in languages I don't speak, so please allow my mispronunciations. This is the Enigma Model C here. It's an original photo. It's an original photo taken by that company because there are no surviving models. It is the commercial Enigma that is most similar to the Nazi Enigma 1. So let's move on. So the Enigma machines were simple circuits. They simply took a key press on the keyboard and connected the signal from that key through a circuit to a certain lamp. What made them special was their ability to scramble the lamp that the key connected to. So when one presses a key on the keyboard on the Enigma, the signal goes from the keys to the rotors, where each rotor has a carefully constructed scramble of wires in it. So the rotors are labeled 1, 2, and 3. Disregard these labels here. The rotors are labeled 1, 2, and 3 with an actual label on the outside. And so the rotor, the order of these rotors could be changed. It could be hot swapped by the operators of the Enigma as a setting used in the machine. So every rotor 1 was the same between all the different Enigma machines. Every rotor 2 was the same, and so on. So the signal would go from the keyboard to the rotors. It would go into one of the contacts on the rotors. It would go to the other side, its position scrambled. Then it would happen the same for rotor 2 and rotor 3. It would reach the reflector, which pairs the 26 letters of the alphabet into 13 pairs. That means that when a letter goes in, let's say A, it could be paired to letter Z, and it would be returned back through the rotors backwards. Then that signal would finally go to the keyboard. So now, importantly, what this does is for every setting on the Enigma machine, for example, right now it's set to 25, 23, and 7. For every setting, the keys are paired into 13 pairs. That is, if you press the letter A at a certain setting, and it output as G. If you press G at that same setting, it would output as A. That also means that a letter cannot be encrypted as itself, which, while famously was a cryptographic blunder, it was known and it was allowed because of the ease of use for the Enigma machine it allowed for, which is that on two ends, if there's operator A and operator B, if operator A sends a message with some starting settings, operator B, as long as they have those same starting settings, they can decrypt the message. They don't need to change anything. So, this is the Nazi Enigma 1, first introduced in 1930 and became widespread across the military in 1932. It is very similar to the Enigma Model C, except for this addition of a plug board at the front of the machine. The plug board is very important to the actual encryption of the Enigma and what made it so difficult to solve. The way it works is a signal will go from the keyboard, the plug board would intercept it, then the signal will go to the rotors and back through, and then the plug board would intercept it once again, and then that would go to the lamp board. On the plug board, you could pair any two letters with an actual physical plug. And so what that does, if you have X and Y paired and A and B paired, if you press the letter X, it will go into the rotors as if you had pressed Y. And then if we got an output of A from the rotors, it would go through the plug board and go to the B lamp. So this allowed for significantly more difficult encryption. So with only 3 cables on the plug board, there are 3.5 million different pairings you could do. With 5, it turns into 5 billion. With 5 cables, it's 5 billion. Now, with all these settings, there's only 4 settings each Enigma operator needs to know. They would need to know the pairings on the plug board. They would need to know the actual rotor rotations. They would need to know the order of the rotors, what order you put them in. And they would need to know what's called the ring setting. Each rotor on the Enigma had a letter ring on it. For the Army and Air Force Enigmas, it would be numbers. For the naval Enigmas, it was letters. This letter ring could be turned with respect to the internal wiring. That's called the ring setting. What that does is the ring itself isn't doing anything, but it changes the point at which a rotor can turn over the next rotor. So the rotors are normally counting in base 26, but if you change the ring setting, the next rotor could cycle when this rotor is at position 8, for example, instead of position 1. Now, to encrypt and decrypt messages, as long as both senders have those settings correct, then everything will work. And they'll both be able to encrypt and decrypt the message sent. Let's look at the first decryption attempt at Enigma. So, importantly, military Enigmas had different wirings within the actual rotors than the commercial Enigmas. So this would be something that a code breaker would need to know, is they would need to deduce the internal wirings of the reflector and of the actual rotors. So the Polish were actually the first working on Enigma, not Alan Turing. They started work in 1932. And through just looking at the actual sent ciphertexts and with their own commercial Enigma they had bought previously, they were able to deduce all the internal wirings of the rotors and the reflector, even without a military Enigma of their own. With this intelligence, they were able to create their first copy of a military Enigma machine in 1933. The first step to solving the messages had been solved. They had their own Enigma machine with the correct internal wirings. Now, they just needed the 4 settings used. Let's look at how messages were sent between 2 Nazi operators. They would randomly generate what's called a ground setting. That's the starting rotor settings. They would randomly generate the starting rotor settings. Let's say X, Y, and Z were the starting settings. Keep in mind, I'm going to be solving this as if it was a naval Enigma. That means I'm going to be using letters as if those were the settings. But they were only solving actually the Army and Air Force Enigmas. So they would actually be using numbers, but it's easier to explain with letters. So an operator would randomly generate a ground setting, let's say XYZ. They would type this twice and encrypt it using the daily ground setting in their settings book. And this turns into ABCDEF. So in their book, they had a starting setting they were supposed to use. They would randomly generate a different setting, and that's what they would use to actually encrypt the rest of their message as the starting rotor settings. To send that randomly generated string, they would type it twice and encrypt that using the daily start settings in their book. This output string of letters is called the message indicator. That would be sent as a preamble to every single message sent. Now the Polish, they could deduce this, but what's difficult is they can't decrypt it because they don't know any of the settings used. They don't know the daily start settings because they don't have a settings book from the Nazis, and so they can't really do much. But they do know a few clues. So they know that the letter X was in positions 1 and 4, or they know that some letter was in positions 1 and 4, and they encrypted that to A and D. So the same letter became A and D in rotor positions 1 and 4. That's shown here. Question mark at rotor position 1 goes to A, and the same for D at rotor position 4. But because these operations are reversible, Because the letters are paired, that means that if you put A at rotor position 1, it would become that mystery letter. And then if you put that mystery letter at rotor position 4, that would become D. So what the Enigma operator, what the Polish code breakers could do with this was they could find a ton of message indicators sent on that same day. Those would all be made with the same settings, and they knew that A would become D with this operation. A would become D. They knew that D would become G, and that G would become A. That's a cycle now. A becomes D, D becomes G, G becomes A again. So that's a cycle called ADG. If you get enough message indicators, you can create cycles that make up the entire alphabet, as shown here. And these are like fingerprints for certain rotor settings, because you can mark the lengths of all of these 11, 9, 3, 2, 1, and every single rotor position and rotor order has a different characteristic, which is what these string of numbers would be called. So the Polish created this machine called a cyclometer. It would have one set of rotors, and then it would have another set of rotors 3 steps advanced. And what you could do is you could put in any random letter at position 1, run that through, and then the output doesn't matter, and you can run that through at the second set of rotors. And whatever output you get, you can start creating a database of all of these characteristics and the rotor settings that were used to create it. There are 17,000 different rotor rotations and 6 rotor orders, meaning there's 105,000 different characteristics. And with the cyclometer, in just over a year, the Polish actually made a database of all the characteristics. And they also did that again for positions 2 and 5 and 3 and 6. So that's over 300,000 different characteristics marked. And they successfully decrypted Enigma in 1934. This worked until November 1st, 1937. They were able to decrypt Enigma messages with a little bit of effort finding out what the characteristics were. Then, on November 1st, 1937, the Germans changed the wirings of the internal reflector. So all the work had to be done again over a year. And that they did that, and it worked. But shortly after, they changed how the Nazis changed how they made the message indicator. So that was the end of that. This is Marian Rajewski. He was the person who actually first solved Enigma using this method.
Can you back up to him for a second?
So the Polish solved it again after that. The new message indicator was created as follows. There would be a randomly generated starting setting an operator would make, instead of a daily start settings that all operators have. Then, in the same way as before, they would randomly generate a ground setting and type that twice and encrypt it using that randomly generated start setting. And then that ground setting they generated would be used as the encryption for the rest of the message. So, again, the Polish operators, they knew that the first and fourth positions had the same input letter, the same for the second and fifth and third and sixth. They all had the same input at those different rotor positions. And so when they found a message indicator that had the same letter in those 2 positions as well, that would be called a female. As long as they found 3 message indicators with a female of the same letter in the first and fourth, second and fifth, and third and sixth position, here it's I. If they found 3 message indicators like that, with their new machine, the bomba kryptologiczna, or the cryptological bomb, they could decrypt those messages. So, the bomba had 6 rotor stacks on top. There would be 3 pairs, 1 and 2, 3 and 4, and 5 and 6. The first pair would be at rotor position MOK, like here, and the second position would be, the second rotor stack would be at MOK plus 3, or MON. And like that, every single rotor stack was at the correct position that created that letter. So, once it was in that position, the rotors, they would input I into all those rotors until until each pair had the same output. It didn't matter what the output was because the plug board would change it either way. But as long as they had the same output, they could deduce the ring setting and the rotor order from that. And that is because they knew what rotor position created those same two outputs, and they know that the offset should be 3 between each pairing. So if the offset wasn't 3, they could simply change the ring setting so that the offset was indeed 3. And so that gave them the rotor order and the ring setting. Now, the rotor rotation and the ring setting. Now we have two unknowns still. We have the plug board and we have the rotor order. So to solve the rotor order, you just had 6 bombies. That's the plural of bomba. You had 6 bombies, and you would just have each one at the different rotor orders. And again, this worked until the Nazis. And so using this method, they were actually able to decrypt about 75% of messages sent by Enigma. But then in December of that year, the Nazis added 2 more rotors that could be used. So there were still only 3 rotors in every Enigma machine, but you could choose which ones you could use. So that is 60 different rotor orders now. You would need 60 bombies to effectively solve all those messages. But Polish resources were already very strained by that point, preparing for what they knew was going to be an invasion soon. And that was in December of 1938. And then 1 month after that, the Nazis actually upped the number of cables from 3 to 5, from 3.5 million different plug board combinations to 5 billion. Before, when they had 3 knowns and 1 unknown, that unknown being the plug boards, through manual methods, they could solve the plug board combinations, but not anymore with 5 cables. There's too many possible to be able to manually deduce. So, with all this happening, not being able to decrypt Enigma messages anymore, on July 25th, 1939, in the Kebaki Woods near the town of Pyre, the Polish met up with the United Kingdom and French intelligence to actually hand over all their bombing machines, the cyclometers, and their replica Enigmas, and all the intel they had on Enigma to them. And that was 5 weeks before the invasion. So we move on to Alan Turing. Alan Turing was a logician and a mathematician at Cambridge before working on Enigma. He was born in 1912, and he was already very distinguished in 1936 for his concept of the Turing machine, which cemented him as the father of modern computer science. In 1939, after living in the United States, where he got his PhD at Princeton, he decided to return to Britain as tensions rose in Europe, where he was recruited to the government for the Code and Cipher Squad at Bletchley Park. One day after the UK declared war on Europe, on September 4th, 1939, he reported for duty at Bletchley Park, and he was later assigned as the leader, as the head of Hut 8, which was focusing on decrypting the naval Enigma messages, which the Polish actually never decrypted. So, in May 1937, the Kriegsmarine, or the German Navy, introduced the Enigma M3. The M3 was identical to the Enigma M1, except for the fact that it had 8 rotors to choose from, not 5, making 336 rotor orders. It also, the operations for creating the message indicator were much more sophisticated than for the Army and Air Force. So, there had been basically no work done solving the message indicators to that point, except the Polish worked a little bit on it. They knew that there was something called a bigram substitution. That was what they suspected, and that was true, actually. I'll explain what that means in a little bit. They knew there was some type of bigram substitution, but there was nothing else known. So, Turing and his team found out over a few months all of the following, from not only looking at the messages, but also looking at some of the decrypted Enigma messages from manual methods. Throughout all of this, even though there were many machines you made, even from the Polish and of course Alan Turing later, there are many machines made to decrypt Enigma, but there were always manual methods that worked a very small portion of the time. And so I'm not going to explain how those worked, but that was a point of intelligence that could have been used along the way. So through those very infrequent decrypted Enigma messages and through just examining the message indicators, Alan Turing and his team deduced all the following. The plug board and the ground setting were changed every day. The starting rotor setting and the plug board were changed every day. The rotor order and the ring setting were changed on odd numbered days. And the way that the message indicator was created was an Enigma operator would, out of a book, a settings book, they would choose two random 3-letter strings of letters. So let's say they choose ABC and FGH. The first one would be the key indicator group, and the second would be the message indicator group. The operators would offset these, as shown here, and they would fill the spaces with 2 dummy letters. Then they would split these into 4 vertical bigrams. That's just 4 vertical pairs. So let's say XF, AG, BH, and CY. Then with their settings book, they would flip to another set of pages where there were 9 different tables. These were called the bigram tables, and they had a pair for every single bigram to be substituted into. There were 9 bigram tables to be used on different days. So we can say, for example, XF turned into HO, AG to DL, BH to WY, and CY to NM. And that would become the message indicator. Then the decrypting operator would have to do all of this in reverse, and then this message indicator group, they would input that to the daily ground settings, also found in their book. They would input that into the daily ground settings, and whatever output they got, that would be the actual settings used, the rotor settings used for the rest of the message. And so Alan Turing and his team, after deducing all of this, which was all correct, after deducing all of this, they spent many months trying to solve the bigram tables, trying to piece it together bit by bit, trying to figure out what all the substitutions used. This was a very slow process. Again, they only had the decrypted messages to work with. And so that was it. But on April 26, 1940, the HMS Griffin captured a German Verpuschenboot, which is a patrol boat. Interestingly, this patrol boat was disguised as a Dutch trawler boat, which is a type of fishing boat. So they captured this disguised German patrol boat, and the patrol boat didn't have the settings books in them. Actually, those were made out of this pink material that would, when put in water, all the ink would bleed, and it was unreadable. So those were all destroyed, including all their enigmas. That was actually the main. When a boat was captured, one of the highest priorities was to destroy everything about Enigma. And so there was not much they could get out of it. But through some, like the intelligence for the message indicators could be confirmed, and through more details like that, the creating of the bigram tables was quickened by a lot. Let's move on to Ian Fleming. I'm sure you know who that is. He wrote the James Bond books, but he was also the commander of British Naval Intelligence at Bletchley Park. So he actually made a plan for how to capture these bigram tables in the settings books. And you might find some parallels between some of his books. So the plan was as follows. A group of five with one native German speaker would dress up in authentic German military uniforms with fake blood and bandages put on their suits. They were to get all into one captured German Luftwaffe plane, Air Force plane, and fly up to a flying bomber squadron as if they were there the whole time. They were going to pretend they were there. Then they were going to fake an engine failure and crash into the channel, and then they were going to send out SOS signals for a Nazi rescue boat to come save them. Once on the boat, continuing their disguise actually like injured Germans, they would then shoot all of the people on board, throw them overboard, and then drive the ship back to the UK, and they would have all the settings. And they got pretty far in that plan, actually. They ended up, doing everything up until crashing their plane, but a rescue boat never came, unfortunately. So, let's move on back to Alan Turing. So, before Alan Turing invented his famous bomb machine, his very large computer, he was working on helping the actual manual cryptographers. And he created this method called bamburisms to help out these manual code breakers. The bamburisms is a bamburism is a statistical method of reducing the number of rotor orders that would need to be manually checked. There are 336 possible, and he was working on reducing that number. To start, Enigma code breakers, or he had some information available to him to start this process. From the previous, he could solve for the message indicator group. He couldn't find the actual rotor positions used because he didn't have all the rest of the settings in the settings book, but he could deduce this message indicator group through the bigram tables. So what that means is if he found two message indicator groups that had the same two letters in them, it was likely that when they were actually put through the daily starting settings, it was pretty likely that they would have the same two letters again, the same two starting letters. So that means if you have the same two starting letters and it's just a distance of 3 apart from these two letters, well, that means that if you offset the two ciphertexts of the message, not the preamble, the actual important part with the data, you could offset them within 50 places, and you knew that they would be lined up at some point there, and when they were lined up, it was called in depth. Importantly, when you found the correct position, the number of matches between vertical letters would increase from 1 in 26 to 1 in 17. So, in our example, we know that there's an offset of 3 letters. He wouldn't know that, and his team wouldn't know that. So the bamburisms is a statistical method to actually find out at what point the two messages were in depth. In depth means that when two messages are in depth, that means that the overlapping portions of the messages had the same settings used to actually create them. So we don't know what the messages say, it's all scrambled, but we do know they had the same settings used when they were created. So I'll explain how that actually allowed us to solve the messages later, but let's first determine let's first figure out if they are in depth at first at all. So if the two messages were in the wrong place, about every 1 in 26 pairings, vertical pairings of letters, about 1 in every 26 would match because it's random, basically. In regular German, in decrypted German, regular speech, about 1 in 13 would match. But in decrypted naval Enigma messages, it was determined that about 1 in 17 would match. These numbers are just created through this formula here. The probability of 2 letters matching vertically is just the probability of 1 letter happening at all squared, plus the probability of the next letter squared, and so on. Now, actually finding out how many matches happened between two overlapping portions, that is surprisingly difficult to find how many matches there are. And so they used these paper sheets with hole punches. So in the town of Banbury, they would print these meters-long sheets of paper with a bunch of vertical alphabets on them, and a codebreaker could simply hole punch where there was a letter in the actual message. And so if you had 2 of these sheets with hole punches for different messages, you can line them up over each other over a light source, and where the light shines through, that's a match, and that's how you can count the matches easily. And so that's why the process is called bamburisms. The sheets were printed in Banbury. the sheets themselves were called Banburys, and so the process was Banburisms. I'm going to show you some math about how the actual statistical process worked. It was based on Bayes' theorem of conditional probabilities, and so when you divide this theorem by itself, you get Bayes' rule here. And so we can start solving for what, or we can start plugging in A1, A2, and B. So A1 would mean the messages are in depth, A2 would mean the messages are not in depth, and so that actually turns out A2 is the complement of A1, or the opposite. So if A2 is the opposite of A1, you can just swap out every A2 with A1 complement. So when I'm going to explain how this notation works. If you have P of A line B, that just means the probability of A given B. So this first theorem here says the probability of A given B is equal to the probability of B given A over the probability of B times the probability of A. So if we have the probability of A1 given B over the probability of A complement given B, that's the same thing of saying the odds of A given B. Keep in mind, this is not big O notation. That just says odds. So the odds of A given B is equal to the probability of B given A over the probability of the probability of B given not A times the odds of A. So that we can just plug in these what A means and what B means. And so the probability of the messages being in depth given a match is equal to the probability of a match given they're in depth over the probability of a match given they're not in depth times the odds of being in depth. That just means the probability of a match given in depth is 1 in 17. There's 1 in 17 letters will match over randomness over 1 in 26 letters will match times the odds were in depth. So if we are in depth and we have if we have a match, the probability that the two messages are in depth are multiplied by 26 over 17. We can do the same process for the probability of getting a match, the probability of being in depth given a not match. And so those get multiplied by 416 over 425. So if we return to our message, there are 9 matches and there's 25 not matches. So we just take these numbers, we do 26 over 17 to the 9th power, 416 over 425 to the 25th power, and we get this number, 26.81. That means we're 26.81 times more likely to be in depth than randomly. So we are 1 in 8 times, so 1 out of 1.8 times we are going to be in depth, or there's a 55% chance we're in depth. But that's not true, actually. No, I shouldn't say that yet. Let's look at the scoring system used, and then I'll explain why that's not true. So, back in the 1940s, it is very taxing to do these multiplications with these annoying numbers so much because you wouldn't have like a calculator to just use then. And so if we take the log of these numbers instead, we can turn these multiplications into additive scores. And so 26 over 17 is turned into 0.185 bands. That is the unit used. So 0.185 bands, which is equal to 1.85 decibands, or 3.7 half decibands. And we can do the same for the if we don't get a match. So if it was determined that if you have a score above 34, then you are more likely to be in depth than not. But our actual message has a score of 52, meaning it has 8 to 1 odds of being in depth, or 400 times more likely than in randomness. The reason that its odds are so high, even though there's only 9 matches, which doesn't line up with the addition, the reason its odds are so high is because we have 2 pairs of 2 matches in a row. And when we get 2 matches in a row, and 3 matches in a row, and 4 matches in a row, and so on, the odds, the scores that get added get way higher. And so Turing and his team used this. I'm not going to go over it because the math gets pretty hard. And I don't think I have time for that. But keep in mind it does get way more complicated from here. So once we are sufficiently satisfied the messages are in depth through this scoring system, we can look at the last two letters of the message indicator groups. That was A and E. And we see that the offset is 3. So E is equal to A minus 3. And you can find a bunch more messages that are in depth. And you can keep getting these scores, or these numbers. And eventually you can make a string out of that. So E space A space F then K. And you can just line this up against an alphabet. You can line this up against an alphabet. And as long as the same letter isn't paired to do different other letters, or a letter isn't paired to itself, you can see here first, A is paired to E and A is paired to D, so this can't be the right position along the alphabet. You can keep checking until it finally works, and there'll be multiple positions where it works. And you can keep checking. And eventually, once you get enough of these strings, such as SGL, POV, WX, and keep in mind the spaces are important, there will only be one spot where the rotor crossover doesn't happen in the middle of a string. And where that spot happens determines what rotor is there. Oh, shoot. What did I do? Oh, perfect. When the rotor crossover doesn't happen in the middle of a string, sorry, I mean to say, a rotor cannot cross over while in the middle of one of these strings. So we can filter out all the wrong rotors until we find the right one. Sorry, the rotor one crossover is between O and P, actually. So O and P is the only rotor crossover point that isn't in the middle of one of these strings. So we know that rotor 1 has to be the rotor on the rightmost side. And we can repeat this process for the rotor in the middle. It's way harder now because we have the bandbridges work much less effectively, but you can keep doing this and you can reduce the number of rotor possibilities to about 3 to 90 from 336. Unfortunately though, the 3 rotors that were added to the model M3, the rotors 6, 7, and 8, they all had the same crossover point. So the bandbridges would only tell you if it was one of those 3 rotors. It would not tell you which one it was. So now that we know the rotor order, or we know enough of them, or we have reduced the number that we have to check, we can finally move on to what Alan Turing is one of the most famous things Alan Turing is known for, his bomb machine. So, famously in the movie, you have 2 cribs that were used. A crib is just a string of letters that we know is going to be in the message, or we're very sure is going to be in a message. In the movie, they use weather report, which is written here in German, or Heil Hitler as well. And so, if you have the actual message, you can line this up against the message like this, so that 2 letters don't overlap, because again, a letter cannot encrypt as itself. So let's assume we have the right position here. You would have to have found the right position with that one. You would have to have found the right position for the bomb machine to work. But assuming we did, we now have 13 pairs of letters in rotor position 1. Of course, there were letters before, so it isn't the real rotor position 1. But for our sakes, we can say it is. For rotor position 1, J and W are paired. That's shown here on this map. T and E are paired on positions 2, 3, and are paired on position 2. And I have starred here. Every position T is paired. And so we can make a map. This is called a menu. It's a diagram of all the pairings. We can make a menu of all of the pairings as shown. The more cycles we see between 3 letters, the better, because a cycle makes it much faster for the Enigma machine to do its job, which I'll explain in a minute. So, a decryptor, if assuming they found the right position, they know some things. They know that T goes to the plug board. It goes through rotor position 2. and then it goes through the plug board again, and it outputs E. So what the actual bomb machine did was it would take a guess at the first plug board pairing. It would say T and A are connected. Then we know rotor position 2, so A would go into P. We know what it would go to because we know the rotors and the internal wirings and the setting. So A would go through the rotors at position 2. And now we know what the last pairing has to be. P and E must be paired if T and A are paired. And so we keep going on. We have 4 different pairings T has. So we assume T and A are paired. A goes through rotor position 3 to get K, and K and S must be paired. See here, rotor position 3 has T and S paired. So K and S must be a plug board position. We do this again for T and R and T and J, but at T and J, there's a contradiction. T is paired to A, and T is also paired to J. That cannot happen on Enigma. A letter can only be paired to one other letter on the plug board. So that means T and J cannot possibly be on the plug board in this rotor position we're checking right now. It cannot possibly be on the plug board. So if it can't be on the plug board, well, this is where Alan Turing's machine is genius. Every setting is reversible. You might be checking T and J later, right? So if T and J aren't on the plug board, and that's a contradiction, in the exact same way, T and A cannot be on the plug board either. And because T and A are connected to these other plug board settings, none of these can be on the plug board. They're all equally contradictory. So if we check for a letter, if we check A, B, C, and those are all of our guesses, we wouldn't check J because we've already shown that can't be possible. If we check every single one and all of them contradict, that rotor position cannot possibly work. And you might wonder, well, what if it's just not connected on the plug board? Well, the Enigma machine also checked T paired to T. If T is paired to T, that would never happen on the plug board. It would just mean there's not a plug there. So if all 26 pairs contradicted, you would step the rotor on the entire machine. If 0 pairs contradicted, you might think, well, that's 26 possible solutions. But it turns out that that actually happens quite a lot. And it usually means that we got unlucky with the rotor position and that it just paired the wrong letters to the wrong places. And so this solver was really not a solver. It was just a candidate finder. It found what was the most likely candidate to work. So if 0 pairs contradicted, we would rule that out. It's probably not right. It could be, but it probably isn't. If some pairs contradict, again, we would just step the rotor because it's probably not right, but it is more probable than before. So on later updates of the Enigma of the bomb machine, on later updates, it would actually be able to log those rotor positions. So if only one pair survives and the machine stops and that pair is a false positive, we could go back and check those possibilities. Now, like I said, if only one pair survives, just like the actual concept of the Turing machine, the bomb machine would stop right there, and that is the output. We would know all the plug board pairings, like said before. We would know the rotor positions, we know the rotor order, and we would know the ring setting. And that would be manually checked by a person. Now, for a pair to survive, that means that we would also have to check all the pairings between these other letters. So let's say for T, we have checked the letter F, and it works. The letter F works. There's no contradiction between these 4 statements here. Well, now we know the outputs. We already know what they should be. So we know the outputs. Now we check each one of these. We check E and everything it connects to. We check S and everything it connects to. And we branch out sort of like that until we've checked every single possible pairing. And when we find that only one pair survives and every single other combination doesn't, every single guess we make doesn't, that means the machine stops. And so that's the Enigma machine. That's the bomb machine. That's his very famous machine. Yes, thank you. That's it. I would like to thank the Euler Cryptography Circle for actually getting me interested in doing this, and the runner of that, Dr. Simon Rubenstein Salzito. I would like to thank Dr. James Grime for answering my emails and writing his paper on the Alan Turing and Enigma machine, which was a very useful source. Similarly, I'd like to thank Dr. Klaus Schmey for helping me with some questions, Dr. A. Ray Miller and Brian O'Reilly for contacting me and writing the cryptology mathematics of Enigma, Dr. David Riemann and MoMath for also answering some questions, and Dr. Chris Christensen and Dr. Tom Pereira for answering my emails. Are there any questions? Yes.
The Polish cryptographer, did he survive the war?
I'm not sure about that. Yes.
Great talk, fascinating material. I'm just wondering two things. First of all, there's always this cat and mouse game with the Germans, right? And so they keep changing their ciphers. They keep introducing greater and greater complexity to their machines. To what extent has it been filled in through greater archival research and things like that? The extent of German knowledge of Allies' advancement. In other words, did they just keep making it more and more complicated because they were doing that, or was it more, on their side they were getting intel, saying the Allies are cracking this one, we've got to make it more and more. That's the first question. Second question is, to what extent, because obviously since this is a character it's a character substitution cipher, right? Like
yes.
So that, in other words, you're gonna there's presumably going to be involvement of German linguists and people like that who recognize patterns of, oh, this is this word, this could be that word. To what extent were you able to find the ways in which the code breakers work with the linguists and back and forth?
Yes. So I'll answer your second question first. There were not many linguists involved. This was actually the first cryptological problem that had basically no linguistic use and all mathematical use. You can actually see in the movie, The Imitation Game, once Alan Turing, I don't think this is a real fact, I think this is drama, but in the movie, Alan Turing fires two linguists and he says they're terrible, they're bad linguists and they're terrible cryptographers. And so, yeah, linguists were not very necessary. As long as somebody could speak German and, choose a crib well, it was basically math from there on. And the first question, yes, it was a cat and mouse game, but for some of it, and there was, and some of it was just the Nazis increasing their security as they went along. For example, during the Polish efforts, I'm pretty sure that it was more of the Germans increasing their security as they went along. As we know, there were 4 years where the Polish could very quickly decrypt the messages using just their cyclometer and their database. And so there was on November 1st, they changed the wiring of the reflector. If they had known the Polish were decrypting their messages, they would have done way more, of course. And they would have changed the message indicator right from there, instead of waiting a year. So there, I'm pretty sure it was just a standard security increase. But actually, in 1942, so I forgot to say, this was all done in 1940. The UK had solved it in 1940, way earlier than you might have thought. And so in 1942, the naval operators, they knew that they had a suspicion something was up. Of course, with the intel, again, this is a drama point in the movie, they were very careful on what they acted on. And whenever they acted, they made sure there was another way they could have gotten that intelligence. They made sure there was a way that they could have gotten it without Enigma, because the Germans, they thought Enigma was unbreakable, rightfully so, and so they thought it was unbreakable. And so if they found out it wasn't, it would be very bad for the intelligence. But they had some small suspicions in 1942, and so the Naval Enigma Intelligence released the Enigma Mark IV, or the Enigma M4, which actually had a fourth rotor. It was a weird rotor. I'm not sure entirely on the mechanics, but it wouldn't rotate very much. But it was a fourth rotor added. So yes.
I'll help with the answer to that question because I met Peter Hilton, Dr. Peter Hilton later.
Wow.
In the movie, he's the guy that punches out Alan Turing, which I think he would have thought was really funny. He's been gone for a long time, but he answered that question for us. He said that they didn't know, but they thought that Rommel knew because Rommel kept lying on all of his reports. And they said, so Rommel seemed to always tell them that he's out of guns and all of that, and then the British would fight Rommel or the Americans later, and all of a sudden Rommel was fine. But he said that they didn't seem to guess it. But the other thing that he said was that the other help they had was that every time the Nazis would say, send this out on all the wires, it would go to the lesser secure sites, and so they would get a free hand from the Nazis because here's Hitler's speech sent to everybody, and now they have all the settings for everything. And they said the worst that ever happened to them was the Italians getting out of the war, because the Italian ciphers, Peter said, you'd get a beer, you could finish it before you finish the beer. Okay.
Very well. Any more questions? Yes.
How often were the code books exchanged, and like how long did this duration for the leadership and stuff?
How long did the code books last?
Yeah, just say a code book had like a code to daily codes for what duration of time?
I'm not sure. I think it was a few months, but I'm not very sure. Oh yeah, so like shown here, they were the plug board and ground settings. They were changed every day. The rotor and order and ring settings were on odd days, and you can see how dense the info is packed in here. I'm pretty sure it was a few months that each would last, and then they would change it out across the entire Navy. Any more questions? Yes.
So you talked about the British and Polish intelligence being involved in this. Were there any other countries that contributed to the research on breaking Enigma that maybe aren't noted as much?
I'm not sure. Any more questions? Yes.
You made a comment earlier in your talk about the wiring, about the theoretical basis behind the wiring in the rotors. Can you elaborate on that more? You know more about how the wiring was chosen? Or was it just, I've always assumed it was just random.
Here. I'm pretty sure the wiring was chosen at random, but across every Enigma machine, if you had a rotor labeled 1 physically on the rotor, that rotor would have the same internal wiring as every other rotor 1 across the Enigma machines.
Sure, okay. But within a rotor.
Like the actual wiring chosen?
You know it's just random?
Yes, it's just random. Yes. Oh, are you? Yeah. Okay. Okay, thank you everybody for coming.
Hello. Can everyone hear me well?
Yeah.
All right, awesome. Thank you for being here for Hacking for Social Justice. This is a bit of a strange time for a presentation because it's dinner time and I haven't eaten yet. Feeling pretty hungry, but maybe that's fitting because right now, millions of people around the world are being starved. Children are being starved by deliberate decisions, by engineered sufferings. So, we're here today to do what hackers do. We say we can challenge the system by hacking it. All right, before we dive in, I'd like for you to get to know me a little bit better because I'd like to be allies with y'all by the end of this presentation. My name is Denicia. I'm from Vietnam, and in my blood and my bones, I carry the history of the people who fought off powerful invaders with farmers' tools, fought justice and freedom. So for that reason, I believe that all oppressive systems are beatable. I came here for my philosophy degree with a focus on ethics and social justice. Then I got a master's in cybersecurity, which has allowed me to become a hacktivist and a social movement cyber defender. I work with a lot of nonprofit organizations, big ones that you've probably heard of, as well as grassroots movements to deploy organizational cybersecurity, as well as strategies for civil resistance. I teach cybersecurity online, as well as privacy and tech ethics on the CyberElixir social media page. I also have a website that stores all the educational resources that I share to the public. My personal motto is do good, and do goof. All right, do good things for the world, but don't forget to have fun as well. That's who I am. Now let's talk about hacking as a path to social justice. So why am I giving this presentation here? Technology has never been more powerful, yet unpredictable and confusing. And it's being taken advantage of by a powerful few who's using it to exploit others, concentrate wealth, silence dissent, divide communities, and maintain controls. Communities need defenders, not just from people who understand technologies, but people who understand and embody the hacker's ethos. So we have defiance, which is the refusal to accept the world as it is. Defiance is what fuels courage, the courage to question the status quo and stand up against unjust systems. Persistence, the fight for justice, is very long with a lot of obstacles and setbacks. Hackers love to keep going at it, trying different solutions at different angles, and make sure that until something breaks, right? Hopefully the problem, not us. Creativity, challenging oppression needs to come in many forms. Hackers bring in new possibilities by bringing in new data, new tools, and it needs a little bit of mischief in there as well because oppressive systems hate being laughed at or not taken seriously, right? And hackers do exactly those things. We bring fun, lightness, and joy to disruptions. This is not the break and brag culture that treats intrusion like an ego game. We employ hackers' ethos purposefully to expose harms and protect communities. So many hackers who feel pulled into this work struggle to explain the end goal because social justice is a pretty abstract term. They end up saying things like, we want to make the world a better place, or we want to protect other people. Good intentions, but no direction there. We need a clear vision to guide your actions. So let's ground it a little bit. Social justice in concrete terms can mean equal rights. You fight for people's rights to have the same protections and freedoms, regardless of their identity. Equitable distribution of opportunities and resources. You make sure that resources are fairly distributed and go where they are most needed, like those who are struggling to have them. Increasing people's capacity to live fully and freely, you remove barriers that prevent people from thriving. Reducing harms caused by systems of power, you want to dismantle structures that exploit and oppress others. So these are some starting points, but we all have more personal callings. The more specific context that you can give, like who you want to protect, what are you trying to help them, protect them from, and how are you going to do it? The easier it is for you to focus your energy. So set your mission. It will help you attract allies who share the same values as well as skills. So how is social justice achieved? How did Black Americans dismantle Jim Crow? This is Dr. Martin Luther King's I Have a Dream speech that had 250,000 people showed up. How have workers won better wages and working conditions? This is Occupy Harvard. Harvard students set up camps to fight for Harvard workers. And how do people take down authoritarians? So this guy on the left is Milosevic. He was an authoritarian of Yugoslavia, known for his brutality against his opponents. He was eventually detained for war crimes by the United States, not the United States, the United Nations International Criminal Court. Otpor, the guys on the right, or the people on the right, was the revolutionary group who played a huge role in it. So should you use your skills for nonviolent disruptions or more violent uprisings? Should you invest your time in more structured human rights organizations or get involved with more decentralized grassroots movements? Now we're asking these questions because social justice doesn't happen by accident. It's a carefully planned and engineered outcome. There are common elements for how societies have achieved greater advancements for social justice. So every oppressive system, every unjust status quo is dependent on the pillars of support. These are the institutions and groups that keep the power structure in place. It survives only because of the obedience and the cooperation of these sectors. So you can see we have the legal pillar, which includes laws, courts, policies, the police, the military, financials, corporations, banks, international trades, funders, consumers, social, the media, school, religious groups, the society themselves, political, voters, party systems, international allies. And here's the key. When enough of these pillars are weakened, the status quo collapses. So social justice movements are often won by eroding the support that these pillars provide, mostly through means of persuasion. So in many authoritarian takedowns, like the Otpor revolution that I mentioned earlier, activists would try to convince the security forces to not repress protests. They would try to win the empathy of them, so eventually they would not follow orders. Tesla takedowns, they target the financial pillars by calling for boycotts and divestments, and it worked, right? Eventually, now Elon is not in the government anymore. So as hackers, hackers can target the trust, functionality, and legitimacy of institutions that support repressive systems. So you can see, and you can tell the media pillar that you can undermine news sources by exposing why they are wrong or why they're ineffective in portraying the whole truth, right? This is usually done by investigative journalism, like what 404 Media or Wired has been doing. Many hackers collaborate with journalists also to provide new data or insights on new technology. With the financial pillar, you can amplify boycotts or make other tools that help people transition out of certain products and services. So we have Claw Back Your Data, or SID. We have the founders sitting right there. Thank you for creating this So SID helps people take their data out of X and transition into blue sky. You can also work with other like social justice companies to build better apps so people can have other alternatives, right? So now we have Signal for messaging, Proton for Drive, and Tor for browser. I look forward to seeing more alternatives like this. EFF, they target the legal pillar by discrediting surveillance tools and policies, as well as educating the public about how harmful and pervasive they are. So depending on your interests, you can focus on weakening a specific pillar. However, it is not enough to do this alone. So hackers love to operate in small, specialized groups because we like interacting with people who are like us, who speak our language, and that's totally normal. It's our comfort zone, right? But history has shown that lasting social justice change can only happen when there's a mass of people who get involved. Now, why is that? Well, the smaller you are, the easier it is to ignore you. The more people we have visibly participating, the harder it is for the system to pretend that the issue doesn't exist. Political scientist Erica Chenoweth studied over a century of uprisings, found that if a movement can mobilize 3.5% of the population to participate, it's highly likely to succeed at achieving change. Now, I'm not talking about people just like looking at like a potential change and say, hey, I like that, but not participating. I'm talking about active participants who are like out there attending rallies, trying to persuade other people, building tools for the movement, voting for the movement. So this is called the 3.5% rule. It's a magic number, but it's not a set law that we have to meet. But as you can see from the graph, the higher the number of participation, the higher the success rate. So why does this work? When the 3.5% mass of participation is reached, is usually recognized as a legitimate issue by society, which then helps attract media attention. People start talking about it. People start asking politicians questions about it. And you can even get like international solidarity. The more people the more people speak about that topic, the more people act on that topic, the more people also believe that change is possible, right? And start joining them to push for change too. They're also big enough to disrupt normal societal functions. So think of a general strike. A general strike stops businesses from functioning. Businesses are important for an economy. So when we have a general strike or boycotts, that can pressure authorities to consider change. Movements that reach this level of participation also is often also more sustainable over time. A larger base of active participation can help maintain momentum. So this means that if you want to hack for social justice, it's not effective to act or operate like lone wolves. When we do, our impacts can be limited and short-lived. You might break into a server and expose wrongdoings, but without a network to amplify it, without a network to act on it and frame it, the story fades in a few days. You can do website defacements or DDoS attacks. Many sites have backups now, so they will recover pretty fast. And people, movement people don't really know what to do about them usually. And if you build a brilliant tool, but you can't teach communities how to use it, make it accessible, or spread the word around, you can't really help many. So an example of this is Mesh Static, a decentralized mesh networking tool with a huge potential for activists, really. And not many activists know about it or know how to use it. So it's not being used by many. So for hackers, fueling mass participation doesn't have to mean marching in the streets. You can build infrastructures for mass participation, tools that make it easier for people to act, to speak, and protect each other. right? Take the eyes tracking tool. Simple, it's easy to use, and it enables neighbors to alert each other when the roads are icy and slippery, right? We can also reduce the barriers to entry by sharing cybersecurity and privacy tips. It's like giving people armors and shields when they're out there, starting a battle. When people feel that they're protected and cared for, they're more likely to join. We can help break the fear barrier as well, right? Fear is the system's greatest weapon. And there's a lot of fear about technology right now, right? A lot of people are scared about signal being compromised. VPN doesn't work. Facial recognition is super scary. They're afraid to go out and participate in protests and stuff like that. So people are scared and confused. We should combat this fear with education, with your technical expertise. So the key here is embedding yourself in communities, teaching, listening, collaborating, so that when the moment comes, your skills don't just become a clever headline. They will amplify a much greater force. So who was the first Black woman that refused to give up her seat on a bus during Jim Crow? Now a lot of you might be thinking Rosa Parks. It was actually Claudette Colvin. She refused to give up her seat 9 months before Rosa Parks did. They pretty much did the same thing, but Colvin's disobedience just evaporated into thin air. Now why did this happen? Because there was no strategy, no plan to carry Claudette Colvin's protest forward. Rosa Parks' protest was chosen as the trigger event by the NAACP. They already had a plan to escalate that protest into a full-scale Montgomery bus boycott, which, as you already know, transformed the civil rights struggle. So strategic organizing matters, and it comes from understanding the movement cycle. Learning how to build this wave. Not this wave, this wave. We start with growing public anger, or just you feeling angry about a social justice issue and you think something needs to change. And then I'll talk about these phases and how hackers can take part in them. We have trigger event, escalation, disillusionment, reflection, new normal, and mass adoption. Trigger events are traumatic moments that spark mass participation. They capture public attention, spark outrage, and create a sense of urgency for action. Sometimes they can happen by accident, but can be seized upon. So an example of this is when George Floyd's murder was captured on video, shared and amplified by multiple activist groups. Black Lives Matter actually started 7 years before George Floyd's murder, but not many heard of them because not many heard of them until this trigger event, because they started amplifying this to spark a national outrage about the issue of police brutality. However, when trigger events happen suddenly, they can be difficult to escalate, which is why movement engineers them. Because activists can't just wait for a trigger event to fall from the sky. So the key ingredients of a trigger event is dramatic. The event should be visually and emotionally striking. So from, on the left, we have the picture that is Standing Rock in 2016. Dakota Access Pipeline organizers saw water tanks and staged these protests at nighttime during freezing conditions. The images of people risking hypothermia and even their life for water security were dramatic, which motivated many news to report this and inspired a lot of people to join the cause. If they had timed this during a time that maybe it was hot outside and they sprayed water on protesters, it wouldn't have caused as much anger as doing this at nighttime when it was freezing. And every news would say things like, these water tanks really endangers these people's lives who are trying to protest peacefully. Public, the trigger events must reach a lot of people. So Occupy Harvard students engineered this by setting up camps to demand better wages for Harvard workers. The visibility of the camps, as well as banners and the occupation, drew a lot of attention and was shared very widely. It has to be documented. So we see this, why this is important during George Floyd. As hackers, we like to teach activists that privacy is very important, because privacy is important to us, but to organizers, they care more about exposing injustice and amplify them. So we should teach them about how to document safely as well. It should present a clear moral contrast. So the public must instantly see who is in the right and who is in the wrong. Nonviolent action amplifies this contrast, and we'll talk about it more later. So hackers can create or can help engineer trigger events by creating better conditions for them. So first, consider teaching people digital safety and OPSEC. When activists know how to safely document actions, report abuses, whistleblow, or how to safely reach out to a journalist, they can take more risk, and that can lead to a trigger event. Tools like Hushline demonstrate how confidential reporting channels can protect whistleblowers and participants. Also, when a movement designs trigger events like a huge protest or speech, make sure to prep them digitally ahead of time, because a lot of these aim to gather public attention on purpose, and participants get doxxed all the time. So once they're doxxed or feel unsafe, it'll be a lot harder for movements to escalate. Third, we have strategic leaks. This doesn't mean dumping all the data out at once, right? Strategic leaks are coordinated with journalists and movement leaders. The goal is to make the story public with maximum clarity and credibility. So in 1971, Daniel Ellsberg worked with the New York Times and Washington Post to leak the Pentagon Papers, which revealed the public how the US government had been lying about the Vietnam War, and discredited the US government, as well as intensified the anti-Vietnam War movement. Now I'd like to share some tips about teaching cybersecurity or digital safety to other people. First, you should use simple language. This didn't come naturally for me. I had to create like hundreds of content, gathered a lot of feedback, so I know how to teach people in a simple and approachable way. Besides avoiding technical jargons, I also try to include lots of visuals and screenshots so people know where the settings are. You can also try to make sure that your guides are searchable online so people can quickly find what they need. You don't need a whole website for this, by the way. I've seen a lot of people who used Google Docs and spreadsheets for this. You also don't need to teach everything yourself. There are lots of great resources out there. Point people to reliable and beginners-friendly guides like the EFF's Surveillance Self-Defense Guide is awesome, as well as the Activist Checklist. So by teaching digital safety this way, you empower people with knowledge in ways that they can understand and act on immediately. Escalation. So after the trigger event, a lot more people will be interested in being part of the social justice movement. We now try to grow a spark into a blaze. In the States, you see a lot more civil disobedience, more creative disruptions, more actions that put issues into the public eyes, street protests, coordinated boycotts, banner drop sit-ins, all aimed at making the issue like unavoidable, impossible to ignore. So this is where hackers can be force multipliers. We can deliver new data, insights, and technical tools that deepen the public's understanding of the problem. You can also help organizers build tools like what to do next, where to boycott, where actions will take place, share records, open source apps, and any like toolkits. The public would also be interested in seeing if these movements actually win or actually change anything. So building some sort of lightweight evidence hub with what's going on and timeline of wins can keep the narrative alive and show progress. Opponents will also be moving just as fast, right? They push misinformation campaigns out there, fake stories, character attacks to discredit the movement. We can target misinformation sources and discredit them back. So the goal of escalation is to get active participants and weaken the pillars of support. Now, during escalation, there'll be lots of emotions, right? Sides will be throwing attacks verbally, physically, hackery at each other. It's important that we stick to nonviolent tactics. Now, I'm saying this not because I feel like nonviolent tactics are morally superior or I'm afraid of physical confrontations, right? Have you seen my muscles? But because they've been proven to be effective. Through decades of research, they show that nonviolent movements are twice as likely to succeed as violent ones. How? It builds public empathy instead of fear, right? When people see peaceful actors facing excessive force by the government, the moral balance shifts towards the activists. But if the protest ends with like burning houses, burning cars, innocent people getting hurt by activists, then the thought would change from these people deserve better into these people are dangerous and I want them to stop. So nonviolent disruptions also make it easier for new people to participate in. And again, our goal is mass participation because they feel safer there. Violent disruptions tend to turn people away. Nonviolence also denies our opponents of pretexts they're looking for. So governments, corporations, hostile groups want an excuse to label activists in a negative light so they can use much more excessive force. So again, violent tactics can undermine the movement and prevent it from escalating. This is why governments like to plant agitators inside protests. So when cars and buildings explode and innocent people get hurt, a movement is more likely to be denounced by the public. So doxing, swatting, and encouraging violence can endanger not only the target, but also unrelated people like their family or their kids. This website that doxed Tesla owners, they published the home addresses of people who already sold their Tesla. So the public just finds doxing very off-putting. Some of these other tactics like sabotaging critical systems by taking down essential infrastructures and leaking data without care can upset the public more than motivating them as well. So WikiLeaks exposed so many outrageous government and corporate misconducts, but it also exposed a lot of sensitive personal information by innocent people. So they couldn't gather much support from the public. The goal here, though, is not to avoid upsetting people because disruptions will upset people. But while they're upset, the majority should feel empathetic towards the activist goals instead of fear or anger. Now, after a movement hits its peak of activity, there'll be a drop-off in energy. This is called disillusionment, and it is normal. It happens when people realize that change is not immediate, the law hasn't passed, policy hasn't changed, and the injustice hasn't disappeared. The president is still presidencing, people feel burned out. So when you reach this stage, remind yourself that change takes a long time. You should take breaks, slow things down, do something fun for yourself, get a health checkup, get a mental health checkup. Like seriously, I've seen so many hacktivists and activists feel burned out and just stop altogether. This is why we use this period as a reflection as well. You know, we ask ourselves what worked, what failed, did our tactics reach the right people, gather feedback from the community, talk to other people, learn how to pace yourself better, and keep going. Now, Every successful social movement dreams of this stage. When the once radical demand becomes so accepted, so embedded in daily life that it stops feeling like activism at all. So this is called the new normal. At one time, ideas like same-sex marriage and women working in offices were considered impossible or even absurd. Now they're everyday norm. However, opponents will keep trying to undermine progress. So, to maintain social justice progress, mass movements alone are not enough because they tend to phase out very fast since they lack centralized system, they lack funding, and they depend on volunteers. In this stage, the hacker's roles shift from pushing for change to protecting it. Black Lives Matter, the Me Too movement, we don't hear much about them anymore, right? Not because those issues don't exist anymore. Racism, sexual violence, gender violence, they're still with us. But because society's attention shifts, and that's normal, the news cycles move on. People get pulled up into the next urgent thing. And this is why movements need to transition into structure. So grassroots uprisings, they thrive on speed and acquiring momentum, but once it's acquired as objective and lose funding or volunteers, they phase out really fast. Whereas structured organizations, the strength is they're more stable and durable in the long term. Over time, they also acquired political leverage. They have established fundraising channels and legal teams for sustained campaigns. They can also create leadership pipelines to train and mentor new organizers. The weakness is they can be slow to act as they care more about long-term stability and protecting their leaders. So if you are to help a structured an organization, you might be disappointed at how slow they can be or like how unreactive they are to things that are going on. A perfect example of this too is end-to-end encryption. At one point, it was mostly advocated for by activists, hackers, security geeks. Then we have more organized structures now, like the EFF and ACLU, which try to raise public awareness about it and trying to embed end-to-end encryption into more day-to-day apps. However, governments, as you already know, are still trying to weaken it with backdoors. So hackers and these structures have to keep defending it to maintain the new normal. This is why lasting social justice requires both grassroots and structured organizations. If you're interested in supporting organized structures, here are what you can do. You can work for these organizations. If there's any that you're interested in, sign up for their job letters or introduce yourself to them and bring your skills into their infrastructures. You can be the one who spot the vulnerabilities or design more secure systems or handle organizational cybersecurity like I do. Protects their data, protects their people. They're under lots of attacks and pressure. They usually lack funding as well, so any volunteering would really help them. But they're willing to pay. If you're good at teaching, you can train their staff on digital safety. You can share threat intel with advice with them. If you're handling cybersecurity for a nonprofit, there's this organization called NGO ISAC, which stands for NGO Threat Intelligence Sharing Center, to exchange threat and best cybersecurity practices with others. You can volunteer. Not everyone can work full-time as an activist, but even just 1 hour per week can make a difference to them. You can amplify their work. So if you think of what they do is cool or is useful, you should spread the word to others, like use your social media or bring it into conference talks like how I did and talked about like SIT, 404 Media, Wired, and other cool tools. And finally, donate, because we all need money to keep going. So we've covered a lot of theories, history, and examples. So if you're lost in the sauce, don't worry. I made an action item checklist for you. To summarize the main points. So number one, define your purpose. Ask yourself, what injustice am I trying to address? And how you want to address it. Number two, engage with communities. This is so important. Just introduce yourself to movements. Let them know what you do. Listen before building tools for them, right? Learn their needs, learn their fears, learn their vision. A tool that fits their reality will go further than a tool that you think they might need. Create tools to engage mass participation. As you already know by now, mass participation is the key for social change and social justice. So make sure it's accessible and widely known to others. I know a lot of my friends who create brilliant tools who are sitting in this room, but are kind of shy about like telling others about their tool. So please don't be shy, or contact influencers or content creators like I do to spread the word about them. I think they're really awesome. Protect movements from harm proactively. So if a social movement catches your attention, just reach out to them and offer help. Don't wait until they get doxxed or something. I know from my experience that a lot of these social movement people would get harassed and threatened, and they would just drop after the trigger event and just refuse to do anything else afterwards. When their family complains about it, when their neighbors complain about it. Teach and empower, spread your power to other people. We're stronger when we're more powerful all together. And then celebrate victories, do good and do goof. If you just start out, pace yourself. When I started this work, I started just doing 1 hour per week of social justice, and just realize that this is a marathon. So you need to train your stamina, build it up from there. People who don't run strategically get burnt out really fast. Again, remember, do good, but also do goof. Keep your humor, your joy, and most of all, your hope. The world needs hackers who care. The world needs hackers who take actions. And the world needs hackers who see social justice as a future to be built. The world needs you. Hack the planet. I think there might be time for questions, or I don't know. Go on.
How did you get started?
Oh, started in what?
Well, like, how can we follow your footsteps?
Right. So when I was doing my master's in cybersecurity, I realized that a lot of my program was focusing on protecting businesses, their data and their systems. And I was like, this is not what I want to do. I want to protect people. I want to protect human rights. I want to protect activists. And so I went online and I searched just cybersecurity for human rights. And Matt Mitchell was everywhere. He became my inspiration. And so I just reached out to him and learned about his methods of being more involved in the space. I was introduced to Hope, and I have been I've been loving this community because I feel like hackers align with my values and my ethos more than cybersecurity professionals. I like how unserious you guys are at times. Yeah, and how cool you dress too. So yeah, it's been awesome. So I started doing a lot of work with Matt and got introduced to NGOs and started just like interacting with them as people, like understanding their issues and just telling them that, hey, I have this skill, and if you need help, like, I'm here for you. So I encourage you all to do the same thing. Like, it might be a little intimidating, or like you might feel weird. Just reach out to these people. But they're like pretty friendly and they need help. So they would appreciate it a lot if you just reach out to them and offer them your skills. Yes.
Hi.
first off, I want to thank you for encouraging folks who are involved in this space to get involved in social justice movements and especially get out there in the streets and involved in the community and stuff like that. If I may offer just a brief friendly critique on one thing. And I was curious if you've ever heard of the term diversity of tactics, right? Now, I'll just explain briefly. Now, at some of these major protests like Republican Convention or the G20 or like the RNC, so forth, right, that the coalitions of organizations that are out there protesting, you know there's no one way to do things, right? And so they adopted this thing called, in some places, the St. Paul Principles, which basically says we embrace a diversity of tactics, that there's no one way to do that. We won't publicly condemn other organizations, but we will maintain a separation of time and space so people can freely participate to their comfort levels, right? Now, you spoke quite a bit about your perspective on why we need to remain nonviolent, right? And some examples you elaborated was a burning cop car, right? And I just want to say, like, you know, if you don't dig it, don't do it, right? But to be fair, though, for the millions of people in this country especially who languish in the gulags of America, right, the prison system, or who have experienced racist police brutality, right? To tell someone to be patient or don't be violent because then you will be as bad as them, like, honestly, like for example, like the burning cop cars in the streets of LA, like, was a beautiful and important and necessary thing that, like, inspired others to spill out of the streets. Or the burning precinct during the George Floyd uprising, right? That had to happen. That had to happen, right? And so I just want, if you could speak to, like, how we could, like, for example, criminality, like, hackers are often condemned as being criminal or going too extreme and stuff like that. And it's actually kind of, like, shameful how, like, you have sometimes so-called peace patrol people will throw people to the police. And so I just wondered if, like, if you had any opinions on that concept of diversity of tactics. You play the right card for the right situation. Sometimes shit needs to burn. But I agree, it's not always about that flash in the pan either. It's all a lot like what you said, the infrastructure support for the movement and getting the masses in the street. But I just wanted you to offer that little critique.
Yeah, honestly, oh, sorry. Yeah, honestly, I love seeing violence. I base my presentation on research, right? But sometimes it's, like, satisfying to see things like that, and I agree with you. But it also led to, you know, like, I talked to a diverse range of people as well, not just activists, but also, like, people from the other side, see how they see things. And, you know, like, when people get afraid or feel angry, they feel like extra force is justified. And when it comes to violence and using force, it's really difficult for us to meet the forces of, you know, like, these government people, the military. They have tanks, they have weapons, they have all these armors, and protesters, you know, like, they're risking their lives. And it makes it harder for older people or children or people with disability to, you know, show up the next times as well. So it's, like, pros and cons. I also am aware that the LA protests were mostly peaceful. There were just, like, a few that kind of exploded. And I do think that some violence is also good because it makes other tactics look more moderate, and they're more willing to negotiate if they think that you're more moderate than that, like those violent tactics. Yes, I think I have some time left. Yeah.
You say offer skills. In your experience, when you reach out to NGOs and other organizations, what are some skill sets that they are most often seeking? Do they need web app testing? Like, what do they often tell you that they need?
Honestly, like, a lot of them are lacking basic digital safety. Like, a lot of them are not aware of Signal. They don't understand how VPN works. They're still using text messages to, you know, like, send messages around and share, like, confidential information. So just, like, the basics. They don't have money to spend on, like, cybersecurity professionals. So I'm usually, like, out there, like, just offering them help. And they also get, like, harassed and threatened as well. So just, like, knowing someone, like a cybersecurity professional or a hacker who can be there for them to reach out when they need something, that mean a lot for them.
I have a bit of a comment that I'm my background is 15 years working in nonprofits, and now as I try to transition into tech, I think I often bring a lot of perspective from my time in nonprofits who are social justice oriented, and I love that there is so much emphasis I'm seeing today and yesterday on bringing tech folks into volunteering within nonprofits and within community organizations, and I don't want to disrespect at all the power that can come out of that. I've seen what communities can do. I've seen what communities can do with more technical help. And at the same time, I would love to see another paradigm that is not just volunteering brought forward or brainstormed or talked about, because as long, and I've seen this firsthand over and over and over again, as long as you are reliant on volunteers, you are limited. Your capacity is limited, your sustainability is limited, and ultimately, like, projects die, and there's a lot of things that come up. So it's just a plea to the folks in the room and to you to also maybe think about what could we do beyond volunteering to maybe perhaps pay people for their labor and make sustainable opportunities for folks within social justice organizations.
Yes, I totally agree with you. So my cybersecurity job as the CEO of CyberElixir, I'm actually getting paid to do cybersecurity work. And when I meet these NGOs, I told them that I would need to be paid so I can keep doing this work. And I told them like the price and also like how they can reach out for funding, cybersecurity funding. There's a lot of that out there. A lot of the time they just don't know like how much it costs, or they expect people to volunteer. So it's important that when you reach out to NGOs like that, you tell them ahead of time, like, I'd like to be paid for this work, I'm a professional, and here's how you can get more funding. I think we're out of time, so I can get more questions.
Okay. Hi everybody, how we doing? Good? I know it's late. Thanks for sticking around, I appreciate it. My name is Cora. I'm gonna fix this. My name is Cora. I am a second year electrical engineering PhD student at the City College of New York. I'm advised by Tashar Joyce and Rosario Gennaro. I would say that my research interests are in developing security and privacy solutions for thank you, for people, for at-risk populations, and vulnerable populations, so whether that be children or the elderly. And today I'm going to be talking about my ongoing research that has to do with mobility, movement, and communication. Yeah. So for the purposes of this talk, we can define an internet shutdown as the deliberate interruption of internet services that causes a partial or complete loss of connectivity on a network. And just to give you an idea of what this looks like on a global scale, these are a couple headlines just from 2024 alone of instances that have happened. And I'll give you guys a second to take a look. And what I think is important to notice here is that these are not one-off instances of internet shutdowns that are happening. These are repetitive, they're targeted, and they are malicious. So there's something that we need to keep an eye on and watch as things continue to develop. And unfortunately, 2024 was the worst documented year for internet shutdowns to ever be recorded. There were 296 instances of internet shutdowns across 54 different countries. To help illustrate what that looks like, I took the Access Now dataset and made a fun little colorful map. So all of the countries that are highlighted in red, those are the countries that experienced an internet shutdown in 2024. But what is important to notice are the countries that are highlighted in purple, because they are 7 of the 54 that experienced an internet shutdown. They imposed it for the first time within the calendar year, which is something to watch. So as you saw on the graph previously, we're not seeing anything start to decline. They're still climbing rapidly, which is underscoring the importance of why we need to talk about internet shutdowns on a global scale. So let's talk a little bit about how they happen. There are a number of trigger events. These are catalyst happenings that posture a nation for an internet shutdown. In 2024, the most common ones that were recorded were instances of social and political unrest, elections, exams, and government coups. And research supports this. There was a research document put out by Georgia Tech that found that internet shutdowns are 9 times more likely to co-occur with protests, 16 times more likely to co-occur with elections, and 286 times more likely to co-occur with government coups. So we see the correlation here. And now that we have an idea of what causes them and how they get rolling, we can look at what the workflow generally looks like. So typically you have your government authority, and this can be national, regional, militant, whatever it might be, and they can issue a set of directives. You often see it done legally or extra legally. So when I say legally, you often see this rooted in legislation. There's some sort of text that vests power into the authority themselves to be able to issue an internet shutdown, and they can really do it for a variety of reasons. It can be in national interest, it could be for public safety, and you'll notice that the language there is very vague. That leaves a lot of space for these sorts of things to happen. And extra legal methods, there are a number of them. They're often just cases of force. There have been recorded instances of subsea fiber optic cables being intentionally cut, or power being shut off in certain areas where network infrastructure exists to restrict the use of the internet. And that's a way to sort of get around it looking intentional, because it looks sort of like a technical accident. And more often than not, the ISP or telecoms are either partially owned or completely owned by the government, which makes it very easy. It's very much of a tap on the shoulder to be able to get internet shutdowns rolling. And that is a big problem, because the ability to share information, organize, and communicate is vital during times of political and social unrest. And this is exactly why the internet is targeted by governments in these instances. To give a couple examples, shutting down the internet is a great way to control elections because you can restrict the flow of information, make it very difficult for a citizen to cast an informed vote by returning the information that they're able to access is only what they want you to see. If there are some sorts of human rights violations going on, and they're often very grave, shutting off the internet is a way to prevent people from sharing that's happening to the greater world and holding countries accountable. And it also prevents people from being able to protest. If the internet is shut down, it's very difficult to organize, come together, plan where we're going to meet and how, which puts up all of these barriers, which creates a really large problem. And losing internet access is a major hindrance and safety risk for protesters who are actively resisting oppressive regimes. So for those affected, if someone was injured while they were protesting, it is now impossible to make a cell phone call to get EMS services. It's also very hard to keep in contact with protest organizers. There's no way to send a message and figure out where people are rallying together. And it also is very hard to contact your loved ones, whether that's your family or people that you're actively protesting with, to be able to know if people are safe and figure out where everybody is. So we have this large issue of internet shutdowns, particularly in the protest setting. So how can we communicate during internet shutdowns when this is happening? So we'll enter ad hoc mesh messaging. There's been a lot of talk of mesh at Hope this year, so I'm sure we're all familiar. But to review at a very high level, what mesh is a decentralized peer-to-peer communication scheme that uses short-range links, so that can be Bluetooth Low Energy or Wi-Fi Direct, to allow peer-to-peer communication between devices. We know that mesh is proximity dependent, so that means that the range of Wi-Fi Direct or Bluetooth directly impacts who you're able to connect with. And for people that are outside of that one-hop range, there's multi-hop, which allows messages to travel further and further, even if they're outside of that like physical range of whatever link that you're using. And mesh is particularly good to use in a protest scenario for a couple different reasons. Like I mentioned earlier, mesh is decentralized, and to understand why that matters, we can compare it with a centralized structure. In a centralized network, all functionality is funneled through one single point. So in this little diagram, that would be the cell tower. Every message has to go from the person to the cell tower to the receiver, which creates this critical point of failure. And we know that these critical points of failure are targeted by governments, which is why it is such a big problem when it comes to communicating in these spaces. Decentralized completely skips the cell tower, and it can just go from peer to peer, which is why we want to use technology like this. It removes the bottleneck and can still function during internet shutdowns. And mesh also benefits from the network effect. The network effect being the more people that you have involved in your network, the better it's able to operate. So when there's just a couple people that are on a mesh network, your range is limited and it's spotty as people continue to move around. But as you have more and more people, the range gets further, the connection gets stronger, and it overall is a good thing. So you can think about this sort of like a bucket brigade. So you can have one person that has a pail of water. It's getting passed down a line of people, and the pail will go from person to person to person until it arrives at wherever it's trying to go. And the more people that you have in your bucket brigade, the further and faster it's able to travel. That is how I remember it, at least. So this is good. We know that mesh works well in this context, but how is it performing in real life? I would call it complicated. So we can take a look at FireChat first. I'm sure some people in the room are familiar with FireChat. It was extremely popular during a number of mass protests that happened worldwide. Particularly, we point at the Umbrella protests in Hong Kong in 2014 and the ELAB protests in 2019. They saw a massive spike of installations during the instances of these two protests. It was more than they were able to keep up with. And it was, as the article says here, adored by protesters. But there were a lot of issues that made it an unsafe choice for protesters to use. And just 4 years later, it was removed from the internet and it's not supported any longer. So it was plagued with operational and security problems. This is a quote that was from the University of Toronto Citizen Lab. They ran a security analysis on FireChat. They say that all messages sent and received, as well as the list of chat channels the user has joined, are stored unencrypted on the device, which is a real problem when you're trying to protest in places where the government is malicious towards you. It also collected users' real names and their real email addresses while they were registering, and this was all stored locally on the device. And it got to be such a problem that FireChat actually eventually made a statement to the press. And they said, quote, "People need to understand that this is not a tool to communicate anything that would put them in a harmful situation if it were to be discovered by someone who's hostile. It was not meant for secure or private communications." So I think that quote sort of explains itself there. Let's take a look at another tool. This is Bridgify. Bridgify still exists now. It's still available to download. It's probably one of the most well-recognized mesh apps, I would say, and it saw a lot of use during the eLab protests in Hong Kong. Again, similarly to before, it saw a massive spike of downloads. There were millions of open chats going on at the time, and today it boasts around 11 million downloads between Apple and Google download stores, which is something to keep in mind. Despite all of this, it has a lot of functionality problems, quite lackluster if you were to ask me. So these are screenshots I took a couple days ago, what it was looking like. Not great. And these are 2 reviews that I pulled from the Google Play Store. We can keep in mind that they're reviews, so take it with a grain of salt. But if you look at the number of reviews that they have that are negative, I think there's probably something to them. So the review on the top essentially describes that a user was trying to set up Bridgify to use to text with their mom if there was a protest or something going on and they were to get separated. And they put the phone essentially in perfect conditions right next to each other, enabled the connection, and they weren't able to find anything. And this is just like sitting at the dining room table. And the user below actually tried to use it during an actual instance of a protest, and they were unable to get it to work at all. So doesn't bode well for the application. And unfortunately, there is more. In 2021, there was a team of researchers that put out this paper, Mesh Messaging and Large-Scale Protests Breaking Bridgify. And they were questioning whether or not Bridgify was a good tool to use in the protest setting because they saw issues in the way that it was conceived, because it was not designed to be used that way. And the researchers essentially said that Bridgify currently permits its users to be tracked, offers no authenticity, no effective confidentiality protections, and it lacks resilience against maliciously crafted messages. So they put out this report, and it was pretty ground-shaking for the people that were currently using the application. The researchers found that you could produce entire social graphs to show who I message on a daily basis, like who I'm connected to, and so on and so forth. You could read their messages entirely, you can impersonate anyone, and even cause shutdowns of the Bridgify network with a single maliciously crafted message. So Bridgify acknowledges this, and they say, okay, thank you for letting us know. We're going to implement the Signal protocol to try and alleviate these issues. So that's what they said that they did. And then shortly after, they said that the issue was patched. They went on to continue to push the application out for people that were experiencing internet shutdowns. This is in 2022 during the Russian invasion of Ukraine. And it's not, I wouldn't say it's like a super bold advertisement, but if you look at the language, it's definitely suggesting that it's there to use if you follow certain steps. And these were both pulled from the Bridgify Twitter. The picture on the bottom is something that they posted just showing the sheer amount of downloads that they were getting while this was happening. So, who thinks that everything was okay? Baby. Ugh. So, another paper came out, and it is called Breaking Bridgify. Again, it was the same exact team of researchers, and they found that the Signal protocol was implemented completely incorrectly when it came to this, and there were still some glaring security issues. It was essentially a vicious man-in-the-middle attack. This is a screenshot. The researchers actually posted a video. You can find it on Twitter if you want to watch it. It's about 1 minute and 30 seconds long in real time, so it's pretty horrific to watch how insanely dangerous this is. But essentially, you have your two users, Alice and Bob. They're communicating using Bridgify, and there is a malicious third party involved. And by the end, executing the code that they had written, they were able, the third party was able to read the encrypted messages entirely. And that was a major problem. Yikes. So where Bridgify stands today, I don't see, as I reviewed the research, I don't see a lot of consensus. I see the work sort of drop off around like 2022, 2023. I would still be very hesitant to use the application if you were looking for some sort of mesh tool to be communicating with. And there's a lot of reasons to be cautious because the consequences are grave. The New York Times recently put out this article. I don't know if y'all saw it, but essentially they interviewed people that actively protest during the Hong Kong ELAB protests. And they were interviewing people that had been imprisoned for taking part in the protest. And they found that outside of like the mental and physical damage that they received, it's the societal damage that's really it's hard to get your head around. There was one activist who told her story and said that she was arrested and imprisoned for participating in a largely peaceful demonstration. And she was stripped of her social work license, and she's still unable to get her license back to this day and can't find work. So it underscores why it's so important for us to trust the tools that we are using when the stakes are so very high. I definitely recommend reading the article because there's more instances that they talk about in it. But we have to ask ourselves a question. What do FireChat and Bridgify have in common besides the obvious of the security problems and the not working super well? Anybody? Yes, but no for this one. Sorry? I am going to point to something different, is that both Bridgify and FireChat were used as protest tools, but they were not designed to be protest tools. And you might ask yourself, okay, if they weren't designed for this, what was their intended use case and how did it end up here? Surprisingly enough, it was music festivals. It was intended to be used in places like Electric Forest and Burning Man, or very crowded areas with mass crowds, like a very packed stadium where a network could be overloaded. And even some instances of people trying to use them on planes when you're out of the reach of a cellular tower. So you might say, okay, that's still a crowd. Why is it different? Crowds are not all the same, and they're actually pretty different from each other. Although it's technically groups of people, they move differently, they behave differently. And that's something that we have to take in mind when we're developing mesh tools. This brings us to this major disconnect that we have in the research community, is that we have mesh tools that are being deployed into venues that they're not built for or tested against. So we could talk a little bit more about what that looks like. I would say that this is very largely from the academic space, but mesh tools are often evaluated using simulation. NS3 is usually the one that people point to do this. And essentially how it works is you give NS3 a mobility model. A mobility model tells you how the nodes in your network that you're testing are supposed to move. And this can be directional, this can be velocity, the time that it takes to make those sorts of decisions. It's simulated upon, and then you get an outcome to tell us, okay, this is how well this mesh scheme worked. And the problem with that is because we don't have a good understanding of how people physically move. And this is important in the mesh context because in a mesh network, as people move around and change their position, you're constantly restructuring the way that the network works. It's like if you picked up your routers and just started playing musical chairs with them. It becomes very complicated. So when we don't have an understanding of it and we substitute it for something that's random, you're going to end up with this harmful cycle where we're developing tools perhaps they're okay for protest scenarios and then they're deployed and they don't work well. And we need to find a way to accurately evaluate and build tools that have the protesters in mind from beginning to end. So we can talk about how the simulation works. I know I went through that fast at a higher level. So you have your own mobility model. This is how the nodes are supposed to move around. This is like their speed, this is where they're angled, this is how they make decisions. And then you have your traffic model. So that is how frequently are the nodes that are in your simulation sending messages, how large are the messages, that also gets fed in. And then you have your mesh protocol, whatever it might be that you're testing, all gets fed into your simulator, and then it spits out some performance metrics and lets you know how the scheme did. So let's think about that for a second. Let's say you were taught to drive in an empty parking lot, no cars, and you got your license for driving around in this empty parking lot. And then one day you're told to go drive in Midtown and you get in a car accident. Are you a bad driver? Or were you evaluated and taught how to drive in a place that's not conducive to the rest of the environments that you would drive? And I would say that this is the core of the issue here, is that we're evaluating our mesh tools on mobility models that don't match where they're meant to be deployed at all. And you're seeing this massive disconnect in the applications that are being created. Let's take a look at what this type of mobility model looks like. This is I'd say like the de facto model that is reached for all the time in academia. It's called the random waypoint model. You're often going to see the base version of this, or it's going to be some sort of derivative that might have a couple other options to determine the way that the nodes move, but generally at a high level, it works like this. So you have your 2D grid space, and that's where these simulations take place in a blank grid, which is already an issue, but we'll talk about that later. And you have your node that will start in an original position. And it will be in this space, and then it will take a moment to think and decide where it wants to move. Once it's decided a target location, it's going to decide how fast it wants to get there, and then it's going to execute that movement. And then once it arrives in the next block, it's just going to repeat that over and over and over again. And that is it. That, at a very high level, is how the random waypoint model works. And you end up with something that looks a little bit like this. You have a very like zigzagged jumping around motion. And I think just looking at it like this, we know that this isn't how people move in real life. It's making a lot of assumptions here. It's assuming that people move randomly at all, which is something that we'll discuss. But it also assumes that we have this machine-like consistency when we move around. So for the entire day, if I decided to move from place to place to place, I said that I was gonna move at X miles per hour. I would have to do that every single time. We know that's not how people move. Say you're carrying something, say you're walking in a difficult terrain, your speed is going to change, and that's something that needs to be reflected. And going back to this 2D grid situation, the world doesn't look like a 2D grid. There's obstacles in our way, there's buildings, there's pieces of architectural influence that we have to take in mind when we're trying to simulate, particularly when we're trying to simulate a protest that might be taking place in an urban setting where you have big buildings and streets and cars that are around. And finally, it assumes that we move with no memory. So in the random waypoint model, it doesn't matter where the node has been. It doesn't take that into account when it comes to deciding where it's going to go. And we know that that's not how we move in real life. Human movement cannot be represented by any form of randomness at all because it has so many different outside influences. We're going to talk about a few of them, but I would point to crowd science, relationships, and architectural features as being some of the major points for this. So let's talk about crowd science. This is something that I think we need to talk about more when it comes to mesh because I think it brings a lot of the solutions that we're looking for and starts to point us in the right direction when it comes to developing models that work really well. But crowd science is a field of study that seeks to understand and manage the behavior of large human groups. And what you see from a lot of the literature is that large groups have patterns in the way that they move, and it's heavily influenced by certain factors. This is an article that was published 2022. It's very interesting, especially for our context when it comes to like mass dense crowds. Essentially what the researchers found was that the way that one person moves in a dense crowd is directly impacted by their optical neighbors. And what they're saying is that if I'm walking in a big crowd of people, whoever is standing directly in front of me, they're going to drive the way that I move. And they found that people will match speed and direction. And this is a completely unconscious thing that people do, but it happens when you're in these very large crowds, which is something that we have to keep in mind, because go back and take a moment to think about that random waypoint model. They're bouncing around with no direction at all. If you're trying to simulate that as a crowd on a large scale, you're going directly against what crowd science has found to be true. It tells us some more pretty interesting things that we should take in mind when we're developing these mobility models. It defines that there's two different types of crowds, and they actually have different movement signatures, and they behave very differently from each other. So on the left, we have a physical crowd, and a physical crowd can just be defined as a mass of people that are co-occupying a space, but they're all there for their own independent reason. So this woman might be headed home from work, and this guy might be going to a doctor's appointment, but they're both in the same space, and that forms the crowd. But there is also a psychological crowd that exists, and this is when you have a large mass of people co-occupying a space, but they share a sense of self, and they've gathered for a shared reason. And researchers have found that when you have a psychological crowd, they actually tend to move slower and much closer together as they travel as a big group. And there is increased social interaction that happens between the different people that are in the crowd. And that's something to keep in mind again, because go back to the mobility models, we don't have a way to represent that when it comes to people having relationships, moving closer together, and being influenced by the nodes around them. This is a clip pulled from a newsreel of a civil protest that happened in Myanmar. And I want to point out a couple things. I'll give you guys a minute just to look at it as it is. It's been blurred just for privacy reasons to protect those who were involved. It's a little blurry up here, but I'll give you guys a second just to watch and kind of notice some patterns. Does anyone want to point something out that they notice about it that might go against this random waypoint model that we've been talking about?
They're all going in a straight line?
Yeah, there's this like channeling pattern that we see. Anybody else?
It seems like the physical crowd and the psychological crowd are meshing together.
Yeah, you see like this, there's different behaviors, although it's like one large group of people. People are motivated by different things, although they're in the same space. One more person, something that you notice about this that might go against what we talked about?
People that go in the same direction are closer to each other.
Yeah, people that are going in the same direction are closer to each other. So please forgive me for my drawings. I couldn't find my mouse, but here's what we have. I've kind of highlighted for you what the different patterns look like. And when we talked about architectural features having an influence on the way that people move, you can see that really clearly here. If you take a look along the sides of the buildings, I would look specifically here under the awnings and sort of around the sides of the buildings. You see like a high density of people, even though there's definitely a lot of free space for people to move around and give themselves more room. According to crowd science, we actually, as people, when we're in big crowds, we don't like to diffuse ourselves. We like to stay close together, and we don't make use of the space the way that you would think that we do. And these channels of people that you see traveling, you said it perfectly, they want to stay very close together, and we can point that back to the psychological reasons that we've highlighted earlier. And something else is that we have these, this is a still now, but we have groups of people that travel together. These bonded nodes, I guess you could call them, people that might have arrived to the protest together. Maybe that's your significant other, it's someone you work with, it's a sibling. You're not going to tolerate a lot of distance being put between you and that other person. And you see people traveling together in pairs. You see this much more often than you see someone wandering around on their own. So let's put these back next to each other again. And after we've talked about it, the differences are startling. We're trying to develop tools to be deployed in this environment using this understanding of how people move and behave. And this, I would argue, is why you're seeing a lot of failure when it comes to mesh tools specifically being built in the protest context, because we're trying to design them on a mobility model that does not accurately represent how people move at all. So we know a few things now, that human crowds have traceable mobility patterns, and that the media, whether that's videos, pictures, whatever it might be from protests, don't resemble the mobility models that we have, and that our mesh applications that are meant for use in protests don't work well. So we know these three things, and you're probably asking yourself, what do we do about it? And that is the core of what my research is looking at, is to solidify our understanding of how people move in protest to be able to build strong mobility models. And this is sort of the flow of what this can look like in the future as the project develops. So we're going to develop better mobility models by conducting interviews and watching footage. And once we've done this, we can actually do very representative evaluations of how new mesh schemes are working. And once we find one that works, there's room to build a better mesh application that's meant for protesters, that's kept them in mind from start to finish of the development. And we're here right now, is we need to understand the way that people move to build these strong mobility models. So we can talk a little bit about what that approach looks like. My research questions, these have been cut down for brevity because they're kind of wordy, but essentially what we're looking to understand is how do various people in the protest setting communicate when there's an internet shutdown that's going on. Secondly, we want to understand how these different actors are physically navigating their environment during protests when there is no internet access. And finally, we want to know what kind of features that they would want in a secure communication system that can be used during an internet shutdown. And we're hoping to glean this from our interviews that we have that I'll tell you a little bit more about. But before we got to that, we did a lot of groundwork. And this was a massive review of publicly available media to sort of contextualize the study and give us an idea of what the movement patterns look like from afar. And by watching them, we were able to identify patterns and develop questions, sort of like what y'all saw in that clip before. So to show them a little clearer, we see these like bonded clusters of people. This is those relationship nodes. This is you with your friend. This is you with your sibling traveling around the protest. You're not going to tolerate a lot of distance being put together. So one thing that I want to make sure that we get in this new mobility model is a way to represent this. A way to represent nodes that travel together, will only tolerate up to X distance between each other. And if they are to be separated, they come back together at some point. Another thing that we saw was the channeling. So even when there is room for people to diffuse and make space, they're much more likely to just stay closer together, and we can point back to the crowd science to explain why that happens. But we need a way to represent this as well, because the idea that we have that these big crowds of people are sort of like these like mindless, have no direction in the way that they move because there's so many people, it's just not accurate to how people move today. Crowd science tells us that they're self-organizing, and we need a way to represent that. Another feature that we definitely need to have in our new mobility model is going to be a scatter. Particularly when you're looking at the protest context, you have hostile actors, whether that's law enforcement, whatever it might be. We don't have a way to represent them coming on to our 2D grid space to interact with the people. And what we noticed through a lot of review is when you have a hostile actor and they come in contact with a group of people, you actually see people clump together and scatter apart, which even if it doesn't make the most sense in terms of their safety, think back to those optical neighbors. When there's a lot of things going on at once, we're just much more likely to follow the person that's in front of us. So even if it's not the best escape route that's available, we're traveling in groups. And this is something that we need to consider when we're talking about mesh. Again, mesh is constantly restructuring itself when people move around whatever environment that they're in. And if we go from this, like a tight group of people, to this, we have like little cells of people breaking off in different directions, we need to be able to account for that. When it comes to people using mesh networks, we want to try and prevent people from being unable to message with each other. So this motion is something that we want to be able to simulate. So we did our media review, and the next phase in this project is going to be an interview study. And we're looking to talk to 3 specific kinds of people. We're looking for civilian demonstrators, we are looking for protest organizers, and we're looking for journalists. And we're doing this for a particular reason. When you think about all of the different types of people that might be present at a protest, there's going to be subtle differences in the way that they behave and the way that they move. And we want to be able to draw on all of that to paint ourselves a really vivid picture of what movement might look like. So for protest organizers, what we noticed in the review is that there tends to be this scouting behavior. So if someone is in charge of making sure that everyone stays safe and the protest continues to move in the right direction, they're probably going to run out ahead or hang far back and give people an idea of, hey, there's police that are present at this street and this street, so stay aware. So you're going to have like this wider lens view of what's going on. You often have multiple in the same demonstration that are leading it forward. That gives us different perspectives. And they have an understanding of what the intended motion is supposed to be, which is something that we'd want to draw on when we're trying to understand mobility. For civilian demonstrators, they are in the center of the action. You can think about like that very dense crowd of people. And the way that they've experienced the protest is through their personal perspective. And they might be missing a little bit of context as to what is happening like way out ahead of them or way far behind them, because they're just seeing what's in front of them because of how dense those crowds might be. But we want to understand, for people that are in the center of what's going on, how was your movement influenced, and were you using any sorts of devices to try and communicate with people? When the internet went out, what did you do to continue to communicate? So they have a very an interesting way of evaluating what's going on as a whole. And finally, we want to talk to journalists. One thing to keep in mind is that I would say journalists are often conflated as being a part of the protest, when really they're there to report. So you'll see journalists sort of hanging out on the edge of crowds because they want to get an idea of what's going on. So we can't just combine journalists in with the rest of the people that are there demonstrating for the cause, because they're there to report. And you're going to see a difference in the way that they move because of that. So I would call them semi-independently motivated to move. And that's going to give us a rotating perspective that's going to be important for this. So let's do a little diagram. Let's say we have a northbound protest, and we have our civilian demonstrators. They're going to be the most tightly packed. They're going to be right together, right in the center of the street. And then we have our protest organizers that are going to hang out way in the front, way in the back, giving us an idea of what's going on to protect the safety of the people that are involved. And we have our journalists that are hanging out on the edge of all of the action to try and get an idea of what's going on to be able to report on that. And when you think about those three different positions, the three ways that they're going to move, the ways that they're motivated to move, you have this very interesting perspective where you have journalists sort of looking in on everything going on. The civilian demonstrators are seeing what's ahead of them, and the protest organizers can see beyond that. And by drawing on those three very unique perspectives, we can get a really strong idea of how people are moving, even though we're not physically present there to be able to see ourselves. And that brings me into the ethics of the project, which is definitely something that's important to discuss here. Protesters are an at-risk population, and that requires the utmost care that we can provide when working with them. So things that we're keeping in mind as we're developing this interview study is that any of the footage and media that we reviewed in the groundwork phase, that's not going to be released at any time. That was just for us to get an idea of what's going on. And when we get to the interview portion, when we have people giving their testimonies about how they moved and why they moved a certain way, we're going to make it so you can redact that at any time. Even after you've said everything and you decide, actually, I don't know if I'm comfortable with that, take it back to make sure that people stay comfortable. And we want the goal of this to be to improve our understanding of protester movement. We don't want it to be something that's predictive. And this is something that we're keeping in mind as we're developing. And sort of the train of thought that we had for this was that, again, we know that the current mesh tools that we have don't work well enough to be widely trusted or used. And we can't release some sort of application to the protesters that are involved in certain demonstrations because it puts them at major risk, both legally and bodily. We don't want to put anyone in danger. And I would say it's highly unlikely for us to be able to contact an ISP or a telecom and ask them for communication data to get an idea and do traces. So that brings us to our next best option, which is observation and interview, to get a strong idea of how people are moving to be able to address this problem. Considering all of that, I'm very optimistic about the direction of this study. I think that this project is the first stepping stone in a series of stones that we can use to develop tools that can more directly serve the needs of civil society. And on that note, I recognize that I'm in a room full of experts, and people here have all different kinds of knowledge and expertise. And I would say that this project is an interdisciplinary one, and we need to pull from multiple places to get an idea of how to attack and solve this problem. So we want your input. I think we have a little bit of time left, so I would love if people have like questions, comments, or suggestions for how we should go about this project. We really want to hear them and draw on all of your knowledge. And with that, thank you very much.
We do have one question that came from the online. Maybe we'll start there. What do you make of Sino Browser and Briar? These were built for autocratic environments.
Yes, so Briar is one that I took a look at. I think it's very interesting as a solution. My understanding of Briar is that there's some other factors at play. It's not true mesh, and we're looking like directly at that true mesh situation. But I would love in the future to be able to evaluate it and see, because generally the reviews that I read are quite positive of how Briar works. Yeah.
So one thing about like protests, of course, they happen in an environment where things are that environment which is kind of mutable when you think about it, like police barricade streets or kettle protesters in ways that aren't necessarily like direct attacks on the protesting crowd.
Mm-hmm.
Are you planning to account for that in your modeling as you move forward?
Absolutely. We want to be able to account for like the physical features that can be put in place that could like directly block someone's path. So whether that be putting up barricades, or perhaps there's like a line of cars in the way, or like a line of people that you just don't want to interact with, we want to be able to model that. So that's absolutely something that we're looking into, and we're hoping to get an idea from the interview study of what is most common and what people are seeing the most as an interruption to the way that they're trying to move. Yeah.
So you've been talking about communications technologies that use Bluetooth as their physical layer, at least for the existing art. At Hope, we've had 2 or 3 talks about mesh-tastic,
Yeah.
which uses the ISM band.
Lots
Has
of
there been
mesh.
any discussion about how they handle their routing in protest situations, or?
So my lab is very interested in mesh-tastic, and it's something that we're hoping to evaluate. This project, this mobility project, is actually based off of the work of my advisor, Tushar Joyce. He gave a talk here last year that was on this project. I don't know if anyone might have seen it, but essentially as they wrote their paper and they did their evaluation, they noticed that these mobility models were an issue, and that's sort of where my research comes out of. So as a lab, we're very interested in evaluating it at some point because the technology is really cool. For the moment, we're looking specifically at this instance. Yeah.
Are you concerned that publication of better models for movement can be useful for police and for oppressive regimes?
Right, so this is something that we have thought about a lot when we're considering the ethics of this project. And I think that it's a complicated question, because if we want to try and advance mesh technology specifically for this use case, we need a better idea of how people move. But at the same time, we don't want to make something that can be flipped and used as a way to harm the people that we're trying to protect. It's something that we've thought a lot about. In my opinion, I think that to make strides towards developing something better, something that can help keep people safe, it might be something that we have to dip our toes into, but very carefully. And the process of us designing the study when it comes to gathering information, we're trying to do it very intentionally, making sure that we keep people as private as possible to protect them so they don't face any repercussions for contributing to our research. But it's absolutely something we've thought about, and I think it's a hard question to answer. But that's sort of my position on it.
Someone's going to do this anyways,
Tibet or send ads at you or whatever. So might as well do the work and make sure that, you know, it's promoted to, you know, good social, you know, work.
Absolutely. Yeah.
So I look at this as a cat and mouse game because I guess most people who are protesting are using iPhone or something like that, which has a certain frequency band for carrier wave. Police just needs to overwhelm those frequencies, and you don't even have to worry about a mesh network. You have no network, you have no carrier wave, you have nothing.
Right.
You can shout better if you get that way. And then, you know, when it changes to frequencies, or they start popping frequencies, and then they catch up with that. So it's really, you know, law enforcement has people who are looking at LoRa right now, for example, to figure out how to interrupt that.
Absolutely. That's another thing that we're hoping to understand during our interview process, because you see two divergent like schools of thought when it comes to using technology at protests, at least from what we reviewed. So you see people say, absolutely, like, have your phone. You need your phone to be able to communicate with people and let them know that you're safe. Then you see another group of people that say, do not bring your phone. That's extremely dangerous. You can be tracked. Leave it at home, or if you need a phone, bring a burner. And we, as an academic community, don't have a good grasp on what that actually looks like in practice. And I think once we go through the interview process and we're able to get an idea of what people are carrying and why they're carrying it, we can start to tailor solutions. Because it is true that there's always going to be an oppressive power that's pushing back against us. So we need to be able to innovate constantly. And I think that this interview will put us in a great position to do so.
It's that you need to, you know, we're playing chess, right? And it's like, oh, okay, fine. Hey, this is awesome. I can communicate securely with everyone, but it's ISM band. And like, as far as like, oh, knocking, you know, that out, easy. You know, we can knock out Hope, you know, Meshtastic, no problem.
They can shut down cell service if you really wanted to. It's
Well,
just a question of what tactics do they want to use against protesters and how far they want to go with that. Because, you know, that also denies them information and data.
I think they're in a better place to sort of knock out, you know, consumer grade stuff,
Right, but,
you know, while keeping their
well,
own.
no, I mean, it announced that information about the protesters is my point.
Yeah.
So thank you. So I was wondering, what actual issues are you seeing with having bad models of crowd movement? So you showed like that we have bad models, but like what actually goes wrong?
Sure, that's a really good question. So there is one paper, and I can find it and I can send it to you. It is a little bit older, but they found that the random waypoint model in itself, when you're simulating, it has this tendency to take the nodes. So like, you know, it's randomly placing people with, you know, no order as to why they're going somewhere. And it has this tendency, as the simulation runs over time, to actually cluster everybody in the middle of that grid space, which goes against what we know how people move. And there was also some talk in that paper of, as time goes on, because it's like an endless simulation, there's this decay that happens and people aren't able to complete their movements. So I think that all traces right back to it being random. We don't have a good idea of how people move, and when we try to use these features to try and supplement that, you see these movement patterns that just don't match. Probably have time for one more question, I would say. Yeah.
Just on the topic of, you brought up how you can't just release the beta and then have people test in the field for the obvious reasons. So just throwing it out there, has your team considered, and of course you'd have to find a group that's willing to do this, or groups, but just having people take into a live scenario and then communicating dummy data over it, talking about, I don't know, what you eat for breakfast and stuff like that.
I think that is an interesting approach. I would be very hesitant to issue anyone that's in these sorts of situations any sort of technology or like anything that could bind them back to us that could cause trouble for them. I think it would be a great way to collect mobility and trace and have an idea. It would also cut out a lot of the work when it comes to like, how do we make it as easy as possible for people to tell us, you know, if you asked me, how did you move around today, Cora? I would probably shrug at you. So we're trying to figure out ways to make that like retelling easier, whether that has to be some sort of like tactile model that you move around, or if we're just giving you pen and paper and you draw. But that's definitely an interesting approach, and I'd love to talk more about it. One more? Okay. One more question. Hi.
This is really great. I'm super fascinated. I want to learn more. I've also spent a little bit of time studying mesh networks, and one of the things I think is really interesting about how we think of mesh is that often there's a presumption that the network emerges spontaneously, like as an emergent property. And I think with mesh networks, first of all they're not always ad hoc, and they're not always mobile, and they're not always perfectly horizontal. Sometimes they tolerate certain amounts of hierarchy. So I'm wondering if you guys have thought about it, if you've looked into thinking about any of these, like incorporating some of these other aspects of mesh. Like for example, a group of people might mark certain nodes as more influential in advance, or place certain relay devices in the area, and like adding some stationary or some hierarchy or other things that aren't just purely automated algorithmic ad hoc, emergent topologies.
Yeah, absolutely. It's definitely something that we've talked about. So I'll point you to my advisor's paper that mine is built off. It's called Amigo. Amigo by Jashara Joyce, and you can find it online in archive. But essentially, they have a very interesting way of approaching what that looks like. They use clique routing. We've also talked about in lab ways that we could deploy, like what you described, like a deployable device. We described it as some sort of spine, like perhaps because you see this happening a lot in urban environments going down a city street. You have buildings along the city street. Perhaps there's people that are willing to have some sort of device that helps propagate the signal down further to help people when their mobility isn't ideal for the communication we're trying to do. But absolutely, I'd love to talk more about it because it's definitely something we've thought about, like for the further down development of this. Thank you, guys.
All right. Hello, everybody. Thanks for joining me at the last session of the night, in this room at least. Yeah. Today I'm going to be talking about this project that I've been working on for a little bit called the BioArtBot. And hopefully by taking you through that project, I'll be able to just give you a bit of a primer on biosafety and lab automation. And I think it's just a good project to get involved if you want to try to build your skills in one of these areas. And if you're not interested in that sort of stuff, it's just interesting. So I'm going to introduce myself. I'm going to talk about the BioArtBot and like why I'm even presenting it today. And then I want to go into the hardware and the software and the wetware, because this is like a robot that moves bacteria around. So the wetware is like the organisms and stuff. And then I want to explain like the project that I took on in the last year, which was expanding the palette. And you'll learn more about that as I go through it, but essentially it means that like there was an existing set of pigments we were using and we wanted to add some more. So that means finding new bacteria of some sort. All right, so yeah, I gave a talk last year, which I think has more of my theoretical framing for why I do this type of DIY bio work. Essentially, like, I would really love to see a world in which that we like exchange more biological samples between each other, especially ones that have been engineered in some way. But I think, and my big example is just like, it's frightening.
You said you wanted to exchange samples.
Yeah, but I mean, actually, in my thought, it's like it could be as easy as like people already exchange like, you know, yogurt and stuff, and like I think that might be the form factor that people are comfortable like exchanging these things, or sneezing, or like making out, I don't know. Anyways, I'm a microbiologist by training. I actually studied infectious disease microbiology, but then I've sort of taken this path where I like started working as a pharmaceutical advertiser to make some money, and then I kind of quit that and just like volunteered for a bunch of time trying to set up a community biology lab, which is where this work is done. And it's here in New York City. So, you know, I'm really interested in local connection here. Like we're a nonprofit lab. We're organized as a 501c3, but like really we're just like a group of volunteers who are running this like lab together and essentially splitting the rent and sharing the equipment. Because not everyone wants this equipment in their homes, or like it's hard to get it sometimes. And so it's like nice to have a place you can like join together with others who are doing that sort of thing. So yeah, why am I talking about the BioArtBot today at Hope? Well, we'll start off with this idea of paint that can be anything, even bacteria. It's a funny thing to think about. You know, it's just like if you can deposit the material and it has color, then it's paint. And that's been true as long as bacteria have been around. And in fact, like this Alexander Fleming, the guy who is attributed to discover penicillin, right? He had moldy plates in his lab. He also had paint. He was part of like the Chelsea or Soho Art Club, something like that. And he painted these things. So this top image here with the nursing baby and like the, I don't know, hexoid head fighting people, like those are his paintings from back in the day. And you know, this is not like a new thing, like even in our modern sense. Like in 2015, the American Society for Microbiology has been holding agar art contests, which are just really cool. This image, the bottom image is like from like somebody's drawing them. You can't really see it, maybe you can't see, but essentially like they have a portrait underneath an agar plate and they're kind of tracing it with bacteria. Because you don't see the bacteria when it goes down on the surface. It's like microscopic, but when it grows up, that's when you see the color. So that's one of those caveats, right? Like, oh yeah, you can paint with it, but it's invisible when you place it and you only see that color afterwards. Not everything grows together on the same medium. So like that's a limitation. It grows at different speeds, it makes different textures. Bacteria can fight each other. So like if you're painting with a bunch of different like pigments, like you could like sort of antagonize your own painting. But I mean, that could also be really cool, right? That could be a limitation. And in fact, that's like why I bring it here in some ways, because it's just cool, right? Like this is just a really interesting way to get involved with thinking about how do I work with microbes, right? How do I work with biotech? So like one of these paintings is done probably in like an academic lab, I think. This is like the professional class or whatever. So they have like their own special systems. They don't have to worry about what organisms they're working with. They're already working with them for some other research purpose. And then they paint something really cool with it. And on the other side, that's actually, I think it's actually based here in New York City. There's like a lab called the Buca Lab, and they do a lot of synthetic biology, and they made a whole suite of yeast that had different pigments in it. And so then they deposited it using a commercial, like sort of very expensive robot that they have access to make this kind of cool restart. So I think it looks really cool. That's one of the reasons I brought it to Hope. And finding new people and ways to engage with ideas is good. So like just that cool factor, I think, is sort of reason enough to show it to an audience and see what people think of it, see if they want to make it themselves, and something like that. So I like this quote from somebody from the RSA, or it was a talk that was given at the RSA. He says, "Nothing is brand new, but it can be done differently for a brand new outcome." And I tend to think about this in technology a lot, right? Like sometimes you don't have to reinvent the wheel on everything. There's like a lot of prior art that has been lost or that had very narrow applications. But like the interesting thing, and I think the hacker ethos of doing it, is like opening that up, right? Finding a new application area for something, or a place that it wasn't previously applied. Different groups trying to use the same tools that people have been using for a while. So I'm going to tell you some of the biology tools today. And I think actually, like zooming out even more, like the community biology labs, biomaker labs, like we want simple activities that people can build that tell them that, oh, these are cool things you can build inside of our labs, right? I think this is true for maker spaces as well. But in like the electronics world, you have access to the Arduino and the Raspberry Pi systems, which are like really nice hobby platforms to build projects. It's hard to find those things in biology. And I'm hoping that the BioArtBot is one of those projects, but you can tell me what you think the barriers are as I tell you more about it. Yeah, there's just like huge opportunities to develop like new entry kits or new entry pathways projects for people to get involved in this space. And the limitations are there's a lot of specialized hardware in biology. So the top two pictures now are like the bioreactor and the bento box. So bioreactor is like this kind of cool open source-ish, I think, project. It's a shield for a Raspberry Pi that helps you do like bioreactors. So you can have a little 20 milliliter bioreactor. Cost is like $250 for entry, something like that. But like that's ostensibly kind of within the realm of a makerspace. But again, like this is the specialized hardware part, right? They're selling it to scientists that have like huge grants at their disposal. They're selling it to industry folks, right, who have a little bit larger. Hobby industry hasn't caught on to like what the possibility is yet with this. And then the bento lab is like, that's like an all-in-one molecular biology kit. You got a centrifuge, you got ways to look at DNA, you got ways to grow bacteria, and that's all packaged together. And it goes for like $1,000 or something like that. It's like, it feels like these things are a little bit outside of the range of hobby, in my opinion. And so I think that they kind of prevent like real tinkering and playing around with this stuff. So then diverse consumables are another thing. Once you get that specialized hardware, biology experiments sort of consume something in the process of making, right? We're mixing stuff together. Something eats another thing and then grows. Something's consuming a nutrient to produce something else. And there are good suppliers for that sort of thing, actually. Like the bottom photo here on the, well, I guess it's my left, but maybe you're right. Oh, yeah, it's everyone's left. Okay, on the left is a kit from Carolina Biosciences. They're a great educational company that makes all these kits, and you can order your scientific reagents from them, and then you can tinker with them. You don't have to use the kit's intended purpose. And this specific kit is like you get to grow little worms called nematodes and feed them RNAi, which is a type of RNA that when it gets, at least for these nematodes, when it gets into their gut, it like suppresses their gene expression of a certain type. And so you end up changing like the phenotype of these worms by feeding them pieces of RNAi. You can imagine how like that would be an interesting tinker project where you're like, what if I give them different RNAi that suppresses different genes? What does that look like? So like, you know, it does exist out there. It's like kind of packaged within its education framework. And then where do you do that work? Where do you edit the RNAi, right? That's, anyways, a limitation. And on the other side, and the other one down there is BioBits. They make like a cell-free extract. So essentially all the power of making proteins in our cells, we all make proteins in our cells, they take all the liquid outside of it and then they put other templates in so they can make other proteins. Yeah, it's it's an interesting reagent. It used to be like made from wheat germ. You can like, wheat germ has all the components to make proteins in it. Anyways, these are sold as educational kits, right? And it's a really good source of that sort of tinkering stuff. But again, like that's not clear to people, I think, when they're thinking about like making an interesting biology project, that like you have to dip into these sources of materials. And then again, there's no real plan or like test project, hello world project that folks are familiar with. And I think the BioArtBot could fill that gap. So you tell me, I guess, as we get to it. So yeah, it's adapting automation for art. So the big like what are we is like it's a project for encouraging curiosity, right? As I said, this on-ramp. It's based on a pipetting robot, an open source project based on that OT2 pipetting robot, and I'll talk about that more. And it draws user-submitted pixel art using colored bacteria. And so that's I just removed some of the front image of the last one that I showed you. And here are some examples of bacterial pixel art, right? There's like lots of really fun things you can make. There's lots of colors. And this is from when we expanded the palette. Here's another example of some bacterial bioart. So it's a slightly different color scheme, and that's because we weren't using synthetic, we weren't using engineered bacteria, we were using natural bacteria, quote unquote, that we found in the environment. So the colors are like a little bit muted. Okay, so let's talk about this OpenTron's OT2. That's the open source platform that the lab automation side is built on. It launches a Kickstarter in 2014 from people that came from the community biology environment, folks that were working in labs like Biotech Without Borders, that were kind of like, how can we make a cool thing? And I think this sort of speaks to the fact that it was easier to hack a piece of electronics to help within the lab than to hack like some biology thing in the lab to then kind of get big. The software is open source, and technically the hardware is too for this OT2 model, but like I think the sourcing of that hardware is like really difficult actually. But the open source software is really nice, and that's what let us build on top of it rather, to make the BioArtBot software. And I think it was a relatively successful project because there's a lot more of these machines running around the world now. I think previously, before this object existed, you'd have to spend like hundreds of thousands of dollars to get some sort of lab robot. But now you can spend like $10,000, or maybe you can find a broken one and fix it up yourself. And how does this stuff get used in the lab? Well, as I mentioned before, biology is about mixing small volumes of liquid together to carry out different reactions. So like in this picture, there's like 3 different reactions that are happening. Those are 3 different steps. And in each step, you have to add more things, you know, some water, some like squiggles, some other colored squiggles. And then the output of that is like other colored squiggles that go into the next reaction where you add more things and they become something else, right? This is the general workflow of like doing some sort of biology research. And then where the automation part comes in, or like, I guess this is just part of the scaling up part, is that people use these plates, either 96 wells or ×4, 384 wells, or ×4 again, 1,536 wells, to carry out a whole bunch of reactions all at once in like a form factor that's like this size, right? Oh, you can see the person's holding it. And like, that allows you to either test different conditions, test along a range of conditions, right? You can see the gradients on the top, right? They're testing different conditions. And so you can imagine now the next step, adding the robot into this, it's like, okay, now you have like a whole stack of plates and you're running all these reactions. Yeah, that's how people use these robots in sort of an industrial context, right? In a large scale research context. But for our purposes, the OT2 kind of sits in this like, we're still filling the plates by hand method, but maybe once the plates are filled, they can go into this robot and the robot can do the rest of the liquid manipulations by itself. It can add something to each of the wells. So it's a pipette assembly, so pipette being the thing that moves the liquid around. And it has 3 axes of movement on a gantry to manipulate the modules in the deck, right? Go X, Y, or Z, it can go up and down. And the deck is where all the things that we put on there. So like if we want, you can see there's sort of, I don't know if you can see, there's like 9 spots maybe. One of them's occupied by something pink, and then the rest are empty. And then there's like a trash in the back, and then there's like a place where it kind of like refills the liquid handling object. Yeah, anyways. So yeah, tip holder and some trash. And then what was nice about using this machine is that, like, again, because it's a little bit, the software is open source, when something broke on it, when something breaks on it, you can just like write a software patch maybe to like use a different piece of the hardware to achieve the same goal. So that was a really nice feature. And that's actually a big feature of the one that we have in the lab. It's kind of like hacked to bits. And maybe I can show you a picture then. Oh, actually, first I'll say the BioArtBot of it is a website essentially where people draw the pixel art that they want on the website, and then the code turns that into something that the robot can read. And so then the robot will then deposit those bacteria onto the surface of agar. So I think maybe I will try to switch over just to show the video. Right, so like this is like what it would look like in practice, right? So you have this robot, it's like doing a lot of repetitive motion to try to put each pixel onto the agar. And there's just like a bunch of different views of this. And so it'll just like cycle through some of these videos. They're very, very short. But you can see that in the back of this robot, there's a section that has everything like where it picks up the material, right? Like it has to switch out the little plastic bit that does the liquid handling and has to go into a little plastic tube that contains our bacteria and then places it on there. Okay, I think that gives you the idea. So that's all within the software. It's in you can see the GitHub repo that we have for it. Essentially, just taking turning the submission art into a piece of Python code, and the OT2 understands that Python code. It draws upon a bunch of libraries that you can inspect to draw the image. And so essentially, if you have this robot and the wherewithal to put it to use, like you too can deploy the BioArtBot in your own space. So I mentioned like it costs a bit of money. I think that's a major barrier for folks, right? Not everyone's going to spend that amount of money. But what's kind of interesting is that like there's also labs that have it, but they don't use it all the time. Because like for a big lab, they didn't spend all the time. It could be a way to activate if you were interested in doing something like this, right? You could maybe find a lab that had downtime on their robot and say, this could be a great outreach opportunity, right? Can I load this onto your robot and just print a couple bits of art? Okay, but like the printing the bits of art, like you need the pigments to do this. And so like, what's that part? And so I will say that you could just print things out in colored dye, right? It doesn't have to be bacteria. But like the way that we constructed this project was to give people a taste of what people in the lab do essentially. And so it's like one idea is that you could use this robot to deposit bacteria in different formations that you're like testing some sort of like spatial interactions between the bacteria. Okay, anyways. So bacteria, what's the synthetic biology part of this, right? It's a rough transition. I kind of want to say like, oh, we're writing code for the robot, but you could also write code for the bacteria. People call it the central dogma. It means that our DNA turns into RNA that turns into protein. The protein's going to be the things that have the color, or at least the things that make the color. But of course, like it's not really that straightforward, but that's like the way that a lot of engineers think about implementing this type of stuff. And then there's all these caveats, right? Because like biological life like has more systems at play, more feedback mechanisms than just take code, produce product. But for all intents and purposes, we'll think about it as inserting a piece of foreign DNA into some sort of carrier into the organism, and then having that organism make some totally new color. And typically the way that's done is through a plasmid. And very famously, the green fluorescent protein is like the first protein that, or I don't know if it was the first one, but it was a protein that was moved out of jellyfish, which had this glowing green organ, and then put into bacteria because people thought it was like a nice research tool. Right? You could like mark things with it. And so for our purposes, we're just using it like a pigment. So there's an amateur biologist, I think I mentioned this in my last presentation, who like made a whole plethora of plasmids that produce the colors of the rainbow. And so this is the first iteration, let's say, of the pigments of the BioArtBot. You can bring your own pigments, right? Like we just happen to bring these antibiotic resistant ones actually. And so a process that we will go through after we get a palette of, after we bring together those pigments, we have to test those patterns just to make sure they all grow on the same they grow at the same rate, let's say, and you can kind of see them all together. So these are just some test patterns that we ran. And then what's kind of cool about these synthetically engineered ones is that they're fluorescent. I guess, I actually don't know the reason for this. Like, you know, these proteins are fluorescent in the jellyfish, and I don't know what the adaptive purpose of that is. Presumably there's some nature reason, but it looks really cool for us. And then here's some examples of some art that people made using those colored bacteria. And so yeah, UV again helps these images look nicer. So why choose to expand the palette, right? Like that's the description of the project as it existed before we took on this project to try to expand that palette. Ostensibly everything there works, right? Like we have the robot, it prints the thing, we get images, people can have fun. And yes, I think that is true. But something that I'd sort of alluded to here is that to get the plasmid into the organism, to know that the organism that has the plasmid, the piece of foreign DNA, is the one that's going to make your color, like we use antibiotics to kill off everything that doesn't have that foreign DNA. So with the jellyfish gene, we also add like a piece of antibiotic resistance, and then we put that into the organism, and only the things that survive, and we expose it to antibiotics, and only the thing that survives is the thing that we grow, and then we get this like pure culture, and it's really cool. But I think there's a limitation there in terms of really having people take this home with them and like putting it into our own spaces, or like even putting it into spaces that maybe don't have the same like cleanup protocols that you might want to use for some of these bacteria. And then also, I had to tell that whole story about putting DNA and bacteria, and like, as I said before, when I was thinking about like what I think the best way to exchange biological samples is, it might not be like genetically engineered things, right? It might be that there's like a whole bunch of cool organisms that exist out in the world, or like seed libraries, right? Like there's all these, there's this diversity that's already existing, and we just want to share it. And that's true in bacteria as well. So we wanted to find bacterial strains, pigments that we could share like that, and that we didn't have to explain the whole genetic engineering process to get people excited about engaging with this part of the biology. Yeah, they're like everywhere, right? Bacteria are everywhere. Like they're on me, they're like subsurface rock samples in the ocean. And they've lived on the planet for a really long time, which means they've had to adapt to the scenarios that they encounter for a really long time. They have really cool, rare biochemical pathways for eating stuff. And if we can think about where that might be useful, and where we might find usage for that in our own lives, I think that would be really transformative. But for now, as an entry point to this concept, I'd like to present the idea of just finding cool colors that we could paint with. And it's true, you can do like a big inventory of all the different pigments that bacteria make. And again, the purpose for them is like probably for survival in some way. And we just don't know enough about their lifestyles to always say why exactly they make that pigment. But they do, and I think that's a nice entry point for us as humans, thinking about human things, about things just for us, as a way of thinking about these organisms and what place they occupy in our lives. So, okay, but like it's not without risk, right? Like, and I think that that's an important thing that I want to explain to people, is that if you're going out and you're trying to find random microbes and growing them, okay, so sure, they're everywhere right now, but there's not a lot of them. Typically, the organisms are sort of kept in check by each other, right? Like they don't all grow up to like a big, I don't have like bacterial colonies growing over my skin, because like there's lots of other bacteria here, and everything kind of keeps it in check. And so when you want to just get one of those bacteria and you want to grow it up so you can see its color, there's a little bit of a risk that gets introduced, because how do you know that the thing that you're growing is safe? And so in the lab, this like lower image here, so like the top image is just like, look, some small bacteria grow into bigger and bigger amounts of them, and so much until we can see them. And then the lab below, that's like an example of a lab that you would do this work in. You need control over the ventilation, because the bacteria, actually, I was just in the air talk in this room. I thought it was a really great talk. They talked about, particulate matter in the air. Bacteria are of the size that they can easily become that particulate matter in the air. And so you just don't want to be growing large amounts of bacteria that you don't know what it is. For some things, it doesn't matter, right? Like if you imagine a brewery, they're growing tons of yeast, right? There's so much yeast in the air of a brewery, but there's no health concerns around that, right? OSHA is not like super concerned about like the density of yeast that's in those containers. But it matters the identity of these things. But in the project that I'm describing, where I'm trying to approach this and like grow the bacteria kind of before we know what it is, because we want to see if they have a cool color or not. So in that case, like you really want to ventilate the space. So people have a device called a biosafety cabinet where the air inside doesn't mix with the air outside. It's a HEPA filter, right? There's like an air curtain and something like that. But people do grow bacteria they don't know about, actually. Like there's this paper that I'm citing down here, Park and DuPont. Also this picture from Garden Culture magazine at the bottom. This is like a practice called Korean natural farming, right? And it says that like there are really great microbes living in the forest that we've kind of lost in our crops. So like, let's go into the forest and grow a bunch of microbes, forest microbes, and then bring them back to the crops. And that actually really helps enrich the soil quality and helps these crops live. And so like already I think I'm sort of touching on like one of those concepts from my last talk is like, yeah, like those are the things that maybe we want to exchange with each other, like things that work. Like maybe it's just method, right? But maybe it's like I found something in that sample that really works. Anyways, off topic. This Korean natural farming method, they grow these unknown microbes, at some frequency. They just do it outside, right? If there's good ventilation outside. And they use rice. I don't know if that's helpful, but like basically people have done it for a while and no one's gotten hurt, and that's like a valid way to do some of your experimentation. So I'll say that like when you're trying to find just a single microbe, maybe it's a little bit more difficult because you don't want everything to grow. You only want that one thing. So you might not have the capacity to do this. We partially did it because I'll explain later, thought the risk was low in one particular instance. But then also we also collaborate with some labs to like put it into their biosafety cabinet, right? And like kind of go more for the totally unknown approach. And then the other thing is, we also ask people for their microbes, right? And that brings me to this point. Once you know what that microbe is, right? If you know it's yeast, then you can just treat it like the risk that it is, right? There's a whole set of standards that people use to identify the risk group, the safety level of different organisms. And so we really leverage this one from the German federal government. Okay, so yeah, organisms, they're organized into these risk groups based on their capacity to cause disease. I could explain a little bit more. There's like 4 different levels. It's kind of like, does it cause disease to the individual? Can it spread to another person? That's like increasing risk levels. But like really for our purposes, I just want to tell you, we only want risk group 1, right? That's the group that, that the yeast is in the brewery. That's stuff that you can grow to these massive amounts and they're not going to cause too much harm. So once you, so the risk profile for this really looks like there's a point where you don't know what's happening on the plate, right? You don't want to make aerosols with that. Or if you do make aerosols, you want those aerosols isolated from you, either in a hood, wearing a mask, or outside. But after you get some sort of identification process on that organism and it comes up and it's in a list and it says it's pretty good, then you're more or less free to use that as you will. And so we ended up using a combination because of like these limitations of like isolating and asking for them. Because like if you look at the scientific literature, there's so much stuff there and you can just look at pictures and be like, wow, colorful stuff. And then call someone up and say, do you have it? Right? And they've done the identification. You can compare that to sort of known lists of like the risk groups, and then you could use that sort of stuff. And so I'll talk a little bit more about so the top pictures there are, that's what a plate looks like when you like don't know what the thing is. Those came from solar panels, like all sorts of weird stuff. And then these bottom ones are kind of the approach of like, then you have to do this isolation process of just finding one. And then you can have these tubes, you can mail them to each other. We got some about the mail. So I'll tell you 2 stories of the isolation of these organisms. First, a strange mold in my compost. So that's a tortilla. And if you kind of zoom up at the edge of this tortilla, I noticed it was getting a little bit orange. I was like, that's super weird, but I didn't think too much about it. I threw it into my compost, and then I saw this crazy orange pink fuzz that came into my compost. And I was working on this project at the time, like, oh my God, this is amazing. I found a color. Like it was just in my waste, and I have an on-ramp. And so I figured like it's food-based and it grew in my home compost. I've been exposed, right, to like a whole bunch of this. there's a little bit of a worry that like it came from me, right? That if it came from like the human body. So I didn't, oh, I should reference this. I didn't put it might be in the references. By the way, there's a whole list of references at the bottom, and like these slides are hyperlinked or whatever, so you can see sources. But there's a paper out there that says like human pathogens mostly come from other humans, right? Like we're the places that they live, right? They could be things that live on our bodies in one place, and if they get into the wrong place, they cause disease. So like that's kind of the worry when you're growing unknown stuff, that like you sneezed on it in a way, and like that was like the dangerous thing that now you're growing a bunch of, and you really don't want more of that. But in this case, like it was in the like the compost is this kind of competitive environment of a bunch of different things. I think what survives there is stuff that does well with other rotting things, right? That's not how our body is. Our body's not like full of rotting compost, right? That's not the medium that we're made of. And so I was like, okay, I think that's the risk is lower here. So so this is the plate of like the tortilla. Basically, we diluted water and we spread it over this agar to get these colonies. And then it's hard to see in this image, but that red arrow is pointing to the fuzz. And I was like, oh, that's the same fuzz that I saw in the compost. So let's like put it on a new plate, grow more of that fuzz, and then send it off to a company. We could do it ourselves, but again, doing it ourselves kind of requires a lot of manipulating the organism. We'd have to grow it up to a larger amount to get some of the identifying molecules out of it. And we had money for this project. We got a small grant, essentially, like an arts grant to do this. And so I was like, let's mitigate the risk. We can just like send it to a company and they'll just identify it for us. So these services exist for these biotech companies that are like doing processes. They're growing tons of microbes and they see contamination and they want to send it off to get ID'd so they know how to remediate it in some way. And so we can just send samples like that too. That's part of the benefits of being part of a community lab, right? It's like this lab has a name for itself, right? We're like an educational lab. We're like as if we were an institution even, right? Like so we can work with vendors that are typically interfacing with scientific institutions, and it's not so scary for them to be able to order these types of these services. So we ordered it. We did 2 different methodologies for finding the identity. We used something called MALDI-TOF, which is proteins essentially, and then we also used DNA identification. So the MALDI-TOF didn't work. And I think actually it speaks to the fact that like we're hijacking the system to find some random unknown microbe, but really the database of things that these companies are looking for, the databases are rooted in common industrial contaminants. And so like you might not always get a match. But DNA, people have been doing a lot of DNA testing for a lot longer. There's a sort of a rich literature out there of many different investigators that have worked with DNA. And so the DNA did get a match. And so it kind of generates a relationship tree. This tree is like different organisms, how closely related they are. And if your organism, basically you look for where your organism appears on the tree, and the thing that it appears closest to is what it's related to. Right. Oh, I could have used this to point instead of saying bottom left and stuff. Okay, like, so here, this is the unknown sample, and then it's like super closely related to this Neurospora crassa. And so then now the journey is like, what is Neurospora crassa? Is it a safe organism? So it came up on the list and it's safe. And like, actually the literature says that it was like, they were studying it in the 1940s. They were studying a long time ago. They were interested in it because it had some like cool genetic properties and stuff. So it's like, it's even well studied. And so it felt really nice that we were able to find it. And and so that's one pigment found. And so now we can like stick it in our little tubes and try to print some art with it. Okay, and then here's another approach to find organisms. We could like read a bunch of papers. So that's like this top part here is a whole bunch of papers. And it's from one paper. And we're like, wow, look at these colorful microbes. They come from solar panels. Okay, there's a little bit of a limitation here that like when you ask for organisms from institution, they might have intellectual property rights about this. And I sort of ranted about this in my last presentation, so I won't rant about it here. But for our intents and purposes, they let us use it. It was actually a really nice conversation. There's just so much stuff that academic labs create that aren't immediately commercializable and like really don't have, and they're also dead ends in some ways. Like these are random bacteria that lived on a solar panel. There was no plan to use them to make any sort of commercial product. And so they were happy. We didn't get these exact ones, but they were happy to give it to us. So we like asked nicely, had a chat. They had confidence that we were another lab that could do this sort of stuff, and they sent it to us. We did so I'll show you the sending process. So the sending process is they came in the mail. This picture is actually a kombucha SCOBY, but it really just came just like that. It came in this form factor, and I want to explain this to you guys because maybe you don't see this often. It's a small 1.5 milliliter tube that has sterile agar inside of it, and then the organism is just like streaked on the surface or stabbed into it. And these are pretty stable. I was not prepared enough today to bring them, but I'm hoping for the next hope I'll like have a better protocol. Be like, yeah, take them home where you can have them. But yeah, if you want them, you can also just ask and they can be mailed. It's a very simple thing. But we did verify their IDs using the same commercial service that we did for the Encrasa, because like, I don't know, like you have to double check work, and like we were thinking about doing it ourselves. Like, again, the labs didn't care about like what was the fate of those strains. For them, they used the ID and then it went to a list and they like listed out all the things they found. For us, it kind of matters a little bit more. And we did find things that they misidentified after we used the service. So like, it's good to have the identification capabilities. And as I mentioned, they came from solar panels. So I just, did this Google Maps zoom in to the solar panel that they came from. It was in the Boston Harvard Arboretum, something like that. So they rinsed the solar panels and took them off. And so here's a test print with some of those pigments. So the pigments that we got from the solar panels are this pink yeast and this orange bacteria and this yellow bacteria. And then these kind of fuzzy ones out here that are hard to see, that's the neurospora. It ended up being kind of a fuzzy quality. And actually, we ended up having to do a bunch of troubleshooting because when it grows as a colony, it did not grow as a nice pixel. It like took over the whole plate. I think I sort of indicated that in the picture that I have from it, right? Like there's no like dots there. It's just like everywhere. But this is where it was like, there's a really great moment for me. I was just like reading the old papers and they're saying, oh yeah, like people did genetics on these things. So I'm like, if you do genetics, you have to be able to see single colonies. You have to be able to pick one organism. Well, okay, colonies is not a single organism. It's like a bunch of organisms, but they came from one organism. You have to be able to pick one and do it. And so like, how did they do that? They actually added some like random sugar to the media, and that sugar changed the behavior of how the colony grew. And so this media here actually has that sugar in it. So it was fun. It was a fun little process. And this one here, this is another one that we asked for nicely. This one is and this one we used a biosafety level 2 lab to isolate. So like we had one of those hoods that like isolated the air and stuff, because like there are some nasty things that are known to be found in soil, most famously anthrax. So like we wanted to take the precautions for that one. And so we grew that one. That was in a hood, and then we found this soil bacteria. It's it's a type of it's a streptomyces. So it's a bacteria that makes antibiotics. It's one of these antibiotic producing bacteria. They're also very common in the soil. Antibiotics are very common in the soil. Not at high concentrations, just that like, these are molecules that bacteria use to communicate with each other and to like have turf wars and stuff. So like the soil is a very dense and rich place. So they have some antibiotic capabilities. And actually you can see, I'll show you some of the test prints. So you can see that actually this chicken, especially in this chicken, these legs should go right up to the to the bottom of the body, but it doesn't, because there's like antibiotics being made by these organisms, right? So it's like preventing the image. But like, I think this is like really fun and interesting for people to participate in, because it's like you get to see these concepts in real life while making fun images for each other. So yeah, there's some other place-based palettes stuff. And I want to shout out these two handles down here. They're the folks that helped us take these pictures during the workshop that we did at a lab in California. Okay, so my final thoughts about this project are, yeah, we have these strains, right? This is kind of a follow-up from last time. They're available for use in community labs. If you have a space, right, that you're interested in using any of these, painting with them. So like we painted with a robot, But probably I'm hoping for next year's Hope, I'll be organized enough to sort of like, we can paint them just by hand as well. So like, we can bring them, we can do it, right? You can also just mail me and I can mail you these strains, right? Because we have them at the community lab now. And it's fairly simple to like sample from the environment, and especially to read papers and ask for these organisms to find other interesting living pigments. And actually, you know, if I were to do this project again, I would actually just do it all through the literature, because I think that it's a little bit easier to see the diversity there, and it's just as effective. Like the end result is that I can still stand in front of you and tell you a story about this organism and how like someone found it and where it came from, and that can still like kind of flesh out your understanding of all the cool things that live around us. I didn't have to do a lot of the like tricky legwork of like assessing like, is this like going to be fine to grow? Do I have the right facilities for this? But of course, if you do have access to those facilities, you can ID these organisms yourself. And I didn't tell you how, but like actually working with DNA is fairly trivial these days inside of labs. And so like there are methods you could use, especially if you have that biosafety hood. Or, and this is like just where my mind has gone as I put this presentation together for everyone, or you could like sort of do a method where you're working outside and there's good ventilation around you, and like you're working, but you're still able to keep what you're working on away from the air that might have microbes that you don't want in it. Anyways, well, that's for the future. And if you're looking for a project framework to get into lab automation or biological wet work, I think this is a really great candidate project to pick up on, because like if you want to contribute code to like have it draw differently, like maybe you don't want pixel art, maybe you want like strokes or something, like you can contribute that into the code base, right? You can fix up the website to add a new brush style, right? And have that go over the agar. Or you could find your own organisms and contribute them into your own palette and expand it that way. Okay, so thanks to everyone who helped with this project. You know, Biotech Without Borders is the community lab that I'm in. It's like a really nice place to do this sort of work. Particularly, there's a volunteer named Sean who really did a lot of the coding. I did a lot of the coding. And Leon, who actually is just like a general community biology person. He like had a networking meeting where I met Sean. And then Corinne and Tim, they're my two collaborators for this Experiment Foundation grant that we got to do this work. It was a small amount of money. It was like $10,000. It's like a crowdfunding website for science, but they also like kind of put small grants towards little projects. And so those are my collaborators, artist and an automation engineer that kind of helped bring this all together. Yeah, you can reach me this way or reach the BioArtBot this way. And you don't have to worry taking that picture. Oh yeah, because I do have a QR code that you can grab all this stuff from. But I do want to say, you know, I saw in the old Hope archives at Hope X1, there are a bunch of DIY biologists and biohackers here. You know, here's an old presentation. And again, I tried to reference this nicely so you can always find where I found these things. It'd be really great to like have that confluence again of people working on this stuff, because I think there's a lot of stuff that we could share, tools of the art, what are we concerned about, what do we want to make? And having those conversations here at Hope is like so important, because I'll echo the sentiment I've heard from a lot of people, right? Like there's a framework here about thinking about technology, and I think that I like that framework and I want to extend it to other things. So anyways, this presentation is for you guys, so grab it and share it, because I think that like more people thinking about these types of projects is a good thing. So does anyone have any questions? Oh yeah, thanks. I'll take this one here.
If I understood correctly, the BioArtBot workflow has a portion that's web-based. Is there a fully local version?
You could run a local survey, a local server, right? Okay. So yes, yeah.
It's like open source.
Yeah. You could go to GitHub repo and deploy it yourself as a local server and then just run it there. So yeah, we know that some people have done that already. Like I think Sound Bio, that's in Seattle. I think they've done it there, and they didn't really talk to us at all. They just like pulled the code and did it. But you know, if you talk to us, then we can also try to like brainstorm some of the features that we've been interested in seeing. It's up to you. Yes, in the back.
Do they die?
Yes, they do die. Yeah, so actually, it's actually really fun to watch. There's an artist here in New York City, Karen Ingram. She's part of Biotech Without Borders these days, but she does these paintings, and like she just loves watching them grow in her apartments and then get old. And like, there's a relationship there too, right, to biological material. And I think like, yeah, you don't have to be a painter with connections to do it. I think hook into your local community biology lab and try to get this stuff from academics. Yeah.
Can I just have a follow-up?
Yeah, sure.
So when they die, do they have, is there a significant color?
Yeah, I think it's different for different organisms. Sure. Yeah, which is really fun. So I mean, for the fluorescent ones, I think they do have like a pattern of just kind of fading a little bit. I don't know. It's hard to say. It's different for different organisms. I don't want to speculate so much.
Yeah, the same question.
Oh, yeah.
What's the longevity? It's actually living art and dying art too, which brings some important philosophical questions about the nature of art. And maybe to quote Marshall McLuhan, the medium is the message. And here, Agar is the medium.
Yeah, it's a funny thing. I mean, I'm sure there are very interesting art critics that would like to explore that further on the philosophical sense or stuff. I mean, to me, it's like an image in time, right? Like I'm showing you pictures of the stuff that we made at certain points, right? Like the entryway is that to me. What I'm interested in is also this idea of like, and why I tried to put some work into it to find organisms that you can just like find in your local environment that like aren't considered dangerous. Because you give someone a plate of this to take home. Like I'm thinking about the hackerspace, right? People want to take something home that's really cool, but we're kind of uncomfortable letting people take home the genetically engineered organisms because like, well, what if they let those out in the environment, right? But these ones, they're already found in the environment. So like maybe you can take this one home. And so if that's what I was saying, like I wasn't prepared enough for this hope to like really like have that framework ready to like give you guys plates, but like, yeah, next time.
Have you heard of this company that's selling glow-in-the-dark petunias? It's a firefly.
Yeah.
Yeah.
Yeah. And they went through like a sort of a rigorous regulatory process to make sure that the engineering that they did wasn't going to escape into something else. And whether or not that process is rigorous enough for like our values, like, the values of the FDA aligned there, right? To say it's rigorous enough for them, or probably the USDA, I think, for them. Yeah, I think this is like kind of like a big unknown. Like I was telling my cousin once that like, yeah, people should just release, like, I was thinking about like bacterial biosensors. Actually, there's this project someone did where it's like you can have like genetically engineered plants that like detect landmines, something like that, right? And you like sprinkle the plants everywhere and see them. But like that conversation about like why sprinkle those plants everywhere when we don't really know how those plants are going to interact with other things, I think that like those conversations need to happen, and they have to happen before you do the sprinkling of plants everywhere. I will point to other like big biotech things where we're interacting with the environment, like getting rid of dengue or malaria stuff by like spreading mosquitoes that aren't able to produce progeny, right? We do that. I know that there's like prevent certain types of bot flies that infect cattle. We like also spread like a bunch of flies, essentially like a biocontrol. I think those conversations are like interesting case studies that to bring into this community and talk about, because like if we're going to DIY some of these things, those conversations sort of have to happen first. Yeah. Yes.
Safety-wise, you talked about fume hoods, and those are either really expensive or really expensive, and you have to alter your infrastructure. Can you do some of the stuff you've talked about inside of like a still air box instead?
Yeah, still air box. I think it's a good thought. I was thinking still air box outside, right? Because like the outside is your ventilation thing, right? And the still air box is how you're preventing stuff from falling in. So that's what I was saying. Like, yeah, like I think there's space there to really like go down that path. But yeah, I haven't tried it myself. I haven't like fully thought it all through, but I think that makes sense to me. Mm-hmm.
There might be some techniques to learn from the mycology community that grow their own mushrooms. Are using similar equipment.
Yeah, I mean, that's actually part of like our Biotech Without Borders. Like we have folks growing mushrooms in the space, right? And like they bring their own tool set and understanding, and it's nice to collaborate with that side of things. Like, yeah, it really is like there are some disparate threads of people working with the same technology, and like having people come together and think about stuff they want to build or like just share tips and tricks is like good. We're just going back to that, like, I would love to see more of this at Hope, right? Like, if you know people who are interested in talking about this sort of stuff, like, I feel like we should get in touch. Please get in touch. I got the 1 minute mark a while back, so I think, oh yeah, but it doesn't matter because I'm the last session of the day. Yeah.
So how long does it take, well, I mean, again, it probably depends on the species and stuff, but typically, how long does it take for you to kind of get a fully realized image? And also, how long does it take to identify?
Yeah, so the identification is like it's very like for industry. So it's like you can pay for the 1 day turnaround, like you can pay like out the nose for the 1 day turnaround, and then the cheaper version is like the 5 day turnaround. If I did it myself, then it's as fast as I can work. So probably it would be like as quick as overnight. Sorry, if you do it yourself, you're still reliant actually on one commercial service, and that's sequencing, because most people don't do their own sequencing. So it would be overnight to get the sample prepared, and then it would be whatever the sequencing company has as their turnaround, which is typically, again, it could be like as quick as 24 hours if you do it that way, or yeah. Oh, sorry, did you say something?
How long does it take for the image?
Oh yeah. To grow one of the images, it's maybe like for the naturally isolated palette, it took longer, maybe like 3 days for the growth to come up, and then as much as like a week in the fridge to get a really nice color. And then for the bacteria, the E. coli one, that's like 1 day to grow up, and maybe like a couple days in the fridge to get really nice color.
Yes. What additional encouragement that you would give to people who are hesitant into making the jump into biotech?
Yeah, I think.
Repeat that question.
Oh yeah, the question was, what's some encouragement that you could give to people who are hesitant to make the jump into working with biotech stuff? And I'll say that it's all around us already. We're already doing a lot of biotech stuff like on a day-to-day basis, like the choice to wear masks and like air ventilation things, working with chicken in your kitchen, right? Like that's like, you don't want to eat chicken juice, right? Like, you know, you have inside of you a lot of learned knowledge about working with this type of stuff, and like adding more bacteria into the mix. Yes, that's kind of expanding some of the risks, but you can read about it ahead of time and you can understand like how to do it. If you know how to cook chicken in your in your kitchen, like I think you know how to do this work. You just need the nice clean space, the space you can wipe down to do it. Like, because I was doing it in my kitchen for a while, right? And I had like a different surface that I took out and stuff. It was like too much work. I found a community lab that I could like do that work in. Okay. Thanks for coming out, guys. Have a good evening.